Please be informed that this program is being telecasted on YouTube channel of DGMS. You and your industry member can view it on DGMS YouTube channel. Meanwhile, we request all the participants please be seated in the seminar hall. All the presenters and their team is requested to please be seated on the right side of the dais. Our chief guest of honor have been arrived here and will reach in the seminar hall shortly. Namaskar and very good morning to the esteemed guests distinguished speakers, officials of DGMS, manufacturers, special invitees, and delegates. It's a matter of pride and privilege to be anchoring this national seminar on futuristic approaches to electrification and automation in mining industry, being organized by the Directorate General of Mine Safety, Dhanbad, under Ministry of Labour and Employment, Government of India. The usage of electrical equipment is an integral and core part of the hard rock mining cycle and involves considerable risk. It is important to adopt latest technological development in terms of enhanced safety, efficiency, and economy in mining operation. The National Seminar FAEA-MI 2025 will provide a platform for wider consultation and interaction between the various stakeholders like government regulatory bodies, the manufacturers, mine management, and the user industry through a process of wider deliberation and interaction. This workshop has been conceived and conceptualized by Honorable DG Shri Ujjwal Taha sir and Shri Ajay Singh sir, DDG Electrical, Dhanbad, to address safety issues for use of electrification and automation. In the day-long deliberation comprising of 4 technical sessions, 13 technical papers will be presented by distinguished speakers on the behalf of mining companies, electrification and automation industry, and pave future path for necessary legislative changes in this direction. With these words, ladies and gentlemen, I, Hemant Gautam, Deputy Director Mechanical, Central Zone, along with my co-host,
Tripti Maurya,
once again welcome you to the inaugural session of today's seminar, and we greatly look forward to hearing to the viewpoint of our eminent speakers.
Thank you, Hemant. On behalf of the organizing committee, we extend our heartfelt greetings to all dignitaries, delegates, paper presenters, and guests who have joined us from across the country. As Warren Bennis once said, leadership is the capacity to translate vision into reality. Today, we are privileged to have among us such visionary leaders who are shaping the future of mining and safety in India. With this thought, and embracing our tradition of Atithi Devo Bhava, I humbly request Shri M.D. Mishra, DMS Soma, to kindly escort our Director General Shri Ujjwal Tah to the dais. I now take the honor of inviting Shri Shyam Mishra, DMS DMRS, to escort our chief guest Shri Samiran Datta, CMD BCCL, to the dais.
May I also invite Shri Sagesh Kumar, MR, Director Mine Safety, to escort Shri Nilendu Kumar Singh, CMD CCL, to the dais. With great pleasure, I request Shri P. Damodar, DMS Electrical, to escort Professor Arvind Kumar Mishra, Director CSIR Simfer, and our esteemed guest of honor to the dais. And finally, I request Shri Somerajulu Saab to kindly escort Shri Ajay Singh Saab, DDG, Director General of Mine Safety and Chairman of the seminar, to the dais.
Now, we arrive at a special moment of this morning, the felicitation of our esteemed dignitaries on and off the dais. This felicitation is not mere a gesture of honor, but an expression of our deep respect, appreciation, and gratitude. To begin with, I humbly request Shri Ujjwal Tasar, Director General of Mine Safety, to kindly facilitate our chief guest, Shri Samiran Datta, CMD BCCL. May I also request Shri Ujjwal Ta to kindly felicitate our guest of honor, Shri Nilendu Kumar Singh, CMD CCL. May I again request Shri Ujjwal Ta to kindly felicitate our guest of honor, Professor Arvind Kumar Mishra, Director CSIR Simfer.
Thank you. I now invite Shri Ajay Singh Sir, DDG, DGMS, to welcome and felicitate our Chief Partner, Shri Ujjwal Taha, DG, DGMS. May I request Shri MD Mishra, Director Mine Safety Soma, to present a bouquet to Shri Ajay Singh Sir, DDG, DGMS. With great respect, I invite Shri Shyam Mishra, DMS, DMRS, to present a plant sapling to Shri R.T. Mandekar Sir, DDG, Northern Western Zone. Now I request Shri Ajit Kumar, DMS SEZ, to present a bouquet to Shri SS Prasad, DDG SEZ.
May I invite Shri Anil Kumar Das, DMS Region 1 Central Zone, to welcome Shri R. Meena, DDG Western Zone, with a sapling. I now request Shri Sanjay Gimidi, DMS EZ, to welcome to Shri Veer Pratap, DDG Headquarters, with a sapling. With great pleasure, may I invite Shri Niranjan Kumar, DMS Central Zone, to welcome Shri Supriya Chakraborty, DDG Eastern Zone, with a sapling.
May I request Shri D.A. Somyajulu, DMS Electrical, to kindly welcome Shri T.R. Kannan, DDG SCZ. Ladies and gentlemen, can we have a round of applause, please? Now, may I request Shri K.M. Reddy, DMS Electrical SEZ, to present a plant sapling to Shri Neeraj Kumar, DDG Northern Zone. Now, I request Shri P. Balakrishna, DMS Mechanical Central Zone, to present a bouquet to Shri P. K. Singh, DDG Mechanical DGMS. Now, may I request Shri Ratnakar S. Sir, DMS SEZ, to kindly welcome with a plant sapling of Mr. Manoj Agarwal, Director Technical, BCCL. And finally, I request Shri C. Palanimalai, DMS Central Zone, to kindly welcome with a plant sapling of Shri Sanjay Singh, Director Technical, BCCL. Ladies and gentlemen, let us acknowledge this moment with a round of applause for our distinguished dignitaries. Thank you so much. Let's start this event with the safety instruction. The seminar hall in which you are sitting is having 4 exits, 2 on the front side and 2 on the back side. In the case of any emergency, don't panic. Just get outside from this seminar hall and kindly get cluster outside the seminar hall near the Vikas Bhavan as a cluster point.
Ladies and gentlemen, may I request everyone to please stand up as we proceed with the ceremonial lamp lighting, a tradition that symbolizes the dispelling of darkness and the ushering in of knowledge and wisdom. As the flame is kindled, let us remember, light is the harbinger of hope and progress. May this light guide us through the discussions and deliberations of this seminar. I also request all the DDGs and DTs to please join the ceremony on stage. Thank you, sir. You can all be seated. As we officially begin the proceedings of this esteemed seminar, it is my honor to invite a leader whose vision and dedication has been instrumental in shaping this event. May I now request Shri Ajay Singh, Deputy Director General, Electrical and Chairman of the seminar, to deliver the welcome and keynote address.
Thank you, Tripti. Respected Chief Guest of today's function, Simran Datta Saab, CMD BCCL. Our respected guest of honors, Shri Nilendu Kumar Singh, CMD CCL. AK Mishra Saab, Director CSIR Simfer, and host of this seminar, respected Ujjwalta Saab, DG, DGMS. All the senior officers sitting off dais, all the various representatives, that includes manufacturers, users, MDOs, officers of this directorate, staff members, press persons, and all. Good morning to all of you. Actually, I am giving the dual responsibility, keynote address as well as welcoming. So I will not take much of time. We are actually running slightly behind the schedule, but still, I'll say just a few words. Actually, of late, if you see, there is a wide adoption of different type of technologies. To name few, is AI, robotics, LIDAR. LIDAR means light detection and ranging. This we call it IoT, Internet of Things, and so many other things actually. And personally, I feel other sectors, even non-technical sectors, means where directly technology is not used, something like hospitality sector. There also people have started using this robotics, all that. If you call for room service, now a person won't come, a robot will come to deliver your order. In India itself, there are many hotels which have adopted this. Then firefighting. If you see firefighting actually in a developed nation, if you see, persons are not directly exposed to the hazard. Now these drones are doing it, robots are doing it. So personally, I feel our mining sector is also flourishing, no doubt about that. But still, I feel there is a lot of scope to this adoption of different type of technologies. Still, our operators, HEMM is one of the major cause of fatality in according to our statistics. So their operators, they just due to one reason or other, this HEMM gets toppled or hit or something like that, and operators are dying. We have technology available worldwide. Just one example I am quoting, that's all, nothing else. So where we can use operatorless. There are countries where this operatorless HEMM is used actually. Not that this is something hypothetical. This is very much available. So are the various other technology. Or somehow, recently I had attended one Government of India's program where they demonstrated, Ministry of Health, they demonstrated one person sitting at remote location and carrying out the surgery using robots. So this is even in our Indian context, this is widely accepted. Somehow, personally, I feel we are somewhat in mining sector, we are slightly hesitant or we are lagging behind slightly. But this is the forum. This is the forum where we can, from almost all to 5:30, 6 o'clock, we'll be sitting, and all different type of, means from a regulatory point of view. If you have any issues, you can share here. That will record in the form of recommendation. Actually, DGMS now we are also very fast we are adapting to the changing situation. If you see the older people, the senior people, they can understand, but slowly we are moving towards self-regulation. And DGMS officers, we are now mostly in the role of, okay, as per acts, whatever our power is there, we have to exercise that is all right. But still, we are now more than inspectors, we are in the role of facilitator. So we are also adopting, and we are open to it actually. If anything you say today's workshop, this seminar, or at any point of time, DGMS is very open to accept your suggestions. I will not take much of time. I take this opportunity to welcome our guest. First and foremost, Samiran Datta Saab, CMD BCCL, who has taken time out from his busy schedule and came over here to grace the occasion. So I welcome you, sir, and at the same time I thank you also. जैसे कि मेरे को जानकारी मिली है, समरेंद्र दत्ता साहब का ये शायद लास्ट मंथ है सर्विस लाइफ का. He is going to superannuate. So again I take this opportunity to wish you and your family all the very best, sir. Good health and best success in future endeavors. I welcome Shri Nilendu Kumar Singh Saab, CMD CCL, who came all the way from Ranchi to grace the occasion. Sir, thank you very much, sir. We welcome you. I welcome Shri A.K. Mishra Saab, Director Simfer. उनसे तो हम लोगों की रेगुलरली मुलाकात होती रहती है, बातचीत होती रहती है, और जो भी मतलब पार्टनर ही है वो हमारे, क्योंकि उनके ही बेस्ड उनके जो टेस्ट रिपोर्ट्स वगैरह के बेस में हम लोग अप्रूवल वगैरह देते हैं. तो आपका भी बहुत बहुत स्वागत है सर. हम स्वागत करते हैं अपने सभी सीनियर ऑफिशियल्स जो भी सामने बैठे हुए हैं, जो भी डिफरेंट जोन से आए हुए हैं, सभी डीडीजीज, उनका भी बहुत बहुत स्वागत है. जितने भी हमारे मैन्युफैक्चरर्स हैं और यूज़र इंडस्ट्री के जितने भी लोग हैं, पब्लिक सेक्टर के जितने भी लोग हैं, सभी लोग जो आए हैं यहाँ पे हमारे आमंत्रण पे, वो सभी लोगों का बहुत बहुत स्वागत है. और भी कुछ जो अगर मैं मिस कर रहा हूँ, जो प्रेस पर्सन्स हैं वो भी आए, उनका भी बहुत बहुत स्वागत है. और हमारी डीजीएमएस की टीम है, जिन्होंने, मैं देख रहा हूँ पिछले हफ्ते 10 दिन से दिन रात एक कर दिया इस इवेंट को सक्सेसफुल बनाने के लिए. तो आप सभी लोगों का बहुत बहुत स्वागत और बहुत बहुत धन्यवाद. थैंक यू वेरी मच.
Thank you so much, sir, for your inspiring and kind words. Now, I would like to request Shri Nilendu Kumar Singh, sir, Chairman cum Managing Director, CCL, to kindly address the forum.
धन्यवाद जनाब. आपने मुझे शुरू में ही मौका देके मुझे कितना हल्का किया है, इसका एहसास मुझे ही है. आप लोग शायद थोड़ी देर में इसको महसूस कर पाएंगे. जहां बुद्धिजीवियों की जमात हो, और यदि आपको ऐसा लगे कि आप उनसे ज़्यादा बुद्धिमान नहीं हैं, तो पतली गली ही पकड़ लेना ज़्यादा बेहतर होगा. जो सब्जेक्ट है ये इलेक्ट्रिकल एंड जो मॉडर्न टेक्नोलॉजी क्या वे से हम लोग जाएंगे, उसमें मैंने देखा इटनरी में काफ़ी वक्ता हैं जिनको सुनने की इच्छा मुझे भी रहेगी. तो मैं ज़्यादा समय नहीं लेते हुए मैं भी कुछ पतली गली की ओर जा रहा हूँ. तो मैंने हिंदी को माध्यम चुना, जहाँ थोड़ा बल मुझे मिलता है और बुद्धि कम से कम उपयोग होता है शब्दों को खोजने के लिए. आदरणीय उपस्थित उज्जवल टा साहब, DGMS, आदरणीय समरन दत्ता साहब, CMD BCCL, आदरणीय मिश्रा साहब, डायरेक्टर CSIR सिम्फर, आदरणीय अजय सिंह साहब, डिप्टी DG DGMS. आज बहुत एक नया ही आयाम में मैं अजय सिंह साहब से मिला और मुझे ये जानकारी मिली कि साइकिलिंग के बड़े शौकीन हैं. तो ये एक अच्छी बात आज पता चली. तो जहाँ जाते हैं कुछ न कुछ सीखना चाहिए. मैं भी कुछ न कुछ सीख के ही जाऊँगा यहाँ से. मैं आपको कुछ बैकड्रॉप में लेके चलना चाहता हूं। मैं इस सब्जेक्ट में घुसना नहीं चाहता, मैं कारण बताना चाहता हूं ये सब्जेक्ट क्यों आज इतना इंपॉर्टेंट है। आपको मालूम होगा कि यदि बिजली की व्यवस्था पूरी देश की देखी जाए तो 2032 के आसपास 1200 गीगावाट का हम लोगों का एक टारगेट है पूरे देश में, जो एक कैपेसिटी होनी चाहिए। आज के डेट में यदि आप देखेंगे तो करीब करीब ये 480 गीगावाट के आसपास ये कैपेसिटी बिल्डअप है, जिसमें आधा जो है वो रिन्यूएबल सोर्स ऑफ एनर्जी वो अभी हासिल कर चुका है। ये एक अच्छी प्रगति है। अब बात आता है कि क्यों मैं इस टॉपिक की ओर जाऊं और क्यों ये टॉपिक इतना इंपॉर्टेंट है। तो आने वाला जो समय है उसमें आप हमेशा देखेंगे जितने भी कॉप समिट्स हो रहे हैं वर्ल्ड वाइड, उसमें इन्वायरमेंट को लेके बहुत चर्चाएं हो रही हैं और ऐसा माना जा रहा है विश्व पटल पर कि कोल इंडस्ट्री इन पर्टिकुलर, जहां से मैं बिलोंग करता हूं, शायद ये सबसे बड़ा गुनाहगार है उस इन्वायरमेंट के कार्यक्रम में। तो अब हम लोगों को भी एक सचेत होने की आवश्यकता है, जहां से हम दोनों चीजों को एड्रेस कर पाएं कि हमारे देश की ऊर्जा व्यवस्था में जितना ऊर्जा चाहिए उसको कैसे पूरा किया जा सकता है। उसके लिए कोयला एक अहम और एक सरल और सबसे सुलभ माध्यम है, जैसा आप जान रहे हैं। तो इसे अभी आगे आने वाले 25-30 साल तक बरकरार रखना होगा। दूसरा, इसको बरकरार रखने में जो लोग हे दृष्टि से इस इंडस्ट्री को देखते हैं, इस व्यवसाय को देखते हैं, उनको ये भी बताना होगा कि नहीं, अब ये व्यवसाय ऐसा नहीं रहा। तो इसके लिए यदि हम लोग डीजल की ओर से, यदि हम लोग इलेक्ट्रिसिटी की ओर यदि हम लोग जाएं, इलेक्ट्रिकल वेज में यदि हम लोग जाएं, तो बहुत हद तक इसको सॉल्व किया जा सकता। जहां तक अभी आप जान रहे होंगे, देश में काफी नई नई टेक्नोलॉजियां, नई नई व्यवस्थाएं ये लागू हो चुकी हैं और बड़े त्वरित गति से ये आगे बढ़ रही है। आज से 10 साल पहले कभी ये सोचा नहीं जाता था हमारे पर्टिकुलरली कोल इंडस्ट्रीज में कि कोई चीज ऑटोमेटेड होगा, बट अब हर चीज में ऑटोमेशन जो है ये ढूंढा जा रहा है कि किस तरह से ये ऑटोमेटेड इस वे में हो कि हमारा सेफ्टी स्टैंडर्ड्स ये बरकरार रहे, हमारा ऑपरेशनल एफिशिएंसी जो है ये जिस तरीके से ग्रोथ चाहिए वो होता रहे, और इसमें कम से कम प्रदूषण जो है ये हो, तो सबसे ये बढ़िया रहेगा ये ट्रांजिशन में। तो ये कोल इंडस्ट्री बड़े ही त्वरित गति से इस ट्रांजिशन की ओर बढ़ रहा है। अब लोग बात करने लग गए हैं R&D की, जो आज से 10 साल पहले बड़ा कम सुना जाता था। कोयला और R&D ऐसा बोला जाता था, आज बोला जाता है कि R&D में और क्या करना है। मैंने जहां तक सुना है कि ओबी से सैंड ये निकलना तो चालू हो गया, उसके बाद अभी FMC प्रोजेक्ट्स जो हैं ये आने चालू हो गए, फर्स्ट माइल कनेक्टिविटी, जिसमें बेल्ट कन्वेयर का इस्तेमाल होता मेनली, एंड रेल नेटवर्क का इस्तेमाल होता, जहां आप डीजल को मिनिमाइज करते यूज में और इलेक्ट्रिसिटी को आप मैक्सिमाइज करते, जो इन्वायरमेंट पॉल्यूशन को कम करने में बहुत मदद करता। आपने सुना होगा डिफरेंट न्यू टेक्नोलॉजीज में सरफेस माइनर आए हैं, जहां ड्रिलिंग एंड ब्लास्टिंग जो है ये इवेड हो रहा है और कम से कम प्रदूषण में साइज्ड कोल ये मिल रहा है। साथ में ये टेक्नोलॉजी ये भी मदद कर रहा है कि आप अपने ग्रेड को, कोयले के ग्रेड को कैसे मेंटेन रख सकते हैं, क्योंकि यदि आप कोई भी कोयला निकालते हैं तो खर्च उतना ही आता है यदि ओपन कास्ट मेथड से है, चाहे वो किसी ग्रेड का हो। तो ये हमेशा ध्यान रखना चाहिए कि यदि बेहतर ग्रेड का कोयला हम निकाल पाए तो खर्च उतना ही होगा, मुझे जो दाम मिलेगा उसका सेल के बाद वो ज़्यादा मिलेगा, तो एक प्रॉफिटेबिलिटी मार्जिन आएगी। अब यहीं तक ये सीमित नहीं है, फिर धीरे धीरे एक रिपर माइनिंग का ये आया, वाइब्रो रिपर्स जिसको बोलते हैं, वहां से बढ़ते हुए अब बातें आने लग गई कि AI एंड IoT, जैसा हमारे अजय सिंह साहब ने अपने उद्बोधन में भी बोला कि AI और IoT का आने वाले समय में बहुत प्रयोग होने जा रहा है। और जहां तक मुझे मालूम है बहुत सारे ऐसे इंस्टीट्यूट्स इसके ऊपर में R&D पर्टिकुलरली माइनिंग इंडस्ट्रीज के लिए शुरू कर चुके हैं। जब मैं ECL में था तो वहां एक चर्चा के दौरान मुझे ये भी बताया गया कि कार्बन से नैनो कार्बन बना के और मोबाइल का जो बैटरी है इसको बनाने की ओर भी CSIR ये आगे बढ़ी है। वहाँ दुर्गापुर में एक इंस्टीट्यूट बहुत अच्छा है मैकेनिकल का, तो उन्होंने इसको टेकअप किया है। वहाँ पे थ्रू AI एंड IoT ये ऑटोमेटेड स्प्रिंकलिंग की जो व्यवस्था है, जिसमें सही जगह पे सही मात्रा में पानी और पानी की बचत, एनर्जी की बचत सारी कुछ होती है, पैसे की बचत, इस पर भी बहुत तेजी से R&D एक सोनपुर बाजारी में ये काम हो रहा है। और अब तो यहाँ तक हो गया कि OB डंपिंग में क्या कोई रेयर अर्थ मिनरल मिल सकता है क्या मुझे, तो ऐसी भी अभी काफ़ी चर्चाएं शुरू हो गई हैं, जहां सिंगरैनी ने बड़े हाल फिलहाल में एक सफलता हासिल की है, जहां उनको रेयर अर्थ मिनरल में वो एक अच्छा परसेंटेज मिला है, और अब हम लोग भी पूरे कोल इंडस्ट्रीज में इसकी तहकीकात कर रहे हैं। तो मेरा केवल एक ही चीज कहना है कि जो देश की ऊर्जा व्यवस्था है इसको मेंटेन करने के लिए कोयले का क्वांटम ये हमारा बढ़ेगा देश में, इसको अभी कम से कम 10 से 15 साल बढ़ना है, फिर स्टैग्नेंट होना है, फिर बाद में देखना है कि किस तरीके से रीनेबल एनर्जी इसको, इस गैप को फिलअप करता है, और उसके बाद ये आगे बढ़ेगा। तो क्वांटम इज मस्ट। दूसरा है कि क्वालिटी से हमको उसको निकालना है, सो दैट कम खर्च में ये निकल पाए, जिससे ऊर्जा हमारी वो सस्ती हो पाए। और तीसरा है कि जो डाइवर्सिफिकेशन में हम जाएंगे उसमें ज़्यादा से ज़्यादा इलेक्ट्रिकल इक्विपमेंट्स का व्यवहार करें। जैसा आपको मालूम होगा, अभी लीबर, मैं पढ़ रहा था जस्ट 2-3 दिन पहले ही, लीबर एक कंपनी है जिन्होंने 240 टन का डंपर बैटरी ऑपरेटेड ये बनाया है। बहुत सारे जगह ऐसे हैं, कुछ कंट्रीज ऐसे हैं जहाँ कि करीब करीब 100 की संख्या में, 150 की संख्या में ऑपरेटर लेस, मैन लेस ये जो है ट्रांसपोर्टेशन हो रहा है थ्रू टिपर ट्रक्स। तो ऐसे बहुत सारी व्यवस्थाएं आने वाले समय में आने वाली है। मैं ज़्यादा समय नहीं लेते हुए आप लोगों को एक बड़े सद्भावना के साथ ये बताना चाहता हूँ कि आज का जो ये चैप्टर है यही हमारा फ्यूचर है इस माइनिंग इंडस्ट्री का। तो कृपया करके इस चैप्टर का जो भी डिलिब्रेशन हो उसमें हम लोग पूरी तरह से लुत्फ उठाएं। क्यों जरूरी था, मैंने इस बीच आप लोगों के बीच रखने का प्रयास किया। आप लोगों ने बड़े ध्यान से मुझे सुना, इसके लिए साधुवाद, धन्यवाद।
Thank you, sir. Your words about the Industry 4.0 and robotics will be definitely inspiring for the forum. Now, I would like to request to call Professor A.K. Mishra Sahab on the stage to address the forum, please.
Thank you very much. आप सभी को मेरा सप्रेम नमस्कार and a warm welcome. The most respected Director General, Mr. Ujjwal Sahab of DGMS, respected CMD Samiran Datta Sahab, BCCL, respected Sri N.K. Singh Sahab, Nilendra Kumar Singh Sahab, CMD CCL, respected Sri Ajay Singh Sahab, DDG, DGMS, all other distinguished guests from BCCL, from other industries, from DGMS, most of the respected DDGs are here in the hall, directors are there, deputy directors are there, and the academicians, some of the academicians, research scholars, industry stalwarts, and research scholars, and friends from press and media. Indeed, I am really honored, privileged to be here at the occasion of this national conference being organized by DGMS, which is on futuristic approaches to electrification and automation in mining industry. And this is very, very pertinent topic in the present context. Reason being, if you look up the economy of the country, we have become more than $4 trillion economy, the 4th largest economy globally, and poised to become the 3rd largest economy by 2028. That is what some of the studies do predict. And in achieving that, or if you look up the economic or growth of the country, or the GDP growth of the country, this is one of the largest globally right now. Somewhere around, hovering around, some of the studies say 6.5% or 6.3%. So if you look up, apart from the kind of hiccups, the kind of bumps we got in on the economic growth from the Western world, the tariff war, which was started by the Western world, still our economy is growing well, and the backbone of that economy is mining and mineral industry. All other industries, all sectors, if you look up, although in pure percentage form, if you look up, arithmetically if you look up, it hardly comes out somewhere around 2.5% of the overall GDP. But if you take up other allied industries which are dependent on mining and mineral industry, that is huge mammoth. And we cannot think of any industry, excluding agriculture, where we can grow in, which will thrive or which will survive or which will grow without mining or mineral industry. Even our handsets, mobile handsets, tablet, you talk of anything, even defense. The strategic sector in defense, as we had seen in the recent past, the Indo-Pakistan war, which was there, Sindoor operation, the defense technologies are dependent on mineral, and they do thrive on. So if we talk of all the securities which are required, let it be strategic or food security or water security or energy security, as Singh Sir was talking about the energy, we are dependent on coal, as most of us being in Dhanbad are from coal. And the coal is the one which is the driving prime mover for the economy, providing not only energy but for other industries as well. And there was some time back certain concerns on coal, but all the studies have confirmed, including Niti Aayog and PMO have confirmed that the coal will continue to be there, a prime factor for the energy security in the country. And so this topic becomes more so important, and that is one part of the mining and mineral industry, and I am really thankful to all the industry leaders who are here, who are contributing in a big way for the growth of the country. Similarly, DGMS being 1901 was the establishment, 1902 it started in. So its contribution of the DGMS as enabler, as facilitator, as regulator, as a guidance provider, because they are the one who have been providing guidance since last 124 years, which is a big contribution, achievement of the organization in the industrial and the country's growth. And what I consider for DGMS is like, father, जैसे घर में होता है कि जब बच्चा पढ़ता है और भाई ग्रेजुएशन के लिए जाता है तो पापा से जरूर कंसल्ट करता है कि मैं क्या पढूं, मुझे मिल गया एडमिशन, आईआईटी में तो एडमिशन हो गया, बट या तो मिनरल इंजीनियरिंग मिला है या मे बी मेटलर्जी मिली या व्हाट्सएवर इट इज, तो मैं, या इवन कंप्यूटर साइंस मिला है लेकिन आईआईटी धनबाद मिला है, आईआईटी बीएचयू मिला, शायद मेरे दोस्त को आईआईटी बॉम्बे मिल गया. सो सम कंसर्न, सो ही ऑलवेज कंसल्ट्स टू द फादर, एंड फादर इज द वन फिगर हु ऑलवेज प्रोवाइड्स हिम गाइडेंस आफ्टर कंसल्टिंग, टेकिंग ऑल द स्टेक होल्डर्स, उनके जितने फ्रेंड होते हैं, दोस्त होते हैं, कहीं कोई प्रोफेसर है, कहीं कोई इंडस्ट्री में है, and then he guides him ki which way you need to move on. And once he gets graduated, probably he gets in 1 or 2 or 3 job offers, or he may not get either one. So in either of the condition, it is one who provides him. Similarly, I look up that DGMS has been a fatherly figure who has been providing guidance to the industry, to the academicians and the research institutions, so far as innovation is concerned, so far as reform is concerned, so far as sustainability of the industry is concerned. So that is why it becomes so pertinent that at DGMS we are organizing this conference, wherein we will be talking about electrification and automation. And why should we talk about electrification and automation? Already Ajay Singh Saab has very, very excellently, brilliantly he has explained, as well as Singh Saab. Everybody knows, as the COP, the various COPs have been concluded. UNFCCC is there, wherein we need to, as a country, we do submit in our data, and then there is a global big concern of the climate change. And so the just transition and moving away from the traditional conventional energy sources to the renewables. That is what is being talked about. That's one aspect. But apart from that, the second aspect comes in the machineries which are being used in underground operations, wherein the confined conditions are there, and as we all are the professionals operating in mines, if you have noise, as you do have the conventional equipments, you do have noise, you do have fumes, you do have heat. These are the three major issues of the equipments being used in underground operations, apart from the hazardous operations wherein the equipment is being used. And with the electrification and automation is the way forward with which probably we will be providing a better environment and providing a safer environment, comfortable environment for the operators, workers who are working in the mine, which is our one of the primary responsibility. And because of the healthy or the situations wherein the occupational diseases or occupational health issues do come up, this will be eliminating up to some extent, provided we do take care of the other issues. So electrification and automation, these are two very pertinent topics, wherein from the hazardous operations we can move away, we can put in the autonomous equipments, but the complete automation, as most of the platforms we do talk about the automation, complete automation, wherein the manless mining being done. At some of the places globally, in the advanced world, it is being done, but probably in the country right now, we are not in that stage. Looking up the unemployability, looking up the other issues which are there. So in islands, yes, that is very much required. In isolation, yes, the various activities or various operations which are there, but it is the day when we need to go for indigenization of the electrification of the equipments as well as automation of the equipments. And this is the platform wherein DGMS as a big anchor point has brought in all the stakeholders, including the researchers, academicians, the industry operators, manufacturers, all stakeholders have been pulled in together to come up at one stage, one platform wherein the deliberations will be there. And I am really thankful to DGMS as well as the industry that they have picked up this topic and they have organized this conference, wherein throughout the day deliberations will be there. And I'm pretty sure that at the end of the day, the roadmap which will be chalked out for the future implementation of the electrification and autonomous equipments in the mining industry will be chalked out, and with this all the stakeholders will be benefited. So with this I wish this conference a great success. Thank you very much for inviting me. Jai Hind, Jai Bharat. Thank you.
Thank you so much, sir. Now, I would like to request our Chief Patron, Shri Ujjwal Taha sir, Director General DGMS, to kindly address the forum, please.
Good morning, everybody. Respected Samjan Datta Sahab, CMD BCCL, Shri Nilendu Sahab, CMD CCL, respected Director Shri A.K. Mishra, Simphar, my senior colleague DDGs, Director Technicals from BCCL, other senior officers from different companies, different representatives from suppliers, users and manufacturers. I am privileged to address before you in this platform about the today's program, which has our officers led by Sri Ajay Singh Sahab. This seminar is being conducted. They have taken a lot of pain. I congratulate them also for organizing this event and bringing all the stakeholders to one platform to discuss about different issues and participate in this seminar in a very interactive ways, so that what are the challenges we have faced earlier, what are the challenges at present, and what are the challenges and prospects we have in future. We can assimilate, we can discuss, and then we create a roadmap for the future. You see, mining, we know that always is the main backbone of our development, our civilization. Since long back, at least if you talk about the history of mining, it is so prehistoric, we have no particular period, but we can find the mention of mining in Kautilya's Arthashastra. But modern mining, we recorded that when this started, first in Raniganj coalfield for coal mining in 1764 or 68 something. Still then, this progress in the mining industry has been phenomenal. Now after independence, we are going towards self-realization, towards fuel requirements, our other material requirement, our development path, and for this mining and minerals are the driving force. We cannot think any industry other than agriculture, which now also dependent on mining to much more ways. We have to have mining and minerals. So we have to sustainable mining with the inclusiveness of all the stakeholders, so that our growth engine towards our vision Viksit Bharat, we can achieve as our Prime Minister's vision is. You see that if we look back few decades back, at least 3 to 4 decades, when we joined in the mining, it was only very primitive stage. Now we can think of only that time support system only. We are talking about only khuta, small, these chalks and props. When this transition was taking place from props to roof bolts, there was lot of resistance, lot of hesitation, lot of apprehension whether it will be going to, it will delivering any progress or it will deliver its objective. But slowly we build the confidence. So change management is one of the factor we have to accommodate. Only we know that change is the only constant in this dynamic world. So always change is taking place, and this last few decades change has been so faster that it is very difficult to keep space with this. Particularly mining, because whose gestation period is quite high, we find it very difficult to accommodate all the changes where it is taking place to accommodate mining. Now from the primitive mining, we are now talking about smart mining. Now at least we transition what India has shown, that production not only produced, now they have target for coal only more than billion tons, and other minerals if we consider the growth, our GDP's contribution for mining, direct contribution is only about, you say about less than 3%, 2.5 to something. But indirect contribution if we see, there is a huge, we cannot just determine, because it is dependent, all other industries are depending, whether it is electric vehicle, whether it is electronic industry, whether it is semiconductor industry, it is more or less dependent upon mining and minerals. So, but with this we have to see that mining is very hazardous and arduous. So, how to efficiently mine and without causing accidents and harming our, not only the human or the other environmental inclusions, particularly this forest or environment, other parameters, without damaging, how can we do? That is the challenge for in future. For this, we should have the collaborative approach where we collect together our users, suppliers, manufacturers, and DGMS as a regulatory body, and also with the help of academicians. We have to have future growth path, how we accommodate this change. And this topic has been selected quite rightly, because without energy, but there is a catch. Automation has no limit. But we have to keep in mind that we are a developing country. We have crores of people to feed. But this change should not come with pain, but it should be inclusive. Pain in the sense, we have to have a balanced approach, that employment versus this automation has a balanced approach, so that we can feed our peoples, we can generate employment for our youths, and we can at the same time our development path continues to grow. With this emphasis, as a DGMS, we have the Vision Zero. Vision Zero includes not only accident-free, lot of efforts have been put up by all the stakeholders to reduce accidents as well as to bring productivity improvement. But still we are not at that in the line with the developed countries. We are still having every year 30 to 40 fatal accidents only in coal mines, similarly in the metal mines and oil mines only very few. But not only that, we have no basis to calculate or to determine how our occupational health is performing. So in this area there is a very much lacuna. We are trying to catch it up with. That's why this regulatory mechanism, if is stagnant, we cannot progress. The regulation also have been taken very long leap. I think with this regulation CMR 2017, it has taken many scientific and systematic approach towards our modernization of regulation, scientific approach. And in this way, our approach has been the Atmanirbhar Bharat as our government of India's flagship program of Make in India, and to do the ease of business. We have taken so many steps as a regulatory body from e-governance. Even approvals we are talking about, conducting online examination, granting permission, and this has been not only rendered transparency, this also given us the speed and also human interface. Interaction has been reduced, so transparency it has increased, speed has been increased, and all the permissions and approvals are being dealt in a very efficient manner with transparency and speed, and all permissions are dealt and approvals are granted within 3 months, 90 days time. This has been very strictly being followed in this office. The recent change has taken place. Silently, there is a regime change, we can say, that we are still using electric detonators. Now, this shifting has been, we are regime change that electronic detonators we have to use in underground also. With this development of electronic detonator and electronic e-exploder, which our product was not there, but there was a pressure from the different quarters to grant the approval. The DGMS is an obstacle. But I have not seen that there is a DGMS, it has been an obstacle for the developmental path, but it has been a team, it has been a collaborative approach, it has always ensured, it has taken the lead, and it has been taken all the stakeholders in the platform for the growth of the mining industry in general and the country as a whole. Why? Because you see, the detonator's product was not there. We are telling that DGMS is not giving permission, but this is the record time I can say. Even within 7 days, this approval has been done. And maximum time it taken 28 days. For such a new product, they prepared guidelines, they prepared modalities, they prepared conditions, they discussed with all the stakeholders pan-India and developed the modalities for granting permission, and this permission, at least 4 companies have been given such permissions, and this credit goes to all the members of the DGMS team. I thank all them and also thank other stakeholders for this design change methodology, technology. Similarly, if we take any other technology which has come in India, we are generally we are unfortunate, though we are talking about technology development, but most of the mining fraternity equipments are from imported. But in this case also, DGMS has always taken the positive role and moved shoulder to shoulder with the users and suppliers and manufacturers to facilitate this adoption of this technology and machineries. For DGMS also, we have taken this approach, this modernization, automation, and this approach. E-office, e-governance, HRMS, already we are taking step. In this, towards this way, we have achieved this issuing certificate also we are doing online. There is no need for candidate to come here and wait for their certificates as earlier it is being done. Now everything is online, DGMS is doing. I think because this has been possible only with the help of you all people, all the stakeholders sitting in the dais, whose leadership has played a very vital role, and of the dais, all the people have made their best efforts towards this objective. I thank you all, and with this deliberation, I think you will take in very much active participation, and I constitute one team headed by Sri R.T. Mandekar, our senior Deputy Director General, and he will choose the member, a team, to enumerate the suggestions from different suppliers, users, manufacturers, if they are finding any obstacles or any improvement suggestions to be accommodated by the DGMS, which is render our ease of doing business or transparency or faster movement, faster approval. It will be very helpful for you all. So I request the organizing committee to select the members from different stakeholders, users, suppliers, and manufacturers, headed by Sri R.T. Mandekar Sahab. In the end of the day, they will tell some suggestions which will be improving our efficiency in the mining industry. With this, I have taken a little bit long time. Please pardon me. With this, I thank you all again. Jai Hind.
Thank you so much, sir, for your inspiring words. Now, it's time for Souvenir release. With the inspiration of our DG sir and DDG sir, Ajay Singh sir, the organizing committee has finalized a Souvenir which consists almost 30 technical articles on improvement of mine safety and latest technologies. Not only articles, but it is having all the presentations you are going to witness today. So now I would like to request all the guests of honor to kindly release the Souvenir. Ladies and gentlemen, can we have a round of applause for same time, keeping our theme go green and being environmental friendly, we are having a soft copy of this Souvenir. So may I request our chief guest to inaugurate the soft copy of this e-Souvenir. Thank you so much, sir. I hope you will like this initiative, and all the members, participants, presenters can have this copy through the barcode which is pasted outside. You can download a copy of the same. Thank you so much, sir. Now I would like to request Shri Sindhu Kumar Upadhyay, Deputy Director Electrical, for the introductory speech of Shri Simran Datta, sir.
थैंक यू गौतम। आदरणीय अतिथि, विशिष्ट अतिथिगण, देवियों और सज्जनों और प्रेस मीडिया से आए हुए प्रतिनिधि, आज के इस राष्ट्रीय संगोष्ठी के मुख्य अतिथि के रूप में भारत कोकिंग कोल लिमिटेड के अध्यक्ष एवं प्रबंध निदेशक श्री समीरन दत्ता का स्वागत करना मेरे लिए अत्यंत हर्ष और गौरव का विषय है। श्री दत्ता एक चार्टेड अकाउंट होने के साथ साथ 3 दशकों से अधिक का बहुमूल्य अनुभव रखते हैं और कुशल और पारदर्शी प्रबंधक हैं। दिसंबर 2021 में बीसीसीएल के सीएमडी का कार्यभार ग्रहण करने के उपरांत उन्होंने अपनी कंपनी का नेतृत्व राष्ट्रीय कोकिंग कोल मिशन और आत्मनिर्भर भारत के संकल्प के अनुरूप किया है। अपने सफल कैरियर में उन्होंने कोयला क्षेत्र की कई अग्रणी संस्थाओं में से महत्वपूर्ण पदों पर कार्य किया है, जिसमें बीसीसीएल और सीआरईएल में डायरेक्टर फिनांस तथा ईसीएल के सीएमडी के पद पर और सीएमपीएफओ में अतिरिक्त दायित्व निभाया है। उनके मार्गदर्शन में बीसीसीएल ने उल्लेखनीय प्रगति की है, जैसे रिकॉर्ड कोयला उत्पादन करना और अच्छा लाभ कमाना। इनमें से सबसे ऐतिहासिक बात यह है कि अपने इतिहास में पहली बार बीसीसीएल ने सभी संचित घाटों को समाप्त कर लाभांश देने वाली कंपनी का दर्जा प्राप्त किया है। श्री दत्ता का प्रभावी नेतृत्व एसीएल में भी स्पष्ट रूप से दिखाई देता है, जहां उन्होंने अपने कंपनी को उल्लेखनीय विकास की दिशा में अग्रसर किया है। महोदय, आपका दृष्टिकोण और उपलब्धियां पूरे खनन समुदाय के लिए प्रेरणा हैं और आज आपको यहां पाकर हम गौरवान्वित महसूस कर रहे हैं। धन्यवाद। जय हिंद, जय सुरक्षा।
Namaskar and good morning to all of you. Respected Director General of Mine Safety, DGMS Dhanbad. The light is burning, in fact, so the brightness is coming more. Coal burning? Oil burning, yeah. So, this is only a symbol of getting more urja, getting more energy. So when you have a fire inside, it is visible everywhere. That's the tagline. Director General, most respected Director General of Mine Safety, DGMS, DG Sri Ujjal Ta Sahab, Sri Nilendra Kumar Singh, CMD CCL, respected Professor Arvind Mishra, Director CSIR and SIMFAR, respected Ajay Singh Saab, DDG Mine Safety, who has been the backbone, as we have heard, about this seminar. All other DDGs, my colleagues, DT Manoj Kumar Agarwal, DT Sanjay Singh Saab, all DMSs, patrons, friends from press, participants, and all stakeholders from the industry and wherever, whom I could not mention the names separately, but who all ever are present here. Once again, I welcome you all and mera naman to all of you. I am indeed very privileged to be here, and I thank DG Saab for inviting me and facilitating me and giving me an opportunity to stand before you. We all know that as a regulatory body, the DGMS has been constantly behind us for improving our mining standards, for improving the mining conditions the people are working in, and leading the country towards a safer, greener, and more attractive mining environment. I thank him for his outstanding guidance that he has been providing. Today's seminar, when we are talking about this subject matter for which you are going to be sitting for over next 2 days, including today, the futuristic approach to electrification and automation in mining industry, it speaks volume. As we know, even a company like Coal India, when I joined, there was a total manpower of around 7,20,000 people. Today it is reduced to less than 2,30,000. The production has gone up from meager around 100 million ton to more than 800 million ton. So it has inversely, in fact, the ratio has been inverse. While we have been reducing the manpower, we have been increasing the production. It has all been possible because of adoption of technology. And this electrification and the electronics have been the major backbone in this modernization. So, we shouldn't say that sustainable mining, inclusive mining cannot be achieved without being, over dependent on the manpower only. It can be, and that's how the world is reshaping. People are now producing or manufacturing more of these equipments which will be replacing the manpower. So it's not that they will lose their job. They has to be repurposed. They have to be re-employed. We have seen in today's world that even deliveries, how the deliveries have been changed and has touched each one of our life. This delivery system, be it a delivery boy, be it a delivery equipment, has also employed so many people. So it is only a change in method that is taking place, and it will continue to do so. Today's tariff world, this tariff war or whatever you say, these are all for more efficiency, cost cutting, and of course giving better service and sustainable service to the people. So if we look, keeping these in mind, we will find this electrification and automation in mining industry, like any other industry, is very much essential. And that is exactly what we are looking for, we will be doing. When it comes to coal mining, as has been rightly told by your predecessors, today it is not only the coal mining, but all sorts of other minings also are going a sea change. Even in coal mining, Coal India a few years back had started an automation process in 7 to 8 mines, whereby entire mining system was digitized to achieve a better goal or better production. We are now completely online. SAP system is there. Right from the production to everything is now online, and it has greatly helped us to enhance our production line and the facilities. So basically we have to go for this sort of changes and look for more automation. We have heard, our predecessors who were mining experts, and I, not being from the mining industry, I was thinking what I should say at the end of the things. नीलेंदु जी ने बोला उन्होंने पतली गली से निकल गया, but मेरे लिए तो मोटा गली भी नहीं है, कहाँ से निकलूं? One or two wild thoughts I have, or maybe food for thoughts you can say. In fact, I was discussing the other day also. We are talking about electrification in the mining industry. We will have to look for this indigenization also, because we have now a policy of Make in India. So but we have practically found that when it comes to deploying some machineries to have a competitive world and to have a competitive participation in our tenders and supplies, there are occasions when one organization may have a license from DGMS about the equipment, but that particularly is not concurring to the Make in India policy. So how do we tackle that? I think that DGMS can take up and think about that, how to do that, because both are separately required when I am a procuring entity. So this can be one thing. Very lightly I was telling that mining is no more, because I come from a financial world, mining is no more confined to only minerals, metals or oils, but even to financial world as we have crypto. So crypto is also mined, whether some safety today, in fact Reserve Bank has also come out with certain safety guidelines for cryptos. So safety is required everywhere. I will share a very pertinent figure here for BCCL. Under the guidance of DGMS, as I mentioned, he has been tirelessly working for these things. BCCL could achieve a zero harm for calendar year 2024. But this cannot be only a one-year figure. It has to be sustained. We have to continuously endeavor for sustaining these sort of figures, because ultimately these seminars and all these things are for the good of the people, and unless we can make the life of the people good, these seminars will not have once again I will thank, without expanding further, I will once again thank DG Sahab for inviting you here, and thank you all for having a patient thinking, a patient thoughtful listening to my speech. Jai Hind, Jai Bharat.
Thank you so much, sir. It's time to show our gratitude and our thanks to all the distinguished chief guest of honor of today's national seminar. And now I would like to take permission from the chair for the conclusion of this inaugural session. May we, sir? Thank you so much, sir. One important announcement. We are going to have a 15-minute tea break and a bio break. And after that, we will again assemble in this hall with the session 1 of today's seminar. This session 1 will have 4 presentations.
These deliberations spark ideas that shape a safer, smarter, and more sustainable tomorrow. Let us begin this remarkable session with a presentation by Shri Saifullah Ansari, Director of Mine Safety, Science and Technology on DGMS at a glance since 1902. Sir, please.
थैंक यू मैम। नमस्कार। आज के इस शुभ अवसर पे खनन जगत से उपस्थित सभी स्टेक होल्डर्स, डीजीएमएस के सीनियर ऑफिसर्स, साथियों, प्रेस एंड मीडिया के पर्सन, सभी को मेरा नमस्कार, प्रणाम। इस 15 मिनट के दौरान मैं आप लोगों को ये खान सुरक्षा महानिदेशालय का जो 124 साल का जो हम लोगों का वर्क है, इतिहास है, उसमें थोड़ा सा कोशिश करूंगा कि आपको उसमें मूव कराऊं। साथियों, सबसे पहले अगर खनन के इतिहास पे जाए तो ये खनन का जो इतिहास है उतना ही पुराना है जितना कि मानव सभ्यता है। जैसा कि अभी आप लोगों ने सुना कि ये कौटिल्य और साथ में भी मिलता है, प्लस आप जो है ना इवन पाषाण युग में जाए, मोहनजोदड़ो सभ्यता में जाए, आपको कहीं ना कहीं खनन का, ये मिनरल का ट्रेसेस मिलेगा। लेकिन वो यही था कि वो कमर्शियलाइज नहीं था। उस समय हम लोग उतना ही ये धरती से निकालते थे जितना कि हमको यूज करना है। तो ये बहुत पुराना है। इट इज द evidences are time immemorial, but the first the recorded history of mining in India is date back in 1774 when the English company was awarded for mining in Raniganj coal field. And if you go to the non-coal sector, the first gold mine was started in 1880 in Digboi. And a gold mine was started in 1880, and the first oil well was drilled in Digboi in 1866. Just 7 years after the first ever oil well was drilled in the world, that is in USA, in 1859. If you go through the evolution of the safety legislation which the DGMS enforcing in Indian mining industries, in 1895 the government of India take the first initiative to frame the legislation, and same time in 1897 there was a two major disaster, first in the Kolar gold field killing the 52 persons, and followed by the Ghosh coal mine disaster in Balochistan killing 47 persons. These two disasters hastened the process of formulation of safety legislation, and the first mine act was enacted in 1902, and later it was superseded by Mines Act 1923, and this Mines Act 1952 was in force from 1st July 1952. Satyo, this Mines Act 1952 applies to whole of the India, and as we know, this Mines Act has been superseded, subsumed by OHS Code 2020, which is yet to be enacted. So these are the evolution of the safety law. If we go to the journey of DGMS, as we know in Constitution of India, Article 26, the safety welfare of person employed in a mine are the subject of the concern of the central government, and this objective of the Constitution is regulated by the Mines Act 1952, and this Mines Act is again administered by the DGMS, Director General of Mine Safety, headed by Chief Inspector of Mines, presently our respected Ujjwal Sir, the Director General of Mine Safety. साथियों, जैसे माइंस एक्ट जो फर्स्ट स्टार्ट हुआ 1901 में, तो देर कोई एजेंसी होना चाहिए जो कि इसको इन्फोर्स करे, इस पे एडमिनिस्ट्रेटर करे, तो उसीलिए गवर्नमेंट ऑफ इंडिया ने जो 1902 में 7 जनवरी 1902 को बोर्ड ऑफ माइनिंग इंस्पेक्शन कलकत्ता हेडक्वार्टर में बनाया. दैट इज द अभी जो हम लोग देख रहे हैं डीजीएमएस, उसका जो फर्स्ट जो स्टार्ट था 1902 में 7 जनवरी, बोर्ड ऑफ inspection, which was again renamed as the Department of Mines in 1902, and this office was shifted in 1904 and 1908 at Dhanbad, which was again renamed as Chief Inspector of Mines in 1960, and again restructured and renamed as Director General of Mine Safety since 1/5/1967. So we have the DGMS is serving nation since 1902. We are in 124th years, and on 7th January 2026, we will celebrate our 125th Foundation Day. These are the mandate of the regulation. As we all know, all the safety regulation, whether this is the coal mine, metal mine, oil mine, or mines tool, all these are administered by the DGMS, whether it is electricity rule. So these are the mandate of which are administered by the DGMS, all safety regulations related to either technical or health issues, training issues, emergency preparedness, welfare issues, electrical safety in mines. To fulfill the mandate, we have the vision. Our main vision, as we know, the occupational safety and health and welfare of person employed in a mine from the Constitution, it is the concern of the central government which is administered by the DGMS. So our vision is to attain the risk and hazard-free condition of work and welfare of person employed in a mine. And mission is to identify and reduce the risk of accident and diseases. That is the very important, the occupational diseases which the person is attaining while working in the mines, to identify the and reduce the risk of accident and diseases in and around the mine through development of suitable legislation, rule, regulation, standards, adequate measures to ensure the compliance, and awareness initiatives to inculcate the safety and health culture among the work person. This is the infrastructure of DGMS across the India. Because the mine sector applies the whole of the India, we have the 8 zonal offices and 38 regional offices, and zone is headed by the Deputy Director General of Mine Safety Mining, and region is headed by the Director of Mine Safety Mining. This is the whole picture. The whole India is covered by all different zone, northern in north, and south में southern zone Bengaluru, northwestern zone Udaipur, central zone Dhanbad, eastern part में Sitarampur, southeastern part Ranchi, and Hyderabad in southern part, south central zone. So all whole of the country is under the whole the mines in the country is under the jurisdiction of any of the zone or regions. This is the picture of the total mines registered. We have around 20,000 mine registers as on date in DGMS, and there are several mines in our unorganized sector which is not yet registered, and they are not the person employed in that mines are not benefited by the OHS rules and regulations. So it is one of the issue we have. The main, to achieve the mandate of the DGMS, we have our role and functions. The core function of DGMS is inspection of mines, which is, you all know that it is based on the risk-based and totally online inspection, web-based generation and web-based inspection, and total increased transparency of accountability of speedy disposal of work. And the second core function is investigation into accident, danger succession and complaints, etc. The major core function is the granting permission, exemption, relaxation, approval under different regulations, rules, development of standards, updating safety regulations, issuance of technical circulars based on our experience, and collaborative approaches from all stakeholders. We issue the technical guidelines in form of the technical circulars. Safety information dissemination is one of the core functions. And interaction for the development of safety equipment, material, safe work practices through workshop, seminar, for which we have, today we have assembled for development of the, at the end of the session, we will issue some guidelines by taking inputs to all stakeholders. Safety promotional, conduct of stage 2 examination to issue the stage 2 certificate in the, for the competent person who are working in the industry for the safety of person employed in a mine, and to for compliance of the mine sector rules and regulations. It is a major part. The conduct of stage 2 examination and safety promotional initiative includes organizing safety conferences, safety week, etc., promoting and safety education and awareness programs, workmen participation in safety management through workmen inspectors, safety committee, and tripartite review, we all know. And this is the other major role of the DGMS. DGMS interact with an advisory role to promote the cause of safety with the different organizations of industry and even government bodies also, like we have the government body in NRIM, in BIS, in different committees in BIS and Ministry of Coals and CSR SIMFERS. So we have the interaction and advisory role in the different organizations of the country. And another, if we see the beyond the OSH, we have the very important role of DGMS, DGMS intervention. DGMS facilitate through provision of safety protocols, guidelines, scientific studies under the Mines Act and regulation made thereunder, and implement appropriate measures to safeguard the railway, national and state highway, public roads, etc. Because we issue the guidelines based on the scientific study to work and sequence, what will be the sequence of mining, what will be the method of mining, so that the public structure is made stable. And again, the conservation of minerals, providing the technical guidelines and advice to operate the scientific and systematic mining, provide the specific competent persons based on the examinations. The major issue of the, as we know that the major issue of the OSH in mines is because the person is exposed to the a number of hazards like dust, noise, heat, humidity, vibration while working in the mines. And we all know that we have the 20,000 mines, and every year around we faces the 70 fatal accidents. साथियों हर साल जो है 70 एक्सीडेंट जो कोल और मेटल सेक्टर में होता है, हमारे 20 से हमारे 70-80 साथी नहीं रहते, तो ये मेजर इशू है कि कैसे उसको हम लोग जो है कम करें. Similarly, employment is 1 billion on daily average basis, and also the serious accident around 140 per year. So this is all this in backdrop, this the total issue of the safety is very complex, and it is the role of users and mining industry from the regulator side with the DGMS. We all make efforts to for the safety in mines. DGMS, because the DGMS started in 1902, we have the our experience from more than 100 years. We have the data of since 1901, and this is the accident data since 1901. Fatality rate per 1,000 person employed has come down. You see that this is the decreasing trend, but still there is still we have the 70 fatal accident per year, and this is because of the efforts made by by the regulator, the user, the manufacturers, and the Ministry of Labor. These are the efforts through which we are decreasing, there is a decreasing trend in accident. Sathiyo, the major, we have made the different efforts for ease of doing business of the industry. The major is that we have standardized the major approval system, as our DG sir told, that out of 60 approvals, the 37 number has been standardized by the general order. No special order is required. We have the online system of dealing approval permissions and online system of annual submitting annual return accident statistics and unified Samsuvidha portal for single registration and single return through the unified Samsuvidha portal, and all the information, latest updates are available in the public domain through the DGMS websites. And DGMS is also transforming from the perspective to the self-regulation regime through the scientific studies approach and the safety management system, safety management plan for operating the mines. These are the major reforms in the examination sector, that all the examination by the DGMS has been made online by CBT mode. And for the junior examination, the certificate is certificate in junior examination. The exam is conducted by the 5 regional languages also, that is in Bengali, Odia, Tamil, Telugu, Karnataka. Because our junior certificates, the person employed in the mines, these are the languages they appear in the examination. And we have the 24 zonal and regional center for verifications. And the major is of doing business, because we are seeing that we have the mining engineers just here. It is the women empowerment that the government of India has relaxed the condition of employment of women in mines, and now the women can be employed round the clock in open cast mine, and from 6 a.m. to 7 p.m. in underground mines. So these are the major breakthrough in the mining industry and driving safe regulation. Sathiyo, we have the DGMS, we have the social media platforms like YouTube and Twitters and also Instagram. These are the, because from the DGMS side, we request you all to please go through this, because a lot of the safety information and safety initiatives has been taken. It is uploaded in the DGMS. Please go and like all the platform. I request to all the stakeholders, please like and share this, because it is one of the our role is to disseminate the information. तो साथियों, अभी जैसा कि हम लोग देखें कि हम लोग इतने 1774 से स्टार्ट किए, 1902 से ये DGMS खान सुरक्षा महानिदेशालय बना, और हम लोग जो माइनिंग स्टार्ट किए बहुत ही प्रिमिटिव स्टेज से स्टार्ट किए. माइन में जबकि एक लालटेन लेकर के लोग जाया करते थे, मैनुअल लोडिंग होता था, और आज हम लोग जो FLP लाइटिंग यूज कर रहे हैं, मैनलेस माइनिंग यूज कर रहे हैं, कितना मैकेनाइजेशन हो रहा है. तो इस पूरे जो जर्नी है DGMS का, ये बहुत मैं कम शब्दों में आपको बताया, जर्नी में आप सभी का साथ रहा, और इसमें जो DGMS का जो रोल है, मैं आशा करता हूं कि जितने भी यहाँ सदन में उपस्थित है उसको अप्रिशिएट करेंगे कि DGMS का रोल कैसा रहा, मैंने गाइडिंग फॉर्म में रहा, या एक दूसरे से मिलकर के हम लोगों ने जो भी गाइडलाइंस दिया, जिससे कि आज हम लोग ये यहाँ पे सक्षम है कि इसको हम लोग कह पा रहे हैं कि हम लोग सिंगल एस से 4S स्मार्ट, स्पीडी, सेफ एंड सस्टेनेबल माइनिंग की जो कल्पना कर रहे हैं 4S माइनिंग की, वो आप सबों के सहयोग से संभव हुआ है. अंत में मैं सभी के लिए ये कामना करता हूं कि पूरा इंडस्ट्री जो है, सर्वे भवन्तु सुखिनः, सर्वे सन्तु निरामया, सर्वे भद्राणि पश्यन्तु, मां कश्चित् दुख भाग भवेत्. सभी सुखी हों, सभी निरामयी हों, सभी मंगल कार्य के साक्षी बने, किसी को कोई दुख न हो. धन्यवाद. थैंक यू.
Thank you so much, sir. Thank you so much, sir. Now, let's start today's technical session 1, and the theme of this session is electrical safety management and recent regulatory development, digitalization, IoT, AI, and remote monitoring in mine electrical networks. So let me tell you, in entire day there will be 4 sessions, and in totality we will present 13 presentations. And this session 1 we are going to have 4 sessions, 4 papers. So the first paper, for the first paper I would like to request Chairman Shri S.S. Prasad, DDG SEZ, to please come on the stage and please have, chair this session, please, sir. Can we have a round of applause for today's session chairman? Along with sir, first member, along with our chairman, is Shri T. Srinivas, DGMS Electrical, Western Zone. Member 2, Shri K. M. Reddy, DGMS Electrical, SEZ. आज के इस सेशन को चेयर करने के लिए हम आपका तहे दिल से आभार और स्वागत करते हैं. The first paper is going to be presented by Shri Ajay Singh, DDG DGMS, along with Shri Rupesh Mehta, DDMS Electrical, Central Zone, Dhanbad. Can we have a round of applause for the very first paper of today's session? Meanwhile, after this, the next paper is Mining 4.0 by Shri M. Armugam, DMS Mechanical.
सभी को नमस्कार. We are running late by almost 45 minutes. Okay. So earlier we planned it would be 15 plus 5, 15 for presentation and 5 for discussion. So now we'll try to curtail it. Okay. It should be anything around 12 plus 5. We'll start with
I think we should restrict the time for each paper to 12 minutes, and we'll ring a buzzer in 10 minutes. And after 2 minutes, it should be concluded. Already we are running short on time, and it is already 12 o'clock. It was to start at 11:15, so we'll save some time in the first session so that some time can be shaved in second technical session, and before lunch time we should complete both the sessions in time. So please start.
Thank you, Chairman sir. Respected Chairman of this session, and both the rapporteurs, DG Saab, and all the dignitaries present over here. With me is my junior colleague, Mr. Rupesh Singh Mehta, Deputy Director Electrical, and myself, Ajay Singh, DDG Electrical. We are going to present paper on a very pertinent topic, actually, very important topic. All of you are aware that earlier there was CER 2010, then in 23 it was repealed by CER 2023, and earlier it was IER 1956. So related to mines, anything CEA, Central Authority Regulation, Central Electricity Authority, CEA, whatever they make amendments based on our recommendation only, DGMS recommendation only. But in one particular regulation we are going to talk, it's very important regulation because it has got direct relation with human safety and equipment safety. In that they accepted our suggestion, recommendation, but only in a partial manner. It was not fully accepted, fully incorporated. I don't say they rejected, actually just to make it consistent with other sectors like metros, traction and other industries. They just repealed that. They just did not incorporate. So because of that, what happened? Now that particular regulation has become bit ambiguous and unsafe. We'll try to explain, and what is the way forward, what is the solution, we'll try to explain. Okay, I'll go in a very somewhat faster way. Okay, these are the table of content. Next, this is the regulation. Directly we jump to the regulation. This is the regulation that only relevant parts we are showing. You can see this talks about restricted neutral system of power supply, limited up to, you can see this whatever we have underlined, limited up to 10 amps by employing suitably designed so and so, so and so, so and so. But after this is our recommendation only, DGMS recommendation only, but after this there was one more para, whatever we had suggested to CEA, that they did not incorporate. Means that was something regarding capacitive current. What is the importance of capacitive current? That will explain. And how this particular regulation has become a bit unsafe. And what is the solution? As I said earlier, this previous. You can see here, this regulation recommends a blanket limitation. Blanket limitation, we did not suggest blanket limitation, but this now it has become a bit like you have to restrict within 10 amps, but the capacitive current into a very dangerous situation. We had suggested that capacitive current should be taken into consideration, but somehow they did not incorporate that. So with that, what happened? What is capacitive current? Next. Capacitive current is, as we all know, parallel plate capacitor we all have studied in 10th and 12th. Capacitive current, any parallel plate capacitor, C equal to epsilon A by D. Two plates separated by dielectric is a capacitor. So in our application, what is the capacitor? A cable. Cable, three power cores we know. Cable separated by insulator or dielectric. It's basically a capacitor. Overhead line, two conductors separated by air as dielectric. It's a parallel plate capacitor. So capacitive current flows all the time. We don't see it, but all the time capacitive current flows. Next, this is the diagram. Now what the limitation? Limitation is what? If the restriction, this 10 amps is mentioned, but if capacitive current in the system is more than 10 amps, what the risk is? Whenever there is single line to ground fault, what happens? Voltage of the network will spike, will shoot up. We don't know that. Our system voltage is say 6.6 kV, but that voltage may go to 15 kV, 20 kV, 25 kV, like that, depending upon switching conditions, all that. So with that, what happens? Suppose on that particular feeder, number of equipment, like transformers, lightning arresters, insulators, whatever is connected, they all of them may fail at the same time. That has happened. That has happened in the past. Next. Okay, so we are pursuing the matter with CEA. So we may find solution in the future, but by the time we don't find solution, what is the way forward? We'll try to explain. Next. Importance, its importance we all know. It reduces touch oblique step potential. हम लोग की जो भी humans, any fatality due to electricity is caused due to touch potential only. So we have to save people from any leakage due to electricity. This is a system for that actually. By using restricted neutral system, we reduce touch potential. Next, how we reduce? You can see here. First slide. 550 volt system, you can see shock voltage is 317 volt, but same 550 volt, the right side if you see, pointer hai kya? Pointer. That you see, the second, just we incorporated one resistor, NGR, neutral grounding resistor. With that, shock voltage reduced from 317 volt to 30 volt, you can see. This is the main advantage actually. Next. This is the, I'll not go much in detail actually, but majority of you are electrical engineers, so you can understand. This is the distributed capacitance. This is what? And it's a phasor diagram. Okay, next. This diagram you see, you just show. No? This particular left side, whatever phasor diagram, this one. This is for balance condition when there is no fault. Right one. This is the phasor diagram when there is fault. What happens? Neutral shifts, voltage of the LD feeder increases by √3 times, and there will be flow of capacitive current. This capacitive current, when the system is balanced, it remains 0, because IC1 plus IC2 plus IC3, they are vectorially equal and they cancel out each other. So that magnitude will be 0. The moment there is single line to ground fault, this comes into picture. This comes to life. And then you can see minus IC plus IB, this is the capacitive current when there is single line to ground fault. And in this particular diagram, you can see this is minus IC plus IB is very much lesser than IF. You just see the length of this vector. It is less. So it is within limit, it is safe. Next. Here you can see NGR by VNGR 5, 10, 15 we have shown. Na? So 15 it is shock voltage is 610. If we make it 10, shock voltage is 420. When it is we make it 5, it is 270 volts. So it decreases, but there is limit to it. And that limit is decided by capacitive current. Next. Here you see, here same diagram you can see here that 3IC, it's the resultant. I am not going much in detail. All of you must be knowing that. And then this red vector you see. In this particular diagram you can see that 3IC is very much greater than IF sin phi. That means system has become capacitive in nature. This should never happen in any of the application, mining or non-mining, anywhere. If this is happening, means we are inviting trouble. Or that's what has become in the present system actually, because we have recommended, this regulation recommend blanket reduction of, blanket limitation within 10 amps. If due to some reason in the system capacitive current is more than 10 amps, we are in for a big trouble actually. In some of the mines in the past, not distant, very distant part, in the recent past, almost all during this type of situation, almost all number of transducer units basically is a combination of transformer and breakers, almost all 10-15 transducer units in a particular mine failed. Fault is somewhere else, but some other equipment is failing. That's the dangerous situation. Next. Yeah, 1 minute. Now, next, previous. Now, two cases we have shown here. You can see VR. This is the case when capacitive current is within limits. Okay, IF is fault current. Fault current is greater than charging capacitive current. Then you can see the vector here. VR देखो, VR के ऊपर show करो. VR, this vector is lesser than VS. मतलब sending end voltage always, sending end voltage हमेशा greater ही होता है. जैसे receiving voltage में this impedance drop comes into picture, so we will have the receiving end we get the lesser voltage. But when your capacitive current dominates, when the system becomes leading, what happens next? You can see here. Now VR is greater than VS. Receiving end voltage has become greater than sending end voltage because of effect of capacitance. This is the dangerous situation. This at any cost we should avoid. And how to avoid, we'll try to explain. All this okay, we explained already. There will be voltage rise, selectivity may be affected. If this in the forthcoming slide we will understand. Next. Now, question is, okay, we all know how to measure normal current. In any power triangle we are familiar, है ना? Any power triangle, active power, reactive power and dependent power. Active power, how to measure? Active power is useful power. How to measure it, we all know. By using any current measuring device, we can measure it. But how to measure capacitive current? Next. This is the way. This is actually we have done in a particular mine. This is how we can measure this thing. We have to make it isolated neutral. Open grounding कर देना है. Open neutral कर देना है. Floating neutral. Deliberately we have to make it open neutral and create a fault. At some places if we create fault, then this capacitive current, this balance disturbs and capacitive current starts flowing into that. So this is how we can measure capacitive current. इसमें अगर आपको कोई भी doubt है, we can meet afterwards, है ना? Next. You can see here you see these are the 4 emanating feeders actually from one particular network. There are 4 outgoing feeders. Fault is there at one particular feeder, but this capacitive current flows through all because this is capacitance is present everywhere. So this capacitive current flows through all the healthy feeders also. So this R1, R2, R3, these are the basically relays, and but fault is there at R4, but even R1, R2, R3 also trips. And sometimes we don't know, there is no selectivity. Which particular feeder is faulty, we don't know because all the feeders trips concurrently. Next. recommendation. So I am coming to the recommendation part. इसको you also please, all of you please go through. In a leading KVR electrical network, if a person inadvertently comes into contact, where is the human danger? Already we explained, there will be voltage spike, है ना? If 6.6 kV network is there and the system is leading, then what will happen? He will sustain shock of 15 kV, 20 kV. That's the main danger. Human safety and equipment safety both. Next. Cascading failure of electrical apparatus, we already explained. What is our recommendation? Next. Therefore, it is strongly recommended that a proper system study be carried out to accurately how to measure, we already explained, magnitude of capacitive current, and only then should the design value of restricted neutral system of power supply be finalized in accordance with regulation 45.7. हाँ? Conclude है. At present, due to an absence of standardized policy regarding the design, इसमें क्या है? There are some fatalities that have also taken place because of this. In the past, when I was in Ranchi, I had inquired one. There was one fatality also. Next. Then we are considering, because there is a lot of anomaly actually as far as designs are concerned. Just to make it standardized, we are just thinking of bringing this under ambit of special approval. To be granted by DG CIM as per regulation 2083 of CMR and in accordance with so and so standard I6007 2023. This is it from our side. Thank you very much.
We can take 2-3 questions in just 2 to 3 minutes. Please raise your hand. Okay.
Hey, mic do yaar.
Good morning, sir. Myself, M.R. Rath from Tata Steel. Sir, if you remember, 3 years back, you have visited Noamundi Iron Mines and you have inspected and you have suggested actually this, what we have presented today. And as per your advice at that time, we have studied the capacitive current test in our 10 MVA transformer, and it was coming under nearly 4 to 5 ampere at the time. Therefore, the 50 ampere NGR we have converted to 10 ampere actually, that we are continuing in the 10 ampere NGR continuing, because capacitive current was 4 to 5 ampere in that case.
Then, okay, if it is 4, roughly we should restrict around 40%.
Okay.
If you are restricting 10 for 4 amps of capacitive current, you are anything around 10 amps, it is okay. But if it is 5, as you said, if it is 5 or 6, then we have to increase the value.
Therefore, again, I think actually, again, we should because 3 years back we had measured at the time. Now actually, I think actually I will again measure, suppose what is the capacitive current, and if it is more than required, then we
yes,
I will
compulsory.
Yes, sir.
Yes. Okay, thank you.
Thank you.
Anything? Anyone else?
Only one question, please.
Okay, if there is no question, then we will proceed further. Okay.
हाँ बोलो रुपेश बोलो.
See, if your capacitive current is more than your restricted current, then you have to design your NGR based on the capacitive current values. Suppose if it is more than, suppose it is coming 12 amperes or 15 amperes, then the restricted current you have to increase up to a suitable value designing upon your future loads. It can be up to 18 amperes or 20 amperes, so that thus over voltage and selectivity will not be lost. Okay.
For 10 it should be around 25. Okay. For 10 it should be anything around 25.
Sorry?
Explain 40%. We told now 40%. Roughly, thumb rule is 40% because you have to allow current to flow. है ना?
Generally, the earthfall values we took 40% of the current limits. So if it will fall, this earthfall value will fall above the capacitive current. Suppose your earthfall value is 4 amperes settings and your capacitive current is 6 amperes. So in every earthfall, your all feeders will trip. So that selectivity will be lost. And accordingly, you should select the value of earthfall settings if your capacitive current is high also in certain feeders.
Okay. Thank you.
Thank you.
Thank you.
Sir. Now I request for the second paper to Sri M. R. Mugam, DMS Mechanical, Southern Zone, Bangalore, to present his paper. The topic of the paper is Mining 4.0, Conceptual Approach Towards Automation in Mining Industries.
Am I audible? Time starts now. Good morning, everyone. First of all, I would like to say about myself. I am M. R. Mugam, Director of Mine Safety Mechanical. लगता होगा ना यहाँ मैकेनिकल आदमी क्या कर रहा है इलेक्ट्रिकल में, right? Actually, first for this I have to thank our respected DG Saab or DDG Ajay Singh Saab and DDG Kannan Saab for allowing me to come and present this one here. So excuse me, which one is up? Right. I'm not going to read the slides because the time is very less. I'm just left with another 11 minutes approximately. I was just going through, my lesser time, our disasters. So it is really lot many things are disturbing. हम लोग फोकस करते हैं कि एक्सीडेंट के बारे में, just like 5 बॉल हमने डॉट बॉल डाल दिया, 6th बॉल में चले गया सिक्सर. These things, the disasters are like this. So somewhere we collectively, everyone failed. Let it be any disaster. In the past 10 to 15 years, we had Anjan Hills, we had our Raj Mahal. We collectively failed them. Please click the first link. I've gone through the entire report, the Court of Inquiry report. I could find something interesting. Just scroll. Please focus on those block letters. Slowly go up. Some more. Because everything is there in your phone. The QR code has been already given over there because I don't have much time to go for it. So it talks about digitals, mine digitization. Please go up, move up. Talks about delay in decision making. Go up, sir. Some more. Now close it. The next one. This Anjan Hill disaster which happened way back some 10 to 12 years, 12 to 13 years before. There were no much digitization during that time. These are all by retired justice given to us. It talks about the telemonitoring, experts, the decisions. Just carry on rolling it. I intentionally blocked the name of a person who is deceased. I don't want to put it over here. It was blaming him. So these recommendations tells that we are based on our own experience, discretions, whatever the available informations. Please close it. So it's clear from this that we have not acted or reacted on time. समय लगा हमें, घटना घटी, रिपोर्ट होने में समय लगा, समझने में समय लगा, एनालिस करने में समय लगा, डिसीजन में समय लगा, इम्प्लीमेंटेशन में समय लगा. These slides are not mine. These are all taken from the Institution of Mechanical Engineers, UK. So nothing in this mine. It's only just a collected after my research. You can just go through. If we have, we will continue to have our disasters. These are all the latencies. I'll give you a few seconds. You can just go through. Gentlemen, trust me, I conducted fatal accident inquiries. To my surprise, the most unpredictable element is the human who caused the accident. So wherever there's a potential for disaster or for the accidents, we have to remove the man. Because the machines, most of the time, they do the function for they are programmed. How to prevent these latencies, bring down the disasters. I'm not talking about fatal accidents because I do understand if I prepare for or go for prevention of disasters, the prevention of fatal accidents causing 1 or 2 fatalities is a byproduct that will automatically happen. So that's why I am not going into the piecemeal solutions or an approach. The industry, the world is going elsewhere. You must have heard our chief guests when they were talking, they talked about the industry 4.0. We have to go for the automations. Maximum percents of electrical engineers, you know what's automation, and this is ISA 95 standard or IEC 6224. So it's having a 5 levels. This is the very basic gist of any kind of automation what we have to do that. Right? PLC, SCADA, HMI, AMS, these things are not new. You people must have heard. But unfortunately, these things are being done in silos or they are not connected with each other. This is being just a bit explained. I'll give you seconds to go through that. It totally talks about the sensors at the ground level. Don't rely on human and his judgment. At every level, let it be machinery, let it be telemonitoring, let it be strata management, let it be your dump management or slide or slope stability. Keep sensors. They are reliable. Now we talk about the automations. We have 2 kinds of automations. One is equipment automations, as it is happening there in the Rio Tinto. In Australia, if I'm not mistaken, it is almost 180 autonomous tippers, autonomous dumpers are being used, the heavy capacity, and around 20 to 30 blast hole drills. The man sits miles away and he operates it. So those things equipment. But with equipment automation, nothing is going to happen. You can just reduce only the fatalities, not the disasters. For this, you have to integrate entire business process with all these kind of automations and the further things which we are going to discuss and see. And once you are integrating these 2 kind of things, you have to cover the entire value chain of a mining. It's not that only it is restricted only to the mine. This is the entire value chain. It starts right from your exploration, whatever the data which is being generated, that's to be mapped digitally. Mine planning is to be done accordingly. Your drilling, blasting, loading, and all the systems meant for the inundation, gas, fire, waste dump, management. Sorry, unfortunately, I'm not a mining engineer. If I had been a mining engineer, I would have even focused more onto this because the disasters are mostly caused by all those factors, less by machineries and electricity. Accidents who happen with us, but disasters are always caused by these kind of the hidden things, and it's a very, very major challenge for us. And it has to include your human resource. कभी-कभी हमारा कोयला इंडस्ट्री में होता तो आदमी को भर्ती कर लो, बाद में देखेंगे उसके साथ क्या करना है. Gentlemen, if you have to go for a zero harm, we have to come out of the mindset. That's a big question when we talk about the fatal accident scenario. जब हमारा अंसारी साहब ने कहा, उस समय में ये था कि कोयला और मेटल का हम लोग कंपेयर करते हैं, but what about the oil? Oil almost negligible आपका, क्योंकि वो कभी अपने HR में कॉम्प्रोमाइज नहीं करता, कॉम्पनसेशन दे देता. मैं ये नहीं बोलता अब लैंड हाउस काम नहीं करता, करता है, बट वहां आपने कॉम्प्रोमाइज करना शुरू किया तो ह्यूमन इज अ मेजर सिस्टम, मेजर पार्ट ऑफ अ सिस्टम, वो फेल होता. वो अभी होलिस्टिक अप्रोच चाहिए, कैसे इसको रोकें. मुझे लगता है कि आज ये एआई वगैरह जिस तरीके से इंडस्ट्री 4.0 जो चलती है, अगर वो टेक्नोलॉजी हमारे पास कुछ साल पहले था, वी शुड हैव अवॉइडेड चासनेला, वी शुड हैव अवॉइडेड द महावीर खोलियरी, वी शुड हैव अवॉइडेड मेनी थिंग्स एल्स. 375 dying in one stretch. The mobile, I'll just rushing it up. What is an IoT? So big data, artificial intelligence, digital twin, blockchain, autonomous vehicles. This everything need to be brought in a single ambit, a single system. Simulations, cloud computing, telematics, drone technology. So unfortunately, we don't have any standard for this. We have for the industry 4.0. We have to go for a standard, either based on that or we have to have our own. This ISA 95 is a voluminous having 8 pods and running into hundreds of pages. Similar way we have to work. These are all the benefits. The main benefit from our point of view, this directed point of view, is bring down or eliminate the disasters. Subsequently, the accidents shall automatically get eliminated. These are all the challenges. We need to have a paradigm shift. मानता हूं कि हम ऑटोमेशन में जानने में आदमी कम हो जाएगा. मुझे याद है 80s में ट्रेड यूनियंस झगड़ रहे थे सरकार के साथ कि कंप्यूटर नहीं आना है. ट्रस्ट में जेंटलमैन, आज सबसे ज्यादा कंप्यूटर जनरेट किया है इस देश में, कंप्यूटर ने इस देश में जनरेट किया है. सो टेक्नोलॉजी आता, हम रीस्किल करेंगे तो हम हो जाएगा, हमारा काम कंप्लीट हो जाएगा उसी में. So we have to go for the paradigm shift. We have to go for minds will be there, minds will be safe.
Thank you, sir. I think one more question. Madam want to ask one question.
It's only a conceptual thing I want to put into our mind, that it is possible in mining industry. I know it's a difficulties.
Hello, I'm from CCL. I'm General Manager E&M from the coal industry.
Right.
So, sir, you said this was a conceptual approach. So it's not exactly a question. It's more on adding. It's like a comment. So, sir, you spoke about value chain management. So value chain management, that means at every point we have to monitor.
Exactly.
Okay. So in that, I think like 7 of our mines are being digitized in Coal India. So in mine digitization, that's exactly what we are doing. So because if everything is monitored, there is so much cloud-based monitoring, you know, everything. Digitization and automation. So that is what is going to lead to the entire value chain management. But that's what's Internet of Things. And predictive maintenance, which you did not speak of in case of equipments, mines or whatever. Predictive or prescriptive maintenance, that can only come when you have all the data, you know, cloud-based data monitoring, SCADA or digital twins and conveyors. So with this prescriptive management, we go on to Internet of Things. Industry, mining industry goes into 5.0. पहले तो 4.0 का ही compliance पूरा करना होगा, and then going to 5.0.
Exactly,
with prescriptive maintenance, which I think was not mentioned in your thing. That's what is going to enable your value chain management in mines and make it Industry 5.0. IoT is going to make it accident free. Predictive होगा तो accident को predict कर पाएंगे हम लोग better way में. So that's what's going to make it accident free. And as you said that computerization से manpower नहीं घटा. So इससे with just transition में when we are going to digitization and automation.
You please keep your
data is central.
short, madam.
I'm ending it,
because
sir.
we are
Data is
running
central.
out of time. If you have more doubts, you can contact him.
Thank you so much.
Madam.
Thank you, ma'am, for value addition to this. To understand, the paper shall not be more than 6 pages, and I cannot talk more than 12 minutes. So that's why I wanted to put it in a concept. I would have taken a day's class. Thank you.
If anybody have any questions, you can contact Mr. Armugam Sahab afterwards.
So in our DGMS website, my email ID is there. We can work together. I am also a student like you in Mining 4.0. Thanks a lot. Jai Hind.
Thank you, Armugam Sahab. And we proceed to the third paper. It will be presented by Sri P.K. Jha, Superintendent Electrical from UCIL. Topic is implementation of Wi-Fi technology for communication in 9 UCIL.
Technology in Narva Power Mines. Recently, last technology in Narva Power Mines. In 2024, we have installed this system in our Narva Power Mines, where we have installed communications between undergrounds and the surface. And for that, we have a different component that will describe in the later slides. Further, I will stress on the communication. Next slide, please. Next slide, please. Oh, okay, thank you. Why this mines communication is needed? As all of us know about this underground mines operations, that it is a very complex and it requires a fast and reliable method of communication, so that we have implemented this system, and with this fast and reliable method, so we can get a quick response over emergency conditions. We can have a voice communications among the employees that could promote the coordinated teamwork and the management of activity that's provide the safe operations and the resource management and the transmission of data. Along with the voice, we have also stress upon the transmission of data. Data from the tracking of personal stack, tracking of mines, vehicles, and as well as the gas monitoring and other features that we have included in this system apart from communication. Next slide, please. Next slide. Hello. Oh, from that. Okay. Yeah, this is the system architect, where you can see that we have a laid OFC network throughout the mines and also in the surface. And this OFC network is the backbone of this communication system, which provide the fast communications between the persons in the underground and persons at the surface. This is completely based on the Wi-Fi technology that we can discuss in the later slide. And the implementation of this Wi-Fi systems that we can see here, it's provide a seamless voice and video communications, fast transmission, text messaging. Main thing that the mobile handset that we have provided in this system, it gives you the video calling as well as the text messaging. That could not be possible in the earlier system where voice communication is limited. But in this system, we have provided a video calling, text messaging, and also we can do the GSM SIM based mobile communication with the Wi-Fi based mobile handset which is available in the underground. Means if I am standing here, then I can directly communicate to my mines, and my mines person can also communicate to me on my mobile system, just because we have linked this system with our exchange system so that it could be possible. Now the coverage of this communication, we have a link in the 4th level, 5th level, we have laid in the 7th, and up to 8th level we have laid down. And it is also, this communication system coverage is also available at the pumping station, Gisley, that is the important section, and all the substations. So that from the substation we can make a communications to our in charge and anywhere to the mines manager anywhere. And in the surface we have installed this coverage Wi-Fi communication system in the mines receiving substation, minder house, decline, mechanical workshop, every critical sections wherever we need to have a communication, immediate and fast communication. Oh, sorry. This is the OFC network that we have laid in the underground mines. This is 185 meter level, 230, 275, 315, and this is a ring topology we have maintained in this OFC laid. These are the 4 major systems that we are accommodated in this OFC network: audio, video communication, tagging, and gas monitoring, and last one is the CCTV camera. All in the OFC network. This is first audio and the video communication. Here we can see that the Wi-Fi mobile, that is a mobile handset that is using by the person, and it is working in the duplex mode, just like a mobile that we are using right now. And here what is happening, this mobile is sending the signals to the access point, that is the antenna. It's act as an antenna, that is a radio modem, and this access point transmit the signals to our server room, and then from the server room this signals is transmitted to the other located area wherever the information is required. This is the audio and the video, and also with the audio we can do also the video communication. Now the features of this mobile handset, in the half duplex mode you can do the push to talk and group calling. In the video and the text messaging can be possible from this mobile. Full duplex mode voice communication that you can see in the later video, where I will show you that the communication is happening in the underground and the person at the surface in the full duplex mode. Oh, sorry. Here in this mobile we have there is an emergency button. On pressing of this emergency button, red light of every mobile will start flashing with the siren and the display of the name of the person who pressed this button. And it's so that the person who has pressed this button is in requirement of emergency care. So, and every mobiles in the surface, in the underground, everywhere, so this siren will start operating and indicating that there is emergency requirement. At present, we have provide mobiles to dedicated mobiles to the officers, safety in charge, supervisor, mechanics, and electrician. It is in the first phase. After second phase, we will provide more. This is the voice communication happening in the vehicles. In the person is in charge of the mines, safety in charge. Here you can see the Wi-Fi access point that we are. Wi-Fi access point is a radio modem with an inbuilt omni antenna and a power on with the PoE. And this modem supports a dual Wi-Fi band of 2.4 gigahertz and 5 gigahertz. So it complies with the security and whatever is there. And the main thing is that the coverage range of this omni antenna is 80 meter. In underground mines, you can see that in the underground mines we have fixed this antenna at every location, and the range of each antenna is 80 meters. So we have installed at the regular 160 meters interval in underground mines, and also in the surface their range is wider. In the surface it has a range of 100 to 120 meters. Now the access point that is installed at the shaft entry that you can see at the top. Now the network panel which is connected to this access point. Network panel is consisted of the 8-port Ethernet switch, power supply unit of 110 volt AC, and it is installed at regular interval of 400 to 600 meters, which connect with the access points, readers, every critical equipment that's required for the Wi-Fi communications. Now the second system that we are incorporated in this Wi-Fi system is tagging and tracking system of underground vehicles and employees. Here RFID based tagging and tracking system has been implemented, and uses it promotes safety, productivity and resource management as written over here. Now the coming to the approach, how it's happened. So whenever the vehicles are coming in the proximity of the tag readers which is installed at a different locations, then it will sense that the vehicle is reached at that location, and until and unless the vehicle doesn't reach to the other tag readers, the history will be remain same, and whenever it will reach to the other reader, the history will be changed to the next location. So that in this way we do the tracking of the vehicles. Here is that in the vehicles we have installed here over the beside that operator, and that is the tag. Okay, sir, just 2 minutes. This is the tag, and this is the tracking system that we have in the software. We track this. The blue line is showing that the vehicle is there, and the red line is the tracking systems readers, RFID readers. Now this is the tracking systems software where we get the information where the vehicle is there, at what time, where it, and it is the employee movement screens. Now the gas monitoring system, all the noxious gases are checked at through the detectors here, and this information is sent back to the server. This is the screen of the gas monitoring system. At present we have located at 8 places. Now coming to the IP based CCTV cameras, we have at present 25 IP cameras right now, and it is installed at different location. And the screen you can see, this is the picture from the critical loading station, shaft, everywhere. From everywhere we are getting the cameras output. And here we are the control room. Here is the network monitoring system. Network monitoring system that I want to introduce, that this is the system to which we can access and can control and monitors the access points, CCTV camera, network of the OFC network, if any breakdown happen in the OFC network or not. So that can be seen from this NMS. And from this benefits we are getting lost And this is the network monitoring system. Can you see this red mark? This is showing that it is in a breakdown condition and has to be attended. So this system we can keep checking the access point is working or not.
Mr. Prakash, please conclude.
Yes, sir. Thank you. Just 2 minutes, sir. At the last, I just say to play a video that we are working in the mines. Excuse me. So video ke liye. A small video that we have made.
Rajesh, can we start the video? Rajesh and team, please. Video.
A small video that we have made in the mines just shows that communication is happening. Yeah. Here one electrical in charge in the surface and electrician in underground, and the communication is happening between them. You can see that a duplex mode. It is communication is happening in the duplex mode.
Okay.
It's finished, sir. Thank you, sir.
We can take 1 or 2 questions quickly. Please, mic दीजिए.
Yes, sir.
From my side, myself, Professor Sadhu.
Yes, sir, I know.
From IIT ISM Dhanbad.
Yes, sir.
Your technology, whatever you have explained,
yes, sir.
Is it applicable for underground gaseous coal mines?
We have not thought about it. We are working in the uranium
I know
mines.
that uranium and metal
I could
mines.
not say about
yes,
right now.
yes, yes. Okay, okay, thank you.
Oh, yes, sir.
This is Dr. P.K. Misra from CSR Simpler Dhanbad. So on what bandwidth you are working? Bandwidth
Bandwidth
of your Wi-Fi?
Wi-Fi is working on 2.4 gigahertz of frequency.
Frequency. No bandwidth.
That is that bandwidth you are asking. That is a free band. Numbers I not remember. That is it comes under the free bands.
And is it cost effective? Because it is working on OFC. So
Yes, sir.
cost effective.
यस एक्चुअली OFC में सर हमें सिर्फ एक OFC केबल ले जाना और एक पावर केबल ले जाना है, तो कॉस्ट भी बहुत कम है सर, और इसको एक्सपैंड करना इजी है सर इन कंपेयर टू द अदर, और इससे जो बेनिफिट हमें मिल रहा है, और इसको हम लोग फर्दर इसको एग्जैगरेट करेंगे, इसमें हम लोग PLC एकोमोडेट करेंगे, पंपिंग सिस्टम अंडरग्राउंड के सब स्टेशन कंट्रोल भी इसमें लेके जाएंगे, क्योंकि SCADA इज अवेलेबल देयर, वी जस्ट हैव टू प्रोवाइड अ PLC इन द सब स्टेशन टू टेक द सिग्नल्स. तो इसको जितना ये इनिशियल इंफ्रास्ट्रक्चर इसको जितना हम लोग एग्जैगरेट करेंगे, दैट विल मेक मोर कॉस्ट इफेक्टिव टू अस. थैंक यू सर.
Okay, thank you.
Okay, sir. Thank you.
Thank you very much. If there is some more question, please we may contact him after the this session.
हाँ एक मिनट हाँ साधु साहब.
Okay, okay.
साधु साहब, just to respond to your question, you asked this technology can be used for coal or not. It can be very much used, very well. They shall conform to relevant standard. आपको मालूम है 60079 part 0, part 1, part 11. The circuit has to be intrinsically safe, enclosure has to be flame proof. We can definitely use this.
गुड आफ्टरनून एवरीबॉडी. सर मैं सर धनबाद से MP इंटरप्राइजेज से हूँ सर. सर हम लोग कुछ इंडिजीनियस से डेवलपमेंट कर रहे हैं सर, मिनिस्ट्री ऑफ एमएसएमई से हम लोग कुछ सपोर्ट लेकर के कुछ नया नया सर डेवलपमेंट्स कर रहे हैं जो कि माइनिंग के लिए काफ़ी यूजफुल है। और सर मैं थैंकफुल हूँ DGMS का कि जिन्होंने हमको प्रेजेंट करने का मौका दिया। सर यहाँ पर सर बेसिकली हम लोग जो है आपका जो है दो टेक्नोलॉजी जो कि माइनिंग में यूज हो रहा है आपका, एक आपका इंफ्रारेड तो कभी कम ही है, मेनली कैटलाइटिक हम लोग सेंसर यूज कर रहे हैं गैस डिटेक्शन के लिए, हाइड्रोकार्बन सेंस करने के लिए। तो सर जो मैं यहाँ प्रेजेंट करने आया हूँ कि व्हाई इंफ्रारेड इज सुपेरियर देन कैटलाइटिक सेंसर, ये सर इसको हम लोग देखेंगे। कैटलाइटिक सेंसर जो सर हमारा है वो बर्निंग प्रिंसिपल पर काम करता है, जबकि मॉडर्न इंफ्रारेड सेंसर जो ऑप्टिक्स प्रिंसिपल पर काम करता है। ये सर आगे देखेंगे तो ये सर हमारा एक वर्किंग प्रिंसिपल है, इसका एक वीडियो है सर, वीडियो प्ले कीजिए प्लीज। ये सर जो है हमारा कैटलाइटिक सेंसर है जो हम लोग जो है बहुत समय से माइंस में यूज कर रहे हैं। आपका D6 मिथेनोमीटर हो गया या फिर और भी जितना भी नए इंस्ट्रूमेंट्स कैटलाइटिक सेंसर पर आ रहे हैं, उसमें सर आपका जो है क्या है कि ये जो आपका दो बर्निंग एलिमेंट्स है जिसमें आपका जो है हम लोग गैस डिटेक्शन के लिए यूज करते हैं। एक आपका जो है इसमें दोनों ही प्लेटिनम वायर है, लेकिन एक आपका जो एक्टिव बीट बोलते हैं, एक आपका रिफरेंस बीट बोलते हैं। तो सर जब गैस आता है तो ये जो सर आपका एक्टिव बीट है ये आपको जो है बर्न होता है, मतलब गैस को बर्न करता है, जिससे हम लोग गैसेस को सेंस करते हैं। और मीन्स R=R01 + α_T, तो जितना इसका टेम्परेचर राइज होगा विद रिस्पेक्ट टू दिस वन, उसको हम लोग जो है सर्किट में मेजरमेंट लेते हैं। और सर अभी नेक्स्ट ये सर जब कैटलाइटिक सेंसर जो दिखाया आपका, यही सर आपका जब इंफ्रारेड सेंसर में जाएंगे, प्लीज द वीडियो प्लीज। ये सर आपका इंफ्रारेड सेंसर है जो मॉडर्न टेक्नोलॉजी है। इसमें सर आपका क्या है कि दो आपका लाइट सोर्स अंदर में है और एक आपका फोटो रिसीवर है। तो सर इसमें क्या है कि दो लाइट सोर्स से लाइट निकल करके रिसीवर में सर रिसीव होता है। इसमें आप देखेंगे तो ये आपका एक आपका दोनों इंफ्रारेड बीम ही है, लेकिन एक आपका जो इंफ्रारेड बीम है वो आपका 3 माइक्रोमीटर वेवलेंथ का है, एक आपका 3.3 माइक्रोमीटर वेवलेंथ का है। ये सर आपका एक 3.3 माइक्रोमीटर वेवलेंथ का लाइट है और एक आपका 3 माइक्रोमीटर वेवलेंथ का लाइट है। तो सर जब इसमें जब गैस मॉलिक्यूल आता है तो ये जो सर रिएक्शन जो होता है इसका, ये सर जब गैस मॉलिक्यूल आता है तो आपका जो है ये आपका जो हाइड्रोकार्बन जो है आपका मीथेन मॉलिक्यूल फॉर एग्जांपल, तो उसमें जो एक आपका जो बीम है आपका 3 माइक्रोमीटर बीम इज नॉट एब्जॉर्ब्ड, जबकि आपका 3.3 माइक्रोमीटर बीम जो है एब्जॉर्ब हो जाता है। इस प्रिंसिपल पर ये काम करता है, जैसे फोटो रिसीवर में आपको डिफरेंस जो है मिलना इंटेंसिटी का शुरू हो जाता है। यस सर। और सर इसमें सर क्या है कि एक और वेरी इंपॉर्टेंट चीज़ दिखाना चाहूँगा आपको। ये जो सर आपका जो थोड़ा वीडियो फास्ट फॉरवर्ड कर देंगे प्लीज़। ये सर देखिए ये आपको एक आपका ये सर ये जो वीडियो दिखाना चाहूँगा सर, जो कैटलाइटिक सेंसर जो हमारा है वेल नोन आपका D6 मिथेनोमीटर है, उसमें हम लोग जो है दो गैस में चेक कर रहे हैं। एक आपका 2.5% मीथेन है, दूसरा भी 2.5% मीथेन है। सर दोनों गैसेस में चेक कर रहा हूँ इस इंस्ट्रूमेंट को। तो एक जो आपका जो ये सर ये आपका सर यस एक आपका ये सर गैस है आपका 2.5% मीथेन इन नाइट्रोजन है, दूसरा आपका अभी गैस है 2.5%, लेकिन ये सर आपका 2.5% इन एयर है। तो सर जब हम लोग इसको 2.5% मीथेन नाइट्रोजन देंगे तो जो सर रीडिंग है वो आपका इंस्ट्रूमेंट का क्या होता है वो दिखाता हूँ सर आपको। थोड़ा वीडियो आगे ले जाएंगे सर, थोड़ा वीडियो को आगे ले जाएं, थोड़ा और पीछे। हाँ सर, यस सर। ये सर अभी देखिए थोड़ा और आगे सर। ये सर अभी सर देखिए सर मैं इसमें गैस अप्लाई कर रहा हूँ 2.5% मीथेन नाइट्रोजन। मतलब सर अभी क्या है कि इसका रीडिंग जो है आपका, ये देखिए सर आपका जो रीडिंग है अभी आपका जो गैस अप्लाई किया हुआ है और बैटरी का पावर भी दिया हुआ है, लेकिन सर देखिए जो रीडिंग है आपका क्या होता है वो 2.5 तो पहुंचा, लेकिन उसके बाद जो क्या है वो डाउनफॉल होना शुरू हो जाएगा। मतलब वो 2.5 तक रुकेगा नहीं, वो बैक होना शुरू हो जा रहा है सर। ये देखिए सर ये बैक होकर के ये लगभग 0.2 मतलब ऑलमोस्ट 0 तक ये पहुंच जाएगा। सर पावर भी दिया हुआ है, गैस भी ऑन है, फिर भी आपका जो रीडिंग है वो सर आपका रिड्यूस होकर के 0.2 तक, मतलब ऑलमोस्ट 0.2 तक जीरो आ जा रहा है सर। और सर नेक्स्ट गैस अप्लाई करेंगे, थोड़ा वीडियो आगे ले जाइए सर। हाँ आगे ले जाइए और आगे सर। हाँ सर, अभी सर ये गैस अप्लाई किया तो इसमें जो है कोई डाउनफॉल नहीं होता, इसमें आपका कितना भी समय दें तो वो जो है आपका बैक नहीं होता, रीडिंग जो है स्टेबल रहता है। तो सर कहने का मतलब है कि दोनों गैसेस में अंतर था, एक में आपका नाइट्रोजन है, इसमें ऑक्सीजन नहीं है, इसमें आपका इन एयर है तो इसमें ऑक्सीजन है, तो इसमें जो कोई डाउनफॉल नहीं हुआ। मीन्स जो रीडिंग है कैटालिटिक सेंसर का वो आपका ऑक्सीजन पर डिपेंडेंट है। ये दिखाने के लिए सर ये वीडियो था। आगे जाता हूँ सर। ये सर ये आपका बहुत इंपॉर्टेंट चीज़ दिखाना जा रहा है आप लोग को। ये जो कैटालिटिक सेंसर, ये तो आपने देखा अभी कि ये जो है ऑक्सीजन पर डिपेंडेंट है। साथ में सर एक और चीज़ है कि ये जो बर्निंग है ये आपका बहुत ही छोटा एक टाइटेनियम वायर का बर्निंग है, जिसमें अगर वाटर मॉलिक्यूल चेंबर में आता है, वाटर मॉलिक्यूल अगर चेंबर में आता है तो ये भी जो है बर्निंग को डिस्टर्ब कर देता है, वो प्रॉपर हीट नहीं हो पाता। और उस केस में क्या है कि सबसे बड़ा दिक्कत है ये कि ये जो आपका नॉन फेल से बिहेवियर जो हम लोग को देखने के मिलता है। मतलब ये जो है कोई रीडिंग आपको कैटालिटिक सेंसर में नहीं मिलेगा। ये जो आपका जो रीडिंग जो है आपको जीरो मिलेगा कंडेंसिंग एटमॉस्फेयर में, जहाँ पर पानी है, वाटर मॉलिक्यूल्स है। अभी बहुत सारा माइंस हम लोग का डिग्री 2 डिग्री 3 है, उसमें ह्यूमिड एटमॉस्फेयर जो है, ह्यूमिड एटमॉस्फेयर में क्या है कि आपका जहाँ पर कंडेंसेशन हो रहा है, मतलब जहाँ पर जो शीशा में जो पानी ये जो भाप जो बोलते हैं सर, उस तरह का जमा अगर हो रहा है तो कंडेंसिंग एटमॉस्फेयर बोलते हैं। कंडेंसिंग एटमॉस्फेयर में सर कैटालिटिक सेंसर को जब हम लोग यूज करते हैं तो ये प्रॉपर बर्निंग नहीं होगा, और जब प्रॉपर बर्निंग नहीं होगा तो आपको रीडिंग भी नहीं मिलेगा, जीरो मिलेगा। ये मतलब नॉन फेल से बिहेवियर है कैटालिटिक सेंसर का, ये जो बहुत ही इंपॉर्टेंट चीज़ है। जबकि ये जो इंफ्रारेड सेंसर है सर आपका, ये आपका फेल से बिहेवियर है। फेल से बिहेवियर कहने का मतलब है सर कि कंडेंसिंग एटमॉस्फेयर में आपको जो है इसमें जो है आपको इंस्ट्रूमेंट जो है कुछ रीडिंग शो करेगा, जिससे मालूम है कि इंस्ट्रूमेंट फेल हो रहा है। तो सर ये इंपॉर्टेंट चीज़ है कि हम लोग जो है कंडेंसिंग एटमॉस्फेयर जो है उसमें करे क्या। तो सर उसमें एकमात्र उपाय है कि वहाँ से सैंपल लेकर के लैब में भेजना चाहिए, क्योंकि कंडेंसिंग एटमॉस्फेयर जहाँ भी होगा वहाँ पर सारा इंस्ट्रूमेंट जो हम लोग यूज कर रहे हैं माइंस में वो फेलियर हो जाता है, क्योंकि सेंसर जो उसका बेसिक एलिमेंट है गैस मेजरिंग का वही फेल हो जाता है। मोस्ट ऑफ द सेंसर का रेंज आप 90% 95% तक होता है। सर इंफ्रारेड वाले का 95% तक रेंज है, जो कि मोर है 90% से कैटालिटिक वाले से, लेकिन इसका ये फेलियर है। ये जो है कंडेंसिंग एटमॉस्फेयर में ये भी काम नहीं करता, लेकिन फेल से बिहेवियर के साथ ये काम करता है। इसके बाद सर वेल नोन फायर ट्रायंगल डायग्राम तो हम लोग जानते हैं सर कि आपको 3 चीज़ चाहिए, ऑक्सीजन, फ्यूल और इग्निशन सोर्स। जितना भी सर हम लोग का फ्लेम प्रूफ, इग्निशन और ये जो आपका IS और FLP बना है, सबका एकमात्र उद्देश्य है कि हम लोग को इग्निशन सोर्स को कंट्रोल करना है, क्योंकि फ्यूल और ऑक्सीजन तो नेचर डिपेंडेंट है, इसको हम लोग कंट्रोल नहीं कर सकते। इग्निशन सोर्स को कंट्रोल करने के लिए ये सारा जो चीज़ है हम लोग जो है फॉर्मुलेट किए हैं और बनाए हैं। और अभी सर देखिए हम लोग क्या कर रहे हैं कि ये सर देखिए ये हम लोग क्या कर रहे हैं कि इग्निशन सोर्स जो कैटालिटिक सेंसर के अंदर है खुद से आपको न सिर्फ कैरी कर रहे हैं बल्कि खुद से उसको माइंस में प्लेस कर रहे हैं। वो भी सर वैसा वैसा प्लेसमेंट नहीं, सीधा उसको गैस में हम लोग पुट करते हैं कि तुम जलो, हमको देखना है रीडिंग क्या है। तो ये कहाँ तक सही है आप लोग डिसाइड करें, क्योंकि इग्निशन सोर्स जिसके अंदर में ठीक है मानता हूँ सेंटर डिस्क से सेपरेटेड है, लेकिन अगर बहुत सारे इंस्ट्रूमेंट ऐसा भी आ गया है और है भी D6 मिथेनोमीटर बहुत कंडीशन खराब है, अगर ये सेंटर डिस्क में एक पाथ बन गया तो ये बस माचिस की तीली है और ये गैस है, ये खुद से आप जो है एक्सप्लोजन क्रिएट करेंगे। जैसे एग्जाम्पल एक मैं दिखाता हूँ, एक वीडियो है सर, वीडियो प्ले कीजिए प्लीज। ये सर एक वीडियो है सर, एक मूवी से लिया गया मूवी क्लिप एक्चुअली। इसमें सर एक पर्सन है, ये क्या कर रहा है कि बल्ब के फिलामेंट को यूज करके सर ये हीटिंग इग्निशन को करता है, मतलब इसके पास माचिस का तीली नहीं है उस मूवी में। तो ये सर क्या कर रहा है कि इसको बल्ब के फिलामेंट को यूज करके ये जो इग्निशन को क्रिएट कर रहा है सर। ये देखिए ये सेम चीज़ जो है आपका कैटालिटिक सेंसर के अंदर भी है, और एक नहीं दो है, और उसको हम लोग कैरी करते हैं साथ में, और उसको जो है खुद से हवा के साथ जो गैस का मिक्सचर है माइंस में उसमें हम लोग प्लेस करते हैं। ठीक है, मानता हूँ कि सेंटर डिस्क लगाए हुए हैं हम लोग, सेंटर डिस्क लगाए हुए हैं हम लोग, और इससे जो है सेपरेटेड है, लेकिन ये कहाँ तक सही है जबकि नया टेक्नोलॉजी आ गया है। यस सर, यस सर, यस सर, यस। इसके साथ साथ और भी सर कुछ कुछ है, हायर हाइड्रोकार्बन का इफेक्ट है, मतलब हायर हाइड्रोकार्बन का इफेक्ट वगैरह मैं दिखाना चाहता, लेकिन टाइम की कमी है। मैं उसको सर ये देखिए आपका जो इंफ्रारेड सेंसर का रिस्पॉन्स है हायर हाइड्रोकार्बन के लिए वो हायर है, होना भी चाहिए क्योंकि हायर हाइड्रोकार्बन इज मोर डेंजरस टू मीथेन, और ये जो कैटालिटिक का रिस्पॉन्स है वो लोअर होता है विद रिस्पेक्ट टू हायर हाइड्रोकार्बन। मीथेन का 100 में 100 है, प्रोपेन का 67, ये रिस्पॉन्स कम हो जाता है सर। इसके अलावा सर हम लोग ज़्यादा समय नहीं लेंगे आपका। ये सर आपका मैं ऑलरेडी बता चुका हूँ। ये सर ये यूएस कंट्रीज फॉरेन कंट्रीज में इसका रिप्लेसमेंट और एडॉप्शन दोनों हुआ है, इसलिए सर हम लोगों ने एक इंस्ट्रूमेंट सर डिजाइन किया है आपका इंफ्रारेड सेंसर बेस्ड। ये आपका मीथेन एंड कार्बन मोनोऑक्साइड डिटेक्टर है। ये सर बहुत सारा माइंस में चल रहा है और इसका परफॉर्मेंसेस सर ये डिफरेंट कॉलेजेस से ये सर है सर। सर इसके अलावा सर हम लोग और भी कुछ नया इंस्ट्रूमेंट डेवलप किए हैं। इसमें ये आपका एक आपका इंस्ट्रूमेंट है, नहीं थोड़ा फास्ट फॉरवर्ड कीजिए, आगे ले जाइए वीडियो को, हाँ और थोड़ा आगे, ये सर इसमें सर और आगे ले जाइए। ये सर हमारा जो 2 इंस्ट्रूमेंट है सर मिनिस्ट्री ऑफ एमएसएमई से ग्रांट लेकर डेवलप हुआ है, और थोड़ा आगे ले जाइए सर, इसमें सर आप और आगे सर जल्दी जल्दी सर फॉरवर्ड कर दीजिए। ये सर देखिए यहाँ रुक जाइए सर, ये जो है हमारा इंस्ट्रूमेंट है, इसमें आपका एक ही में आपका सर 5 गैसेस के साथ साथ टेम्परेचर, ह्यूमिडिटी, लाइट इंटेंसिटी और एयर वेलोसिटी एक साथ में आपका करने का सर ये डेवलप हुआ हूँ। अभी सिंपल टेस्टिंग में सर ये है इंस्ट्रूमेंट, और ये आपका एनेमोमीटर के लिए है सर। आगे कीजिए सर। और एक और इंस्ट्रूमेंट जो आप देख रहे हैं ये आपका मशीन माउंटेड मीथेन मॉनिटरिंग, जो CMR 2014 को कंप्लाई करने के लिए रेगुलेशन नंबर CMR 2017 रेगुलेशन नंबर 214 को कंप्लाई करने के लिए बना है सर। थोड़ा भी वायरिंग वगैरह करके ये टेस्टिंग में जाएगा सर। यस सर। इसके सर लास्ट एक इंस्ट्रूमेंट हमारा जो मिनिस्ट्री ऑफ एमएसएमई से एक ग्रांट मिला सर, ये माइनस रेस्क्यूअर सिस्टम।
सर कंक्लूड कीजिए।
यस सर ठीक है सर। ये सर बहुत ही एक इंटरेस्टिंग सिस्टम है सर। ये जो हम लोग को अभी जस्ट ये बन रहा है सर, बन के नोड वगैरह डेवलप हो गया है सर। ये क्या है कि जब माइंस में पानी भर जाता है या गैस के कारण पावर कट करना पड़ता है तो कोई कम्युनिकेशन नहीं बचता अंडरग्राउंड वर्कर को सरफेस से कम्युनिकेट करने। जैसे मुगमा कुलेरी में अभी 2020 में एक्सीडेंट हुआ, उसके बाद ही सर प्रपोजल मैंने मिनिस्ट्री ऑफ एमएसएमई को दिया था, तो वहाँ से हम लोग ग्रांट मिला और ये सर काम शुरू हुआ। ये सर वाटर प्रूफ IP68 चैम्बर है, इसका टेस्टिंग हो चुका है लगभग। हम लोग लैब टेस्टिंग किया है, सिंपल टेस्टिंग में जाएगा। इसको होने से क्या है सर कि हम लोग एक नेटवर्क बना पाएंगे इस तरह का पूरा अंडरग्राउंड माइन सरफेस का, जो कि पूरा वाटर फिल हो गया। अगर अंडरग्राउंड पूरा ये वाटर फिल हो गया फिर भी जो है ये सिस्टम जो काम करता रहेगा, और सरफेस में कंट्रोल पैनल में हम लोग को कोई भी माइनर कहीं बचा हुआ है तो वो नोड में एक बटन प्रेस करने से ही सरफेस में हम लोगों को पैनल में मालूम हो जाएगा कि कहाँ से एक्टिविटी हो रहा है। जो कि सर मुगमा में बहुत हम लोग को फेस करना पड़ा कि कहाँ पर माइनर फंसा हुआ है, हम लोग मालूम नहीं कर पाए थे। तो सर ये सब काम चल रहा है सर, हम लोग छोटा छोटा कुछ कुछ करने की कोशिश कर रहे हैं सर। थैंक यू सर।
Any question, please? थोड़ा क्वेश्चन को ब्रीफ में रखिएगा।
श्योर सर। सर मैं अभिषेक हूँ फ्रॉम NTPC। ये IR बेस्ड सेंसर का वन ऑफ द मेजर चैलेंज इज बिकॉज ऑफ द इंटरफेरेंस ऑफ द इलेक्ट्रॉनिक नॉइज। अब माइन एरिया में क्या होता है कि देयर इज ऑलवेज चांस कि वोल्टेज फ्लक्चुएशन हो जाए। अभी अजय सिंह सर ने बताया कि कैपेसिटी इफेक्टिव करंट से वोल्टेज चेंज होती है, बढ़ जाती है। तो एज यू टोल्ड कि आपने ये प्रोडक्ट कई सारे माइंस में भेजा है, तो जस्ट आई वांटेड टू नो कि हाउ इट्स कोपिंग विद दिस एनी फ्लक्चुएशन ऑफ इलेक्ट्रॉनिक नॉइज।
नहीं सर, अभी तक तो ऐसा कहीं से कंप्लेन नहीं आया है। हमारा PCCL मोनिटी में भी चल रहा है आपके नज़दीक में, और MCL में सर आपको लगभग 4.5 ईयर से चल रहा है। ऐसा तो कोई कंप्लेन अभी तक नहीं आया कि उसमें कोई फ्लक्चुएशन हो, और वेल परफॉर्म कर रहा है सर।
मतलब वोल्टेज से या करंट चेंज में कोई चेंज परफॉर्मेंस
नहीं सर, अंदर में ऐसा तो कुछ, अब क्योंकि वो सेंसर बहुत ही 20 mm डायमीटर का सेंसर है, वो छोटा सा है, उसको जो है अगर ऐसा कभी कंप्लेन तो नहीं आया सर, अभी तक तो नहीं आया है सर। वेल प्रूव है ना सर, चल रहा है सर।
हेलो जस्ट टू आंसर योर क्वेश्चन, अभी जो पूछा ना आपने कैपेसिटिव करंट, एक्चुअली दिस इज ए पोर्टेबल डिवाइस है ना, दिस इज ए हैंडहेल्ड डिवाइस, दीज आर ऑल मोस्टली बैटरी ऑपरेटेड, इज इट नॉट?
यस सर, हैंडहेल्ड डिवाइस।
बैटरी इट्स अ डीसी सर्किट ऑपरेटेड, सो वो कैपेसिटिव करंट का फंडा इसमें लगेगा नहीं है ना। दैट इज ओनली एप्लीकेबल फॉर AC सर्किट्स, दैट टू हाई वोल्टेज सर्किट्स। लो वोल्टेज में भी रहता है बट
more predominant in high voltage. So here question of this voltage fluctuation, all that doesn't come, because doesn't arise, because it has its own source, supply source, battery, है ना?
Yes, inbuilt supply source,
हाँ,
inbuilt
तो
battery based.
उसका वो voltage fluctuation इससे कोई relation नहीं है. ये बोलना था आपको.
Yes, sir. Okay, thank you.
Hello. Yeah, thank you. Now, I would like to invite session chairman Shri S.S. Prasad sir, DDG SEZ, for summarization of this session 1.
Okay. We are honored that we got the opportunity to chair this session. I, S.S. Prasad, and assisted by Sri T. Srinivas and Sri K.M. Reddy. First paper of this first technical session was presented by Sri Ajay Singh, DDG Electrical, assisted by Sri Rupesh Mehta, Deputy Director Electrical. And this paper was very relevant in the sense that it highlighted the very purpose of selection procedure of the restricted neutral system in mines. And this paper actually set the tone of the seminar, today's seminar, and there was illustration of many things, how reduction in shock voltage can be done. Then he explained different aspects and criteria which should be kept in mind while selection of the restricted neutral system. Similarly, second paper was also very much relevant to this session, presented by Sri M. R. Mugam, Mining 4.0 conceptualized approach towards automation in mining industry. So it is how we can think of this. We have to think of this because if we have to adopt smart mining. He explained very nicely as to why and how the future mining industry lies in automation, and mining industry as to why the mining industry is poised to take up and embrace the automation, because it is need of the hour. Third paper was presented by Sri P.K. Jha, Superintendent Electrical, UCIL, and it was about implementation of Wi-Fi technology for communication in Narwa Pahad mine, and he explained the many benefits which they are getting there, quick response over emergency condition, voice communication from underground workings, then easy data transmission, text messaging, emergency situation the person can press the button and he can get very easy help. Easily he can get the help. One can study the performance of this system and also the limitations also, and it can be implemented in other mines also. We can be careful in case of coal mine, gassy mines, whether the what are the limitations of this system, so we can just after study we can do that. And fourth paper was basically the use of infrared over the catalytic sensor, particularly in case of methane monitoring, methane detection equipments, and he highlighted all the benefits of the infrared system and what are the limitations of the catalytic sensor. He also emphasized on that. And as we know that the sensor is very key element in automation, so this paper was also very relevant, and all these 4 papers were very nicely presented. I take this opportunity to thank all the speakers, all the 5 speakers who took this pain to prepare and present their papers. I once again congratulate them all. Thank you.
Thank you, sir. The technical session 1 ends here. Now we are at the threshold of session 2. The theme of the session 2 is emerging trends in electrical systems for underground and open cast mine explosion proof and intrinsically safe electrical apparatus. The chairman for the session is Shri Veer Pratap, DDG headquarters. Member 1 is Shri M.N. Dwivedi, Executive Director, MCO Elecon. And member 2 is Shri P. Damodar, DGMS Electrical, Eastern Zone. Sir, you are please requested to take your seats on the dais. I would like to invite the paper presenter 5. The title of the paper is Efficient Transmission of Power for Underground Gaseous Degree 3 Coal Mines Without Electrical Contact. The paper is presented by Professor Dr. Pradeep Kumar Sadhu, IIT ISM Dhanbad.
So for this project, myself, Professor Pradeep Kumar Sadhu, co-workers, co-project workers, Professor Nitai Pal is present. Come, please.
Just a minute, sir, please. 1 minute, please. Welcome to the second session. I would like to introduce to the left Sri M.N. Dwivedi sir. He is from MCO Elecon. And to my right, Sri P. Damodar sir, DMS Electrical. So this session will consist of 3 papers, and each presenter will have only 12 minutes to speak and rest 5 minutes for discussion only. After 10 minutes, I will give you a signal. You will be having 2 minutes for concluding the paper. Please proceed.
Am I audible? So in this paper, actually the efficient transmission for power, it is like a magician. It is a future direction of research for gaseous coal mines, where the inflammable gases are there. My co-worker, Professor Paul is here. Another 2 research scholars, and another is under the operating the video multimedia operations. Here, basically this knowledge is basically we have inspired from this word that if you know this technology, there is no basically magic or that. We can send the power through air. And here, shall I continue? Okay. So here that in this concept that if you know this technology, know the implementation knowledge, Swami Vivekananda has said, from this inspiration we have started this, the basic, these are all of you know, so we'll skip the environment of this. From here we'll that explain this, that this technology is already implemented in US, and the 10, 12 years, 20 years back they have implemented this thing. And we are trying to achieve more advanced. I shall show you the multimedia, whatever the system has developed by the IIT ISM Dhanbad researcher team, and whole systems. Basically this system is basic control that of winding transformer, it is nothing but the whatever the magic, through air we can send the power, and that all the switching is totally abolished. That you have known that in the case of electrical traction in Indian Railways, also in high-speed train, the pantograph system or contact touching, or in case of the underground haulage system, that trailing cables are there, and these trailing cables will be damaged due to the friction over the soil, uneven surface. It is not polished surface. So the power cable, which is trailing cable, which is movable vehicle, over this power will be transferred. If it is wirelessly transferred this power, so contact is not there. There is no make and break, electrical make and break. That is the main difficulty for this system. Electrical make and break will create the flashes, and this flash will ignite like your LPG or anything else inflammable gases which is stored in this. So it is like a detonator, it will blast. So this thing you can avoid in the gaseous mines also, the switching through newer technology. The IIT Dhanbad has granted patent over that, and here this the haulage system, this whatever the vehicles will move, no need of contact. Next slide, it will be clear that here you will see that whatever the loops are there, in this loop basically the current will flow. There is no make and break switch, and this is the advanced technology. And from here, this is the pickup, like the transmitter and receiver signal. It will pick up the current, and after that it will go to the vehicle, and this vehicle will move for the self propulsion. And this is the secondary side converter. There is a huge mathematical side also there. It is not so easy. That high frequency applications are required due to the AR core transformer. Basically we are habituated with the any transformer. It is basically the transformer, and it is the secondary of the transformer, and in between the primary and secondary there is no core. And whenever you abolish the core, so core loss is abolished. So only the magnetizing loss. So here there is no electrical flash over this. So these are the huge circuit which is implemented. Better I shall show you the practical side over the multimedia. In case of the vehicle, if it is very high vehicle, I want to transfer this power. There is a, like your mobile tower, repeater technology. And in behind this power, primary power will circulate here. Through air it will transmit in the repeater coil, and that repeater coil will transmit the vehicle side, the power transformer. Whatever the vehicles, in the vehicles the requirement is there, that power will be transferred. Here in behind this, so many mathematics I shall skip for the timing. The 3 coils are shown, so 3 by 3 matrix. Here the n number of coil can be produced. That means repeater coil, n number of coils. So this size of matrix, we will skip this mathematics. And these are the whole technology for the your system air gap, air core transformer. That means the vehicle transformer is this. And I want to show this, the how can you transfer this power. It is basically these magnetic fluxes will couple the secondary, and there is a loss. Now the technology has been developed here. The repeater coil is inserted, and in the repeater coil, whenever it is inserted, then the magnetic flux distribution is much more uniform, show maximum efficiency. If we take the 4 repeater coil, then almost it is uniform. And after that, this earlier technology, whatever the mathematical distribution modeling has been discussed, that is it is not fit for Indian environment. Our prime ministers are always saying that indigenous technology is required, that this technology, repeater coil technology, is not suitable for Indian environment in the surface road industries or maybe the underground mines. So here the another technology, it is developed by, the patent has been filed, and this thing that this gap, whenever it is more, we can manage over the frequency control as well as the diameter of this coil, whatever the uniformness, that whenever it has been started from this testing of the coil diameter, 5 centimeter coil, 10 centimeter, 15 centimeter, 30 centimeter, it is almost, we have tested up to 45 centimeter diameter coil, so maximum power with maximum efficiency we can transfer. So these are the coil width over the coupling coefficient. Coupling coefficient is very important parameter for the wireless power transfer, and basically the touch, whenever the catenary or maybe the pantograph is there, or like your metro rail, the hanger is there, so that coupling coefficient is 1. But the wireless power transfer, it will never achieve the 1, like your power factor, that always less than 1. So here the efficiency in the lab testing, we have achieved up to 80%. So we'll just run the video that YouTube, it has been cited, it has been given, uploaded by Government of India, DST, as well as the IIT ISM Dhanbad. Just skip this video as because time management is required. Actually who have the interest over this new future direction, you can open in YouTube video link. IIT ISM Dhanbad has developed this wireless power transfer for this vehicle. So just keep a pause. You will see that there is a gap, there is no electrical connection wire over this trolley, and it can transfer this. The lab testing bench, already the 2.2 kilowatt power we have transferred efficiently, which model already it has been developed, and now this is the fast stage model. Now the self-propulsion car is already that done in the laboratory. So here is the vehicle condition in the dashboard, what is the voltage, and here in the static condition, that whenever vehicle in static condition, then also you can transfer the power, as well as in dynamic condition. You just visualize this gap in the hardware setup. We have done this 1 inch gap, that means 2.54 centimeter gap. We have sent the power of 2.2 kilowatt. We can increase the power as well as we can increase. The DST has given this, the Ministry of Mines, we have sent this project that whenever we increase the ground clearance, that is main issue. So we have tested over that. So whenever the gap is much more beyond the limit, the power transfer has been stopped. And just keep this video for initial position. Another mode, you will skip this. Yes. So one after one, whenever from the transmitter coil 1 to 2, 2 to 3. So it will get this. This is the last 2 minutes. Okay. Okay. You will stop this thing. Okay. Who have the much more interest over this? If you write this, the wireless power transfer system developed by IIT ISM Dhanbad, so it will come. So these are the your site. In case of the Times of India also and Economic Times, already it has been reported. So these are the conclusion. The application of contactless power transfer in underground as well as your mining industries. Here the safety measures of the worker will be increased. The controlling can be done cumulatively with the help of contactless power transfer, and introduction of CPT in mine management is the need of the hour. So these are the references. Open for queries. If is there any question, you can ask. Please. Higher side of voltage. Yes, please. That we have tested in the laboratory up to this thing. Any voltage, it will be applied as, because this is the principle. Basic principle is transformer, air core transformer. So whatever the primary number of turns and the depends on secondary number of turns.
You have to depend upon the frequency also.
Yes.
Simultaneously, you have to have the frequency.
Simultaneously frequency, it is not so easy that it is plain transformer or plain conductor is used for making this thing. If you are always welcome. If you want to take this visit in the lab, it has been displayed, and at the time of executive development program, we have shown to the whole participants of CIL and subsidiaries of CIL, NTPCs, that so many things can be possible over this. Okay.
Okay, so it's done.
So this insertion of high frequency current is very difficult. That high frequency current we have tested over this, that is the 20 kilohertz to 33 kilohertz, but next object is up to 450 kilohertz. We have to increase this frequency. Okay.
Thank you.
Thank you, sir. और कोई question है? Just last question only, please.
This is useful for bulk power transmission, because whatever you are showing does not give me confidence that we can use it for.
Yes. So bulk power we can transfer. First of all, we have shown IEEE is our electrical engineering. Whole world is regulated from IEEE rules. Whatever the Indian electricity rules, that will be just modified with the tune of IEEE. Okay. So IEEE has already accepted this thing for the underground coal mines. And I have shown that how it is possible, the primitive things, then the modernization. So in the 50 Hz or 60 Hz also we can send the power. But there is a but, that how much gap we can deliver. If it is a just air core sliding transformer, so it is possible. And here in case of high frequency transformer, there also it is possible. We can send the power 10 kilowatt, 15 kilowatt. That this basically this power
have dominated the diesel powered mining HAMM has dominated the sector due to their robustness, fuel availability, and the proved technology. These vehicles are significant contributors to greenhouse gases, noise pollution, and high operational cost. So if you see here, this side I shown, sorry. So here if you see, so this is actually sector-wise greenhouse gas emission. So in that, energy sector is a major contributor. So it's almost 70.46. in this, mining and transportation is contributing 14%. So electrification is the various forms emerging as the key strategy for decarbonizing in the mining sector. Depending on the various type of mines, either open cast and underground mining, so there is different type of mining equipment is used. So if you take typical open cast mining, conventional diesel powered mining vehicles are like haul trucks, loaders, excavators, motor graders, drills, dozers and service vehicle. So these vehicles have proven reliability but suffer from high fuel cost, emission and mechanical complexity. At present, the available electrified powertrain for these vehicles is so diesel electric vehicles. Now actually regular dump trucks, if you see, so the major initially that is actually diesel engine driven, then that is connected to the torque converter, then from there it is going to transmission, from there it is going to axle. So a lot of actually moving parts. Now here, after diesel engine is directly coupled to the alternator, so which is producing the electricity, that electricity is directly given to the in-wheel motors, which is mounted in the wheel itself. So a lot of energy transmission is reduced and loss has been reduced in this. Now second type of vehicles are cable connected vehicles. Now so in mining, where are some type of equipment where there is a limited restriction for the movement, frequent movement is not required, that type of vehicles actually powered by directly connected electric cable. So like drag lines, rope shovels and electro-hydraulic excavators. For these vehicles, directly cable is connected from the overhead line to the machine, and machine is continuously powered with this cable. So then hybrid electric vehicles, where both electric and diesel engine both are used parallelly for better efficiency. Now trolley assist trucks. Now haul trucks, when it is working inside the mines, so here they are powered with either battery or diesel engine. But once after it is coming to the haul road, before going to the dump yard, so that will be connected to the overhead lines for charging, and as well as there's actually that movement power is used from the overhead line itself. Now last one, actually battery operated vehicles. So as of now actually small vehicles like loaders and tippers. So these vehicles are installed with battery and the electrical drive system. So actually what is the technology available right now for EVs? So for EV vehicle, major thing is battery energy storage system, electrical energy storage system, that is battery. Then electrical drive system. Then next comes is actually charging infrastructure. Okay. So here presently lithium ion battery technology is very much matured and used in automotive industry. So that can be utilized for the mining industry, also for big vehicles. But one problem with the lithium ion batteries is they are having more weight and having low energy density. So solid state batteries, which are having lighter weight and having higher energy densities under development. So this battery swapping system, so now if you are going for the module type batteries, so there is a provision for charging remotely, then when installing in the equipment itself. So this reduces the downtime of equipment for charging. If you come to the electrical drive system, so AC induction motor drives are well proved in mining industry. Presently it is used everywhere, like rope shovels and electro-hydraulic excavators is very much used, which can produce high torque and having higher efficiency. So during break-in time, whatever energy is generated, that can be used for charging the batteries. If you see the charging infrastructure, so there are two types of charging infrastructure. So one is actually static charging, and one more is dynamic charging when vehicle is in the movement. So starting charging system is you have to take vehicle to the charging station. There you have to plug and you have to charge it. But for dynamic charging is now, if you see the trolley lines, when vehicle is going to the dump yard on the haul road, so while moving itself, we can charge that vehicle. Okay, what are the advantages of the electrical drive system? So if you see here, as I explained earlier, engine is coupled to the torque converter. From torque converter it is a shaft. From shaft is going to the transmission. From transmission is a differential. From differential it is going to the axle. Then wheel. So lot of rotating parts are there. Okay, so and lot of wear is possible here. But if you see here, so this is actually diesel electric drive. So where engine is coupled to the alternator, from alternator through drive system supply is given to the motors which are mounted inside the wheel. So because of lot of reduction of the lot of movements, so variable components are very less and high reliability will be there and extended overall intervals. So as the motors are producing instant torque, so immediate higher operational speed is required and faster cycles can be achieved. So this gives the increased gradability also and better availability of the equipment. So what are the advantages? So advantages what we are getting because of the EVs. So if you are using BEV, battery operated electric vehicles or fuel cell electric vehicles, that gives almost zero emission. If you are going for the hybrid vehicles or trolley connected vehicles, that gives some reduction in the greenhouse gas emission. So improved air quality is achieved, so especially in underground mines. So operational efficiency, so higher torque and faster acceleration is possible. Regenerative braking reduces the wear of the mechanical brakes, reduces downtime due to fewer movement parts. So low fuel cost and maintenance cost is the advantage for the user also. Lower noise and vibration is related to safety and comfort. But what are the challenges? So battery technology, even though it is matured, but for high-end equipment like 20 kilometer excavators or 200-ton dumpers.
2 minutes more.
Yeah. 20-ton dumpers. So 200-ton dumpers. That actually very huge battery capacity is required. So that will increase the weight of the machine as well as the energy consumption also. So charging infrastructure. So anyway, so most of the coal mines is having a power plant nearby. There is no issue with the coal mines. But problem comes with the remote mines where mineral excavation is happening. So there they have to, they require high capacity grid, which requires high charging station and high initial cost also. So operational challenges. Harsh environment at the mining. So that drains the battery more. So high initial cost is required for the new fleet as well as the retrofitment of the electrical drive for the mining equipment. So here I have taken simple case study. So where 200-ton dumper. So there 4 varieties are possible in powertrain. One is diesel powered directly. So when compared to diesel powered, so diesel electric version. So that reduces the CO2 emission by 15%. If you are going with the trolley assisted system, then that reduces the CO2 by 50%. And if you are going for the complete battery vehicle, battery operator, then it will be giving zero emission. 20 cubic meter shovel, rope shovel. So typical 20 cubic meter excavator, it actually operates with a 1400 HP engine. So if per year if you are operating that machine for 5,000 hours, per hour it consumes 2 ton liter. The total diesel consumption is 10,50,000. So if each 1 liter of diesel produces 2.68 of carbon. Okay, so that given actually per year that mechanical equipment gives 2,814 tons of CO2. The same electrical operated one consumes gives 625 tons of CO2. So where is 180 tons CO2 reduction is there? So what are the future trends? So integration of autonomous driving with electric fleet. Second is renewable energy using for the charging, and development of modular battery packs for easier maintenance, and greater adoption of hydrogen fuel cells for ultra heavy duty applications. So this avoids the charging infrastructure. These are the conclusions. So electrification of mining vehicle offer transformative pathway towards cleaner, more efficient, safer mining operations. The next decade will likely widespread deployment of electric mining fleet for both environmental efficiency as well as economic efficiency. Thank you.
Okay, thank you. Now session is open for questions, please. 3 questions, quickly, please.
Sir, 240 ton dumper. So if we calculate that motors energy, if you consider 630 into 2 kilowatt motors we are using, induction motors. Okay, so if you consider the average power requirement 800 kilowatt, then per hour, so 800 units required. So at least 4 hours of operation if you consider that 800 kilowatt. That is the minimum requirement for continuous 4 hours of operation. So after that, availability of equipment, if you are charging it continuously, so while regenerative braking time or when you are connecting to trolley system, then have 50,000 liters of diesel, so you are using per year. And the electricity, if you see that 750 kilo units into 5,000, it's coming around actually so 20,000. Okay, the unit price for you is very less. So definitely there is economic. So much of liters of diesel you are saving.
Okay, thank you. I think more discussion could be made in lunch session during. Okay, thank you. Now for next paper.
Yeah, thank you.
Yeah, for next paper, I would like to call Srimati Nandini Chakraborty, Managing Director, Mineline India Private Limited. The topic of the paper is Mass Production Technology, Digitization is the Way Forward. Ma'am, please.
Wait, I have to tuck this in somewhere. Good afternoon, everybody. Good afternoon to Chairman, rapporteurs, my friends and peers on the off the dais mostly. I know I stand between you and lunchtime, so I have to make it really brief. But I cannot start this session without acknowledging Sri Ajay Singh's contribution as well as that of his dedicated team, who has made it possible for all the stakeholders of the mining industry to come under one single roof. I think it deserves a very big round of applause for that. So I will, without much ado, since time is limited, I will start on my session. To introduce myself for those who don't know, I'm Nandini Chakraborty, the Managing Director of Mineline, and we have been in the industry for more than 45 years, and we are the market leaders for manufacturing electrical equipment for gassy atmospheres, as well as now we've diverted into some open cast, but our main forte is underground mines. So today's topic could not be more appropriate, because I'll take you through this journey of Mineline, where we had predicted this digitization at least 10 years ago, and we had started our work. So please, I crave your indulgence and your patience. I will start this session with acknowledging the contribution of my father, the founder of this company. Today happens to be his birth centenary. So as you see, he was served as an inspector of mines, the very ground where I'm standing on. He started his career there. And at that point of time, he was responsible for search and rescue operations in a number of mining accidents, mostly due to gas explosions. And he discovered that the main cause of these accidents were the fatalities due to gas, unsafe equipment, and unsafe spares, and lack of knowledge. So he made it his life's mission to give everything else up and create Indian products for Indian mines. So with a tribute and with acknowledging his contribution to the underground mining industry, I would like to start, and I hope I will be able to do justice. So the company overview. We are established in 1977. We're the market leaders, as I say. We manufacture more than 70 products. We give end-to-end turnkey solutions. And we have 4 manufacturing units in Calcutta and its suburbs. These are some of the foreign collaborations which we worked with in the past. We worked with almost every company in Europe who had to do with underground mining. And right now we have an ongoing technology transfer with Becker Mining. So that is pertinent. So we started our journey in 1993, and we developed our first 6.6 500 kVA transwitch unit, which ran the Kotadi drivage. So Kotadi drivage, and I believe that transformer is still somewhere around and is still running. Then in 2011, we made the 1000 kVA transwitches for RK Newtech shortwall, and as well as the Adriela drivage. In 2013, we made the entire Muni D16 SIM indigenous longwall electricals, and it's been running for the last 12 years very successfully. And from 2021 to 2025, we supplied more than 10 load centers to various projects. So what is the success? What is the secret to it? And why do people come to us? Because we have been able to take these problems, spin it on its head, and put it together into a deliverable module. So this is our load center. For those of you who do not know, any mass protection technology like longwall or a continuous miner or even a drivage project need multiple use of electricity for running its multiple machines, and they have to be working in tandem, they have to be working in sequence, and the machines essentially have to be talking to each other. So that is what we help to do. So this is what the load center looks like. It's a mega monster of almost 14 tons. And this one particularly is 6,600 volts on the primary side and 1100 volts and 8 drives on the secondary side. So these are the primary side and the secondary side are all, the entire equipment is flame proof. Now I'll run you through what makes this special. This is the transformer. The transformer design is such that the tank is of ovoid section, which means there is no accumulation of coal dust, there is no accumulation of water at the top. We have condensation discharge, which is common in any transformer, not through a tap, but through specially designed V notches, which are also tested at the Simfer laboratory. We have easy access, we have cooling baffles, and this is the transformer. So this is the basic equipment. Now I jump straight to the primary side, which shows you the digital display. It gives you real-time data with a data logger for all the voltage fluctuations. Many of you mentioned the voltage fluctuations in underground mines today. And it's a burning reality. The transformer winding, bearing temperatures, stoppage time, warning trips, unsafe parameters, even something accidental door opening or accidental presence of any other kind of hazard that could affect the production or affect the man is reflected on this. This is the secondary part. So where's the point? Anyway, the top shows you the screen, which is an actual HMI running on Windows OS, and it is operated by an external trackball and mouse, which is intrinsically safe. So if you want to access any of the drives, any of the 8 drives, you do not have to open the enclosure. You can just do it through the trackball mouse, which is external. And because it is intrinsically safe and it is tested and supported by the DGMS approval, it poses no danger. That eases your access to the transformer or to the load center itself. This is a real photograph from the screen. So what does the screen do? When you open the screen, it gives you these parameters which are showing you the various drives. The drives are mentioned on top. I don't know if you can see it. And only when all the little buttons are green will it allow the switching on of the drive. And you have at the bottom the software which you can select, either your energy meter or your trends, alarms, data log. I'll run you through some of them very briefly. So this is a typical data logger. This will appear on your screen if you want to, and only with a certain passcode access. How many times your machine has tripped, either on under voltage, over voltage, single phasing, bearing temperature or temperatures on any of the motors. So you have an actual 365-day data backup. You have data logging, data capture, voltage monitoring, fault analysis, fault records with actual fault values. It also gives you energy consumption, stoppage time, and it is constantly moving. It gives you real-time data on all your working sessions. So you know exactly what is going wrong where, and you can immediately go to the same problem during your maintenance time. You don't lose time in trying to find out what went wrong. So this is data capture, processing, and transmission to pit top is possible through special cables. But as you say, these things don't happen on L1. Unfortunately, we have to curtail our prices to such an extent where we are almost thinking, ye loha ka daam aayega ki nahi. So when you're looking for something that is high technology, we are always very happy to say this happens outside, this happens in UK, this happens in China. But we have to ask ourselves the question, are we prepared to pay the prices that come with it? So as a manufacturer, made in India, make in India is a very, very strong viability, is a very strong possibility, but only if we have to accept that this technology comes at a price. Okay, so this is again some more self-generated reports, and these are some of the machine availability which the machine itself has thrown up. This is data collected from the machine. So the machine doesn't lie, the software doesn't lie. So it will show you that these load centers have given you almost 97% machine availability, and one of our biggest customers, JMS, is here. They will be able to vouch for it, I'm sure. So this is what we're doing on the load centers for the mass production technology. I will also run you through some of our other products very briefly. We make onboard electricals for road headers, feeder breakers, and bolters. We also make the intrinsically safe audiovisual alarm, beacon, hooter, joystick. These are in operation. These are approved by the DGMS, and these are proven. These are, of course, our standard equipment. Thank you, sir. This is our compact station for the conveyor. This compact station not only runs your mega conveyors, which is your main trunk drive conveyors, but it also provides the auxiliary power for all your systems. One sec. I don't seem to be getting the hang of this. Anyway, so all your belt sway, zero speed, audio visual, everything, the power is generated from that compact station itself. More than 500 of these are in use in some of the biggest mass production technology mines. So we have circuit breakers. These are used in thousands. This is the backbone of our technology. We also make the lights, well glass light, bulkhead light, tube lights, and we believe that these are safer if they are used along with an isolator. Why? Because you can service any of the lamps, or you can change any of the bulbs or the matrix by switching the individual lamp off, which gives you the option of not having to open a live enclosure. So this is our boltless get-in box. I'll just run you through a very short video. There's no sound. Anyway, this is...
The enclosure is fitted with a quick opening door which can be secured with a single security bolt. This eliminates bolts on the front cover, thereby adding to the efficiency of the equipment, and hence there is no danger of missing bolts. These gate-in boxes are available for many variants and use 1100 and 550 volt applications. Options available for application are the circuit breaker, lighting transformer, drill control panel, motor control panel, and starters. Options available on the incoming and outgoing sides to suit the various applications include cable double compression glands, coupler, adapter, and plug-in sockets. Delta is suitable for operating either the continuous minor, road header machine, load header
Please conclude.
2 minutes. Okay, so whoever is interested can contact me later for the product. I have to listen to Chairman Sir and conclude as quickly as possible. So these are, again, we make our own accessories, which includes the cable connectors, the circuit breakers, all the isolators, and most importantly, relays for reliability. What is the heart of any electrical equipment that we're talking about? We're talking about our relays. So our relays are specially manufactured in air-conditioned dust-free atmospheres to give them reliability. We make them in thousands, and they're all tested from accredited laboratories for performance and reliability. The pilot and search and lockout relays are specially tested for intrinsic safety. These are some of the relays which are popular. And I come to advantages of Make in India, which we are doing. Even though we have so many collaborations, we picked up whatever we needed to pick up and implement it to Indian conditions. So we have instant service, easy access of spares, world-class equipment, the best of foreign technology at Indian prices. And yes, we are comparable to any international product worldwide. So we also emphasize on skill development and training. This is very strong R&D support. My colleagues are here today from the company who have spearheaded this. This is our technical support for the sales and service, which is quite intense. And yes, this is our tagline. We also bring them home safely. So thank you very much for this opportunity, and thank you for your patience.
Thank you. Now the session is open for questions, please. 5 minutes.
Well, Madam, I am Arun Kumar, GME NM ECL. This is not a question, it is a suggestion for you. As you said that you are competing with the companies like Allen West for load center manufacturing. They are now producing load centers with multiple voltage on secondary, say 1.1, 550, even 110. And your load center is having just one secondary voltage. So it does eliminate the requirement of multiple number of TSUs. So I think...
no, sir. I think there has been some miscommunication. Our load centers come equipped with 10 drive load centers come equipped with 8 drives in 1100 volts and 4 drives in 550. If you want 110 volts, you can even run your
we already have
automations
it. We already have in Janjara, in the new continuous minus we received, and the load centers came from Allen West. This
Sir,
is
we
there
are
all
doing it in Mineline. So thank you very much for your suggestion, but we are
And the
already, in
second-
fact, I think we have sold 10 of them to JMS and Gainwell combined.
And
with,
the second,
with the multiple drives.
Second question is your boatless get-in boxes. You told me that you demonstrated that it is for 1100 and 550. Is it not possible for the same in VCBs for 6.6?
You make the specifications, we'll do it for you. Otherwise, I am already not being able to sell a single 1100 volt because I'm not L1 and I'm single manufacturer. So this got developed in, I think, almost 20 years ago, and I can count on the tips of my fingers how many I've sold. So I'd be very grateful if you put it in your specifications. Thank you so much, sir.
Okay.
Yes, may I? Any questions?
Good afternoon, everyone. My name is Jagannath Satpathy and I'm from MCL. I wanted to know the 365 days data logger that you have, and you got out some analytical reports from it. What is analyzing those data?
I think we have a software that has been developed by us. We work with a software company, and it analyzes the data as per client's recommendation. So normally it is capable of analyzing the data like voltage, machine runtime, downtime, energy consumption, or the trippage from the various motors or various drives. I can, if you leave your address with my colleagues, I will give you the reference or give you the details of what it can do. It's too big for me to mention at this point, but it does all that is expected to run the mine successfully and with minimum hazard, because at the end of the day, mass production technology is all about higher productivity, higher power, but very, very minimal safety risks for the operator.
Thank you. I just wanted to know, is the software programmed by you or is it programmed by someone else that is analyzing the data?
We have bought the software program. It's a Windows 10 program. We have bought the software, but yes, we have our own online programmers in our in-house, as well as we use external agencies for this purpose. We have both. Thank you. We have software engineers in the company as well. Thank you.
Thank you, ma'am. I would request our chairman of the session to summarize the session, please.
Okay, thank you very much. The very first paper by Professor Pradeep Kumar Sadhu was about efficient transmission of power. It was really a new innovation kind of thing, and IIT ISM has been always in front. On this efficient transmission of power using use of CWT with movable secondary circuit contactless power transfer mining application, and he has also explained how finite element method analysis have shown that uniform performance with lab testing efficiency up to 80% has been achieved. This will add certainly new dimension in the power transmission technology, and particularly I wish that this technology could be used in the mining field. I wish you successful field trial and adoption in mining technology. Thank you, sir. And the second paper on electrification of mining vehicles by Sri S.C. Sekhar Katta, BML R&D cell. He has nicely explained why it is required with reference to Paris Agreement and greenhouse effect. Actually, electrification is useful to reduce carbon footprints, which is the today's requirement, and electrical vehicles, hybrid vehicles, overhead line powered, that is trolley mounted, trolley connected vehicles, and lastly the latest generation is battery operated vehicles. He has nicely explained the migration, and his paper is very, very relevant to today's context. His paper also explained that how better ergonomics could be achieved and low maintenance cost could be achieved by mining people in mining industry. The last paper by Srimati Nandini Chakravarti, MD, Mineline Private Limited. It was, she explained very nicely that how installation of electrical system load center. She has explained that in 15 projects, their company's system is already installed and working efficiently. How digital display and data control resulting to real-time information and control. Feature of loads center were nicely explained with safety aspects. How it could provide you actual 365 days data capture for fault value and fault analysis. efficient downtime management was the key point delivered by the system, improving machine availability. This will certainly enhance the mass production technology efficiency, and other equipments integration was also explained by her very nicely. Thank you. Thank you all the speakers. Thank you very much.
Thank you, sir. Before we've all dispersed for lunch, there are a few announcements. First of all, the valedictory section will be at 5 o'clock, so all the paper presenters are requested to be here, and because the mementos and certificates will be distributed at that moment. Second, lunch for directors and DDGs is in the auditorium lounge itself, and for other delegates, it is organized in the workshop building next to Vikas Bhavan. And please, it is requested to be back.
Lunch break. Forward with the third technical session, and the theme of this session is condition monitoring and predictive maintenance of electrical asset standard and best practices for electrical installation in mines. For this session, I would like to request as a chairman Shri P.K. Singh sir, DDG Mechanical, to please come on the stage and chair this session, please. Along with P.K. Singh sir, I would like to request as a member Shri S. Puttaraju, DGMS Electrical Headquarter. Member 2 of this session, I would like to request Shrimati Nandini Chakraborty, MD, Mine Line India Private Limited, to please come on the stage. Now, our next session is going to be by Shri M.R. Rath, Head Electrical Transmission Distribution and Utility, Ore Mining and Quarry Division, Tata Steel. And the topic is Best Practices for HT Installation Followed in Open Cast Iron Ore Mines of Tata Steel Limited. So, ladies and gentlemen, kindly welcome Tata Steel team, please.
Good afternoon. Okay. Yes, yes.
Hello.
Yes.
Hello.
Okay.
चलिए.
Good afternoon. On behalf of Tata Steel, myself M.R. Rath and my colleague Mr. Bikram Das, welcome you all. And post lunch, actually, gradually it is very difficult for both sides with such a nice weather, but I will try my best to keep you engaged. In Tata Steel, there are two groups. Today's session topic is best practices for ST installations, followed in open cast mines of Tata Steel. In Tata Steel has two clusters. One is Jharkhand, the Noamundi group, and one is Odisha, the Joda group, Joda and Khandwan. In Noamundi, the power is received at 132 kV. Next. 132 kV level from JUSNL, and in Joda at 220 kV level from OPTCL. And both have MRSS, dedicated MRSS, and it is stepped down to 33 kV and distributed to all area. Since there are 2 MRSS, 8 MPDS, and many more HT substations and overhead lines and cables, there are a lot of HT electrical installations, means hazard is high. But to mitigate the hazards, we have done many actions, we have taken many actions, and some of the few critical actions will show in the subsequent slides. Next. This is one initiative we have taken. There is from Joda to Khandwan 33 kV line, 20 kilometer through dense forest. Actually 33 kilometer line is there. And what we have done, the ground wire, it is optical ground wire. Means same conductor, it acts as, it is audible? Yes. The same conductor, above the ground conductor, the inside is fiber optics and the outside surface is metallic. So the same conductor acts as ground as well as for lightning protection and for communication. And this is for both sides. There are differential line, differential relays are there, and the same conductor acts for dual purpose activity. Next. This I want to highlight. For electrical installations, two things are most important. One is humidity and one is temperature in rooms. Previously what was happening, one person has to go to inside the room, then take the reading of the temperature and humidity, and there are cable lines and sensors, all hardware connected. But now what we have done, everything is wireless. This picture, basically we are using the LoRa, means long range wide area network, the protocol we are using, and the Tata communication platform is used. And this device, it is programmed, the temperature inside the room it is kept, and from the main receiving substation, the SCADA, the web page is opened. So inside the area, throughout all the area, centrally one person that on the real time basis, he gets the reading. And the setting is done like humidity 70% and temperature, room temperature for control room 25 degrees centigrade, and for ST room 30 degrees centigrade. And if above that crosses, then there will be actually alert will be there. So this activity, everything is wireless and elimination of man-machine interface. Next. This condition monitoring of transformer. We have 2-number transformer 63 MVA. At Joda, 220 kV by 33 kV, 63 MVA 2 transformer, and some more transformer, this facility we have used. Actually what happened, the Snyder-based software is used, and with a kit of sensors. There are 2 sensors. One sensor is fitted at the bottom of the transformer, where the oil testing sample for oil testing is taken in that point. In other is the highest point near the conservator, the tank and conservator that side. Then what happens, and there is an algorithm, and entire actually this system, it takes the reading of the temperature first, then in water content in oil, and as well as partial discharge. In the graph actually it is shown, the partial discharge, actually it is in the decibel. And there is a program above 60, therefore this is actually red, like that. The spike means it has been during actually starting charging of the transformer, it is created. Therefore, in same device, actually without money, this is a condition-based monitoring. Remotely, we can get the information of water content, then partial discharge, and temperature, like that. All we are getting in one location. And another thing is the dissolved gas analysis. In dissolved gas analysis done actually offline, once in a year or 6 monthly, that takes the sample and takes to NABL certificate laboratory. But it has a provision of uploading that DGA analysis in the system, and based on the DGA analysis data and condition monitoring of the oil, the system automatically predicts the life of the transformer. Like in our case, it is now telling that 45 years actually transformer is may go. Like that, that prediction actually, it acts as a cross-check for the condition monitoring. This device we use, this is the thermal imaging camera, and one major breakdown we have saved because of this. Because like this overhead line, 33 kV line, hotspots, actually we could able to diagnose the hotspot and taken the action. Therefore, one major breakdown actually we saved because of this thermal imaging camera. Next. This I want to highlight. In Tata Steel, this is a mandatory. In entering to any electrical rooms, you must wear either the LVSC jacket. LVSC jacket means the capacity is 8 to 10 calorie per centimeter square, or the FR jacket 12 calorie per centimeter square. And in ST breaker, usually ST breaker we charge from remote. But in case, if you deal with the ST breaker, then there is a cool coat, that is 40 calorie per centimeter square. This is the rating. And another thing actually we have done, the intelligent rack-in rack-out device. What is happening? The same device, because many electrical flashes occurred during the either rack-in process or rack-out process. And this actually, we have Siemens as well as ABB, because there are different models of actually breakers. Therefore, Siemens, actually one, this is in the picture this is Siemens. And the ABB also we have. Then remote actually rack-in rack-out actually done. There is a video also. Next. This is just 2 minutes video. We can skip, I think. No, relevant. The person 10 to 15 meter distance is operating. For shooting actually from outside also, from distance also he can operate. Now this is reckon, and after that it will rec out. I think we can skip for the time. Okay. This instrument is used. This is actually, this belongs to Megger, but this is a multi-purpose equipment, quite costly. But what facility it has? First is for a long cable. Where is the short circuit? Because in cable what happens? Either open circuit may be there, one conductor may break, or short circuit may be there, or partially damage may be there. This type of incidents actually may happen. Suppose there is a very long cable, then this instrument, location of the cable can find out, then open circuit can be found out, then short circuit or the ground fault where the location that can be found out. In addition to this, it has facility of high voltage testing up to 38 kV actually it can do. Therefore, this is the multi-purpose equipment by Megger. Megger is a very branded actually company. And this is very costly, but we have kept it because once in a blue moon such type of things actually may happen, then it is useful. And this is the contact resistance. Because in breaker, in that side, that yellow and that green color, that is the sensor. In all the three phase, there is one sensor there. This is the Schneider, the EcoStructure. Actually, this is the asset information system software. What happens? The sensor actually reads the temperature. And this temperature can directly through our mobile, or better actually what we do to the SCADA of the control, central control room, all the information live actually they can get. What is it okay or any deviation is there, the temperature, and indirectly the contact resistance also it has facility. Then therefore this is not much costly, because all these items except that Megger, all the solution I have provided is economical for condition monitoring point of view. Next. This I want to highlight. This is our last part of the presentation. Actually what happened in many, 2 minutes I think. Yes.
This one is the last.
This has been the last. Actually what happens, in many cases, there are electrical flash because of wrong handling of the breaker rear chamber actually panel doors. Suppose panel X is working, then panel Y open something happen. Therefore, in this case, what we do, this is actually it has become mandatory. Gradually, we are converting on breaker in this. There is one solenoid at the back side, and limit switch also there. And if the logic is that, first the breaker should be in off position, number one, then it should be in test position, then one person from the front side, there is a push button, he will press the push button, then the solenoid at the back side will get the power, and at that time another person can open the back side of the door. Suppose the solenoid in any case it is actually technically it becomes faulty, and then the second line of defense is the limit switch. The limit switch directly connected to the trip circuit. Therefore, first, during charge condition, nobody is able to open the rear chamber actually cable door, they cannot actually open. If forcibly due to any reason they can able to open, then the trip circuit also trip this circuit. Therefore, this is 100% actually foolproof. One by one we are going. In our Kalinganagar, actually this is a horizontal deployment of our Tata Steel Kalinganagar site. And from there we adopted this. And now in our breakers also we are actually implementing this. And this is the last part of my presentation. Actually, in electrical, what happens? If you want to keep the person away from hazard, then keep the person away from electricals. This is the principle. But without compromising your goal. Therefore, whatever job like analysis, then getting all information, all these activities should be done at the remote, and only during the major shutdown, The field job like transformer maintenance, breaker maintenance, that should be local, and everything should be in remote. Technology should be like that. This is our message to the gathering. Thank you.
Concluding time is over.
Thank
Now
you, sir.
start for questioner is 3 minutes.
Yes. Session for query. Any query? Mic.
Can we use the relay instead of the Mager instruments to detect the fault?
No,
We can use the distance protection relays, no?
Actually, in mines area, it is very difficult to use the distance protection because the location of this area of the landscape of the area. Distance protection generally we use in the overhead transmission
Overhead
line.
lines. Okay. But this is actually that Mager actually for the cables. Mainly cables, there are there are very difficult terrains when cable has been gone, and that cable some fault is there. In that case, actually, this is in which up to
Actually,
400
if you
meter or
see
500 meter for one
the
end.
ST cable,
Where is the location?
ST cable are coming in the 300 meters maximum length.
Mm.
When we are using the 2 kilometer, 3 kilometer length, we require the jointing of these cables.
Yes.
And very difficult to identify after 5 years installation, because the one group is installation, the another group is operating the plant. Is very if the as-built drawing is not available, it is very difficult to identify the fault location or the jointing location. That's why we are using this to identify the exact location of the fault and rectification as far as possible.
One more question.
Yes.
Thank you.
Thank you. Thank you, sir. Thank you, sir.
Okay. Next. Sri Somalya Goswami.
So the next presentation is about advanced condition monitoring for electrical safety in mining application by Shri Sumalaya Goswami, Head Marketing and Sales, South Asia, and Shri Wasim Ahmed, Regional Manager, Sales and Marketing, North India.
This is a long range wire area network.
Please kindly.
That conditioning on the transformer Laura on the side they are controlling the
Hello. Your time will start now for 10 minutes for presentation.
Yeah. Good afternoon, all the dignitaries from DGMS as well as distinguished guests and my fellow participants. Definitely we are honored since DGMS has given us this opportunity. I will not waste time. I will directly go to the presentation with all of your permission. Which one you tell? Yeah, okay. So, today we will discuss about the safety in mines, which is governed by the national and international standards. Then we will discuss about various types of electrical supply in mines. Then risk, what type of risk is there, why the continuous monitoring is required, and what is the trend now, that is the online monitoring and predictive maintenance as per the industry 0.4. These are the challenges actually in mines. Everybody knows, but just to brush up this: harsh condition, moisture, dust, mechanical stress, trailing cable prone to damage, hard to identify low insulation feeders, many of times complicated distribution system, spurious strip, downtime of the equipment failure, and that's why the need for online monitoring is required, which can be done without shutdown. So earthing type, various types of earthing worldwide used. One is the IT system. This is not information technology. It is floating or unearthed system. It is as per the international terminology. People are saying it is IT system. TN system, which is a neutral, star point is grounded. So TN system, and another derivative of TN system, HRG and LRG system, neutral system grounded via register. So why this condition monitoring and how we are doing? Continuously monitoring the insulation resistance with respect to ground, which is lowering continuously. If we follow the trend, then we can get an advantage of time. Likewise, if it is a grounded system, if we continuously measure the leakage currents, then we can get some advantage of time and we can plan our shutdown, no surprise tripping. That's we will discuss. So these are the standards, VDE standards, then CSA standard, this is the Canadian standard. Sometimes it is also that BIS standards are sometimes follows this, and Indian rules and CEA 2023 mining earth fault and other whatever the standard has come, these are the standards. So now again, just I want to again repeat the thing. Three types of electrical systems are there. One is the ungrounded system, first diagram, solidly grounded and impedance grounded. 3-phase, 3-wire, 3-phase, 4-wire, that's it. Now, what type of solution is available in the world? It is not only Bender, there are so many companies are also doing that type of solutions. Of course, Bender having some edge on this technology, where insulation monitoring in ungrounded system, if in the mines there is any ungrounded system, in India it is very rare. Ungrounded system in some old coal mines I have seen somewhere, in Russian technology where it is used, the ungrounded system they have used. Otherwise everywhere it is grounded or resistive grounded. But as a continuity, and we are also following this, and worldwide European mines are following this type of system, that's why I am telling here. Insulation monitoring as per IEC 61557, this is the standard. Then feeder-wise fault location. If there is any complicated distribution system, feeder-wise you can monitor where exactly fault. No need to shut down the entire system. You can control and section-wise shut down, and also tracing the fault is very much useful with this solution. Then this is very much applicable in India. NGR monitoring solution, NGR protection relay, field safe relay, whatever. Only thing is this, there are so many NGR manufacturers in India. We have the due respect for them because they are the Indian manufacturer. We should be proud for them. But still, there's something was lacking on that type of NGR what is making in India today. One NGR monitoring relay must have the 3 parameters to monitor. Leakage current through NGR, and there will be some facility to trip the system when the design leakage current is more than or equal to the leakage current, system leakage current is equal to the design of the NGR. Then continuity of the NGR to be monitored. In any case, if due to some very high leakage current due to hot NGR is burnt and it is separated, the system will be floated. The NGR monitoring relay will not sense the leakage current. What will happen in that case? So in the very early stage, when the NGR getting hotter, it should be monitored, and there will be, in case there is required, there the tripping can be possible. And third point should be voltage across NGR. That is also to be monitored and tripping. And there is also some selection is there. You can, if you check the harmonics, as well as if you don't want to only take the principal frequency, that is a 50 hertz, then this facility also should be there in the NGR monitoring. And most and foremost, there will be some communication protocol to monitor the thing and to you can say communicate it with the central control room through. It's like we have that Modbus R2 communication facility to monitor the thing, so that you need not to come to the panel or rush to the panel every time. Another one thing, in the main system you put the NGR monitoring relay. Then in the distribution board, in the various branches, instead of ELCB, RCCB, there will be leakage current monitoring relay. And this leakage current monitoring relay will feeder wise, it will monitor the leakages, and in case of there is a failure, then only that particular section can be tripped, can be shut down. No need to put the entire system through NGR relay monitoring relay to entire system shut down. So this is another one very important thing, and it has also the communication protocol, so that you can take entire things to your control room for the advanced monitoring of the system before tripping and catastrophic failure. Sorry. Oh. Extremely sorry. Then third one is the ground fault continuity monitor. Ground fault and continuity monitor. When there is some equipment for the underground machines are there, so the earthing of that equipment should be in equipotential with respect to the substation earthing, so that there will be earth, that pilot cable tracing relay, or you can say pilot monitoring relay. So this is the thing. This is monitoring the leakages in the system as well as monitor the continuity of the earthing cable. So these 3 or 4 things, if we can monitor or check continuously in a mines, as per our belief, your futuristic approach should come, and you will get some, you can say, predictive maintenance things you can have. Then maintenance and automation integration to the IMD, that is the insulation monitoring device, NGR monitoring relay, NGR, and leakage current, residual current monitoring system together with a common communication protocol, and then everything should be communicated with your central monitoring and communication facility. Then IoT dashboard enable real-time visualization, graphical representation, everything is possible. Then automated alarm schedule, predictive maintenance, you can predict that on the graph, on the characteristics of the your system. You can predict everything and support that the industry 4.0, what I have told, that is
Sir, your presentation
condition
time is
monitoring.
over. Your presentation time is over.
Just another one slide is there. So futuristic approach, like digital twin models of electrical systems, AI and artificial intelligence and machine learning driven fault prediction and diagnostic also possible. Then cloud dashboard for multiple mine sites, you can integrate, even you can sitting in your head office and sitting and checking the health of various mine sites. It is also possible. Then remote expert and reduce site presence. No need to keep your essentially 24/7 maintenance team in the mines. Whenever it is required, you can put them there, depute them in the site. Then safe automation and sustainable mining operation. It is possible. That's it, sir, from our side.
Concluding time is 2 minutes for concluding time.
Okay.
Among that, 1 minute left.
So, any question?
Any question, please?
Hello.
Hello.
So it was very interesting.
Thank you so
Condition
much.
monitoring for mines. Yeah.
Yeah.
So I just have one question. You said cloud-based dashboard
Yeah.
for multiple sites
Yeah.
to communicate with the
Right,
multiple.
right.
Do you have a pilot project somewhere where
Yeah,
you've used it actually?
Yeah, we did it, but not, unfortunately not in mines, but it is possible. The same equipment, we did it for some industry, steel plants, we did it.
In mines, it's not been used as yet. A pilot project hasn't
as of
come up.
now, because
Okay.
in
It can
India,
be done, you're saying.
we couldn't do that, we couldn't get that opportunity to do that. We are ready for that. The same equipment.
Okay, thank you.
One of the reputed in the steel plants in India, we did it.
This can be done in mines.
Yes, sure.
Thank you so
100%.
much.
Any more questions?
Okay, there is no question. Now, next.
Thank you. Thank you so much.
Thank you. The series of next and last presentation of this session, I would like to request of RR Global Energy Private Limited, and their topic is medium and low voltage power line communication for mines.
So hi, very good afternoon to everybody. So I am Rajesh, I am from GE Vernova, and with me is Mr. Rajat. He is CEO of RR Global Energy Systems. He works with us on some optical solutions, and on this technology since we are putting up a solution which is a hybrid, so he has also contributed. And Mr. Amit here, he is director of Shashi Commercials. He is our authorized channel. Shashi
Sir,
Commercials
your time start for presentation, sir.
Sir, it's okay, sir. Don't worry. I'll finish well within 10 minutes. Don't worry. Okay. So, Mr. Amit, director from Shashi Commercials, he's authorized channel partner, Shashi Commercial for East India as well as for Pan India for Coal India. So this topic, if I talk, because the subject was on automation, so this is a futuristic approach also, because it is one of the latest technologies which is there on the screen.
Sir, mic on continue.
No, mic is not on, is it? Okay, sorry. So I have only 5 slides, okay, and the topics I'm going to cover is the challenges and the requirements for the basically open cast and underground mine segment. What is the solution? I'll touch up very briefly on the technology and IC standard to which it adheres to, and what is the value proposition over any conventional system. Okay, so the typical requirements for any mining segment are basically analysis of the electrical values coming from field machines at a control center where there will be a SCADA, any kind of a remote operation. Then we have surveillance systems which are there, also telephony which is there, and connectivity for the moving machines. So these are the typical applications. There can be many others as well, but these are the most critical applications for which a reliable communication system is required. The challenges are, we have already discussed the hazardous conditions, the extremely high temperatures, then the gases, all that. Then what would be a solution? Because we in one of the earlier thing we have seen a Wi-Fi based solution, which is a very, very good solution actually for irrespective of static or any kind of a moving machine. Then the challenges what we have, but there are challenges as well, because wireless, there's a big issue with the signal propagation and line of sight. Optical it's a static kind of a system, where if the locations are shifting, then it becomes a big challenge. It is really not feasible, and then it's maintenance. And on top of it, in any kind of a underground scenario, to achieve an overall availability of 99.99% is a challenge. So these are some of the issues which are the requirements which are catered and the challenges which this solution takes care of. So there are basically, so this doesn't, anyway, so on the, please have a look on the right side. So basically it's a two-layered approach. The core system will be on an optical fiber network on MPLS TP based technology. And when I say the ring, that basically means all the tunnels and the pits which are underground from their mouth up to the basic data center or a control center where the SCADA is there, where all monitoring is happening. So that will be on this. And all the inside all the tunnels and the trenches and the pits, it will be a different technology altogether, which is called medium volt PLC. It is based on IC 1901 standard. And what the why two things is because firstly this overall bandwidth requirement for the complete set of mines becomes huge, which this technology will not support. And secondly, the distance limitation is also there with this technology. So we have to have a aggregate bandwidth and a distance. For that it is a fiber. So what it offers basically is this technology. What it offers is a per hop distance of about 2 to 3 kilometers, a bandwidth, aggregate bandwidth, we have tested up to 40 Mbps per equipment, and it can be cascaded. And then it also overall central monitoring and management of the system. That basically means is that you can monitor all kind of alarms, any signals, everything can be monitored. But not only that, sitting from a central control center, or if you have a laptop with HMIs loaded onto that, so you connect onto at any equipment and you can access the complete network, and you can do the troubleshooting as well for that. Okay, fine. So this is a technology because you may ask why in this paper. This is actually not a paper, it is just a presentation. Paper is different, that has much more details into that. So you can go through that. But this is basically one question you may ask, why MPLS TP is, because this is the best technology available today, which is being used in India as well as globally, as well as across the globe. Why? Because it has taken all the best things from the IP technology and all the best things of legacy STH technology, and it has done away with all the complexities of both. So this is the most popular choice today, which is being used for backbone optical fiber connectivity. If we talk about the medium volt PLC, so it is some of you I'm sure would be familiar with the power line carrier communication, which works at 132 kV level and higher levels. So it is exactly same. The only difference here is that this works at low voltage. That means it can work from our house voltage is 220 to 33 kV level. It can work from all of them, and the equipment remains same. Only change happens in the coupling devices. So this is the standard. Basically technology is on OFDM. It has got flexible channels. So this is evolution from of 1901 IEEE standard. But today what we have is that overall it is a multi-hop layer 2 routing protocol. So that means no complexities. And on top of it, we have clock synchronization, and we have for security authentication, and flexible channels are available. So this is a NESM alliance. This technology actually it's an alliance of IEEE and Panasonic, and this is called NESM alliance. So GE is also part of this NESM alliance, and we are, we have been part of this journey for the development of this technology and testing. So it offers an excellent solution for mines where the applications, not, I shouldn't say mines, but inside the tunnels, where the bandwidth will be relatively less, distances are less, but it will provide a very high level of, availability. In fact, this is the last slide, sir. So what is the value addition? So basic value addition is on the, it's a hybrid solution of optical plus MPLS TP. So that will provide a very high bandwidth because surveillance cameras are there. this with 40 Mbps of throughput, it cannot have more than 6 or 7. In overall, there will be so many cameras, so backbone is required on a on an optical fiber system. Then last mile connectivity, that is where this solution comes in. So one thing which I have not mentioned is, unlike any other technology, wireless will require, if we are working in an unlicensed band, there's a huge interferences there. Secondly, if we go into the licensed band, one thing is the fee which is to be paid to the WPC, DOT, and second is line of sight issue. So inside a tunnel, it's very difficult. Third option is using the mobiles. But in mobile, the dependency is always with the service providers. So this does away with all this. There's no optical fiber required. There is no frequency allocation required. Only thing is, it works directly over the power lines. And this is plug and play kind of a device. Device doesn't change, like I said. The only thing is the coupler will change, and they will be put at the two ends of the cable, whatever, irrespective of the voltage level up to 33 kV, and the communication will happen. So that's the actual value addition, and that is why the deployment is huge. And in any typical, if we put all across the fiber, the overall cost of the project, 50% is cost of the fiber only. So that is the straight away the saving which we get out of it. And of course, fiber again has a limitation that on a moving machine, whether it is Stacker, Kramer, or any the moving other vehicles, fiber cannot move from place to place. So this does away with that because it works with the power line. So just to summarize, on the commercial side, because technically everything can be extremely good and it can provide best of the features, but commercial viability is mandatory. So commercial, it reduces capex, which I have already explained. I'll not take your time, but also at the opex, because the maintenance is a huge cost, and then you have to keep shifting and relaying as your locations change and the AMC of the optical equipments. So that is also which I wanted to share. One request, those of you who are interested in this, the paper which will be like it was said, it is available. Please go through that, and it has all the lot of details about this technology and the solution. That's all. Any questions? I'll take them now.
Sir, I have a question.
Sir.
So, you have, I think, just heard this first paper regarding Narva power, this communication used in underground.
Yeah.
They were using some this optical fiber, I think. But in your case, you have different technology available. So, did you go for any trial in underground mines?
Yeah, so definitely. I mean, within India, we have done it for NMDC. The system is working there.
NMDC in underground mines?
Sir,
it is open cast mines, sir.
Oh, then it is open cast. So underground in India we have not done, but in Brazil, in coal mines, in Mexico, some other mine is there, and not recently, some time back, about I think year back, we have implemented the system in Germany. That is also coal mines.
So I would request you to get a trial done in underground mines.
So we can definitely do that, sir. So Mr. Amit is here, and he is handling that. So that part he will coordinate, and the technology part we will. G provides the technology, and other part our Mr. Rajat is there for overall fiber and all. We will put together a scheme. So anytime.
Let me put in layman's language that through electrical cables, power line, say 1.1 kV or 11 kV. Suppose it is going to underground, right up to working pace.
Yeah.
So, in your technology, through that cable only, you will transmit the signals and communicate. Okay.
Exactly, sir.
Okay, thank you.
So, I'll just clarify this. So, basically, what happens is that the frequency for communication which we use, it is in some hertz. Okay, and this the frequency what we use for communication is in kilohertz, and the power line frequency is on 50 hertz. So that is how there's no interference, and it uses the capacitive field around the power cable which is happening, the EMI fields, to make the propagation. And this is on the principle on which up to 765, 130 to 765 kV line, up to a distance of 300, 400 kilometers. This PLCC's power line carrier communication equipments are working.
One more, actually, whatever you explained was a good presentation, all right. But this is not something new, na? I worked in a mine, open cast mine, in 90s, prior to joining DGMS. So there we were using this for a German project. So there we used to call it CFT, carrier frequency telephony.
Sir, I'll tell you.
That we used to use for voice and data communication.
So, sir, the difference is what we are talking about here is voice and data is in not even 1 Mbps actually. Okay, voice is 64 kbps. If it is, that time it was not IP, so it was not 32 kbps. Today it is IP, so it is 32 kbps. That time it was 64. Data is also, you know, in kbps, 19 kbps or 64. Here we are talking about theoretical 50 Mbps. We have tested up to 40 Mbps. So that is the first thing. And second is all the cyber security features and all this happening. And to the best of my knowledge, sir, I mean, I don't contest what you're saying since you have done. To the best of my knowledge, because I'm also part of this IEEE forum, this is the technology which has only come, as you can see, I had shared that, when the standard itself evolved about 4 years, it's not going back, whatever reason, some 4 or 5 years back only. This, if you go to the website and IEEE site, just look for 1901 standard. It has only come developed in the last 5 years. So I'm sure there was some technology, and I'm not privy to that honestly, but communication medium must be something else. It cannot be on a low voltage on power.
It was on power cable, 6.6 kV, no doubt about that. Same coupling unit,
So,
LC
sir, we
unit,
will,
everything same.
So, sir, I'll come to you. I think
Please,
we need to discuss
you
that.
go to Singareni Ramagundam Opencast project 2. It's still working.
And I can
But
check
what
the
happens?
details with
All these units, as far as I remember, it used to operate at some 60 volt or something. I don't remember exactly, for different channels, for different different channels for voice and all that, different units. But after few years, means after 10 or 12 years, one by one, those units failed, and we had difficulty finding the replacement, means spares.
I'm sure,
That's the
sir,
thing.
I appreciate your feedback. So, so I'll catch up with you on this. The only thing is that here it is no separate channels. It is all bundled into one, like an optical multiplexer. So those are probably, maybe they have built upon that and learned from the old one. Thank you very much, sir.
Okay, thank you.
Thanks, everybody. Thank you very much.
Thank you.
Sir.
Thank you so much. Now I would like to request Shri P.K. Singh, DDG Mechanical, as the chairman of today's session, to summarize this session, please.
In this session, all three presentation was based exactly on the theme what was mentioned as condition monitoring and predictive maintenance of electrical assets, standards and best practice. First presentation from Tata Steel, and he explained very correctly and in line with the theme how they are using this overhead line, optical fiber cable transmission through overhead line, and long range wire area network for remotely assessing the condition regarding the temperature and humidity. Condition monitoring of transformer they are also doing by the remote things, and thermal imaging camera they told that they have used for failure detection of the overhead line structure. They are also talking about intelligent rack in rack out device, so that direct contact of the electrical person will not be in the contact of the power line. And Megger, they also told multi-purpose Megger. I think these things are very good things, and it should be implemented in all mines. Rear cable clamp interlock, they are telling through solenoid use. It will save the life of the person who are doing the work in the substations. Second presentation was made about the advanced condition monitoring for electrical safety in mining applications. In this, online monitoring was there also without shutdown. His emphasis was without shutdown, he suggested online monitoring. In this, he distribution of power through 3 systems. He told IT system, TN system, and HRG system. And feeder-wise detection of fault, he also suggests, can be found out without shutting down the power. He explained the residual current monitoring system and NGR monitoring relay that will monitor the health of the NGR. When the leakage current will increase, it will from the design current it will trip, and the voltage across the NGR design voltage increase. If it increases, then it will shut down the system. So it is very good system, and neutral ground resistance must be monitored, or continuity of this NGR is very important. If NGR will be disconnected, then fault current will not be grounded. And automated alarm for predictive maintenance. This is also a very good thing. When any fault is detected, the alarm should raise, and it will alert the people to do the things. Third thing was presented about medium and low voltage power line communication. I think what I understood, that without using optical fiber network, he explained for the communication up to the last mile connectivity in tunnels and in also moving machinery. If this seems very good thing, and I think it should be implemented in coal mines where we are using the telephone cable and optical fiber. In that type, if this is possible, then we should certainly try this. So all 3 topics were very useful and nicely presented. I thank all the presenters on behalf of DGMS. Thank you.
Thank you, sir. Thank you, the panel. The technical session 3 ends here. For the technical session 4, I would like to invite Shri R.A. Meena, DDG Western Zone, as the chairperson, Shri D.A. Somaya Julu, DMS Electrical Central Zone, and Shri Kalyan Kumar Hajra, Director, Joy Global Mining Services, as the panel. So please take your seats on the dais. Our first paper of this session will be presented by Srimati Suchandra Sinha, GM E&M or Solar and FMC CCL. The topic of the paper is Renewable Trajectories to Help Coal Go Green on its Journey of Climate Transition, Risk Mitigation for a Safe Planet.
Hello? It's okay? It's okay? I can leave my mobile. A very good afternoon to you all. So it's 10 minutes?
Yes, 10 minutes please. 2
10
minutes for,
minutes for-
10 minutes.
So very good afternoon to you all, and namaskar. And I would at the outset thank all DGMS authorities for having given me this opportunity. It's my proud privilege to be presenting in the highest regulatory body. This is my 34 years with the coal industry, and thank you so much for having allowed me to present this paper. So the theme is integration of renewables in the mining industry, and this is my topic. So the first slide. So coal is at crossroads, as we all know. Why? So I would start with a quotation of Stephen Chu, who was the US Secretary of Energy and a Nobel laureate. He says the Stone Age did not end because we ran out of stones. We transitioned to better solutions. The same opportunity lies before us with energy efficiency and clean energy. I put this quotation because that's what is just transition all about. So coal is at crossroads. Why? Because the world mandates, the world mandate is against burning of fossil fuels. The coal that we call black diamond, हमारा काला हीरा, वो हर कॉरिडोर में बदनाम है. आ रही है? So जो हमारा काला हीरा है, उसे dirty fuel कहा जा रहा है. There's nothing wrong with coal, but when it burns, it has been lighting the nation for so long, ever since 1774 the British started mining. But today the carbon dioxide emissions are being said to pollute the environment, and it leads to environmental degradation. That's why just transition. So we have the world mandate on one side, the COP21 NDC commitments of the country on the other. We are the second largest producer of coal and the fifth largest reserves we have, the proven reserves in the world. So we cannot do away with coal. Plus it's around 50%, thermal energy is 50% of the energy matrix today. So that's why it's at crossroads. And COP26 came out with these Panchamrit goals. COP26 summit was held on November 16, 2021. It was very important for the developing nations which have huge reserves of coal like China and India, because they were able to force a phase down instead of a phase out. That's when we came out with the Panchamrit goals. The nectar goals, these are the 5 nectar goals. We need to reach a 500 gigawatt of non-fossil energy by 2030, 50% of the energy requirements from renewable energy by 2030, reduction of the emissions by 1 billion tons, and most importantly, the carbon intensity. Carbon intensity is an economic indicator of a nation. The higher the energy efficiency, the lower the carbon intensity. It should come down by 45% from its 2005 levels. Rest of it is from 2021 to 2030. And achieving the target of net zero emissions by 2070. I just said these goals because this is the solution to the energy transition risk mitigation that the coal industry, the mining industry, the coal mining industry is going through, and my paper comes with solutions for this. So this paper basically addresses switching to renewable trajectories to replace fossil fuels, how we are achieving the Panchamrit goals. I'll be coming in the coming slides. I know I have to rush through. Switching to renewable trajectories to replace fossil fuels with automated mechanisms like SCADA, remote cloud monitoring systems, everything has been talked about, digital twins and conveyors, because we have FMC. FMC is something to prevent environmental degradation. We have the first mile connectivity projects. Production, as important to coal production, is dispatch. That's where we come in with the FMC projects. Safety and sustainability. So switching to renewables is not enough. I would like to describe the ways to do it. The ways to, the things that need to be adopted, certain goals which need to be adopted. The goal has to be in mind when we adopt certain technology. It's not enough to switch to renewables. Renewables have their own challenges, because every industry is today meeting its renewable energy commitment. Just solar ko hi le lijiye. It's easy to put up solar panels, very easy to put up. But power evacuation, where do we put all the power that we have? A net zero targets. Power evacuation is a challenge. Solar policy is not yet consolidated because banking is not yet allowed. Nighttime power, it's not a reliable source of energy as electricity generated from thermal, but we have to shift to it. So there are a lot of challenges. So those need to be met. So I would just outline a few strategies to do safety and sustainability in the installation and operation of renewables. Safety is very important, not because of safety hazards, but if safety as formulated by the CEA regulations, DGMS ka permission hame lagta in that area, so they inspect and they give up. That is very important in setting up of the renewable power plants, because that is what will help us achieve the energy efficiency. Again, energy efficiency of the system, the CUF, जो हमें solar plants से मिले. For example, I'm just taking an example of solar. The output is very important. Energy efficiency, this system is very important for the energy intensity of the nation. Decarbonization, we are a very carbon intensive economy. So obviously switch kar jane se, we will be reducing our carbon footprints. And there are many other ways. Every system has to be decarbonized. And digitization. These two are the bottom line of B2B. Even B2B, B2C, we are big public sectors, units. But in our ecosystem, we have the B2B and B2C companies. Energy management policy, even for coal mining in India, needs to change to meet these goals. Energy benchmarking, auditing, and conservation. It's an age-old process. It's an ethics coming to us from the Isho Upanishad days. Today also, energy is not being benchmarked. In Coal India, we have the coal targets. We do not have the energy targets. Energy is the sleeping giant. Switching to zero-emission careers like green hydrogen, this is the future, as stepping stones to prepare the black fossil to go green. So coal need not burn, but it can go liquid, go gas, coal gasification. And there are so many projects that are being, I guess the pilot projects have not yet come up, or 1 or 2 pilot projects have come up in the nation. But like ammonium nitrate projects that WCL has taken up, or many coal gasification projects, coal bed methane projects, those are cleaner, greener option for coal to go green. We cannot waste our reserves. Ye kya hua? So this, I just wanted to show the growth of renewables. In December 24, coal was 50% of our energy in India came from coal, and in the June 25 updation, just in 6 months, it's come down to 45%, and solar energy has gone up to 25%. This is what it is showing. So renewables have already gone up to 48.27%. Last 6 months, solar has grown by 4.27%, just in 6 months. So you can just see, so for the comparison, I've given this. Safety. As I said, first of all, we need DGMS permission because हमारे mine leasehold के अंदर में हम solar plants ला रहे हैं. So DGMS is that online system that we go through. Then the inspectors come, inspect. We have to give them all the drawings, all the required for the CT and the CTO permissions, and then we get. And these regulations, CA 119, 21, 21, 20, 21, 22 of Chapter 10, that state the additional safety requirements for renewable generating stations, safety requirements for biomass, waste to energy. These are different, like geothermal, wind, for everything the same, but where DGMS comes in, those regulations where we require safety requirements for solar installations and requirement to prevent fire, etc. These, if adhered to, strictly will help the plant generate at the specified CUF, the GHI, the gross horizontal index. That's very important. We have to rely on sun god, but the gross horizontal index is what gives us the minimum guaranteed energy that the bidder gives us. So these, and efficiency we will get as planned. Hence, safety occupies center stage in operation. So installation and operation ke samay ye regulations bahut important hai. And throughout the operation, if it is followed during the O&M, then only we will get results from our solar plants, wind plants, geothermal plants, whatever renewables we are switching to. So that's the, it occupies center stage, and efficiency is the bottom line of productivity and sustainability. Sustainability goal is the UN goal. We cannot deplete our resources, have to leave it for the coming generations. Sustainability and safety, net zero. Clean energy transition in India, as I already told you, has overachieved its commitment made at COP21 Paris Summit. हमें 2030 तक करना था 50% renewables को, हमने already 48.27 2025 में ही achieve कर लिया है. From non-fossil fuels, almost 5 years ahead of its commitment. Mining industry needs to revisit its policy synchronization, क्योंकि as I was telling you, solar policy is not consolidated. हमारा जो solar का peak hour होता है from 11 o'clock to 3 o'clock, उस समय हमारे mines में equipment का load कम होता है, हमारी blasting होती है, for example. So that needs to be taken. So we have extra flow of energy. That energy is going into the grid. Our utilities are using it. It's in the grid. But
Madam, 10 minutes. 10
that
minutes.
That was the bell for 10 minutes. Okay. I'll try my best to rush through the rest. So these challenges, the coal industry needs to synchronize. Compliance 4.0 का होना चाहिए. Only then SCADA and digital twin के सहारे Internet of Things में हम 5.0 में जा पाएंगे. Increasing energy efficiency is considered the twin pillars. More efficiency means less fuel required. So energy intensity is how much electricity we consume per unit of GDP. So it's directly related, which in turn means lower cost for the provider and cheaper prices for the customers. Energy efficiency is defined as using less energy to provide the same product or service, such as in lighting, heating, and transporting. Energy efficiency is a reciprocal of energy intensity, like I told you, a direct GDP indicator for the nation. Predictive maintenance has already been talked. It's a data-driven, condition-based strategy. SCADA has already been described by the last session. Two speakers, they spoke of SCADA. So these systems we have, these are the central, SCADA is the central nervous system of our solar power plants. It's very important how you design them, taking into account what all. In the design stage is very important. It's fed into a predictive maintenance. So when I say we can always save accidents, save energy, and get our required output. The algorithms that can predict failures, optimize cleaning, identify panel degradation. The first mile connectivity project, I was talking about digital twins. Again, real-time data. This is again predictive or prescriptive maintenance. So we have a virtual replica, like in the value chain management, every point in the value chain management has to undergo a digital transformation. So every point has to be monitored. Uska ek digital twin hum critical path ka create karte hain. Everything is monitored so that we can reduce time and increase efficiency, reduce cost, and so many things we can do if the entire thing is data based.
Madam, please conclude.
1 minute, please. Accelerating decarbonization through digitization. Carbon capture mein kaam ho chuka hai, utilization and storage is lot has to be done. Value chain management and DBT I spoke about. ESG, environmental, social and governance concern. A connected data ecosystem provides investors, regulators and customers the transparency that they demand. So energy benchmarking, as I said, in the coal industry, we save energy, we are saving cost, we are conserving coal, saving the environment. It's a five-fold process and a sustainable development. This we all know of, but this is very important because energy saved is actually renewable energy and energy at no cost. Advantages of energy efficiency, just a case study. 1 kilowatt hour of energy we reduce 10 rupees per kilowatt. 0.378 kg of coal we save. This is 5,000 kcal per kg coal, and at 80% PLF. Energy conservation, 10% we do, and 0.95 kg of CO2 we save per kilowatt hour. And 1 kilowatt hour of energy saved is 2 kilowatt hour of energy generated at the generating end. At no cost. Last
within
slide.
1 minute.
So this is one NCL case study. You can see how the company. So now I come to the last slide, the recommendations. Without
Already time up. Already
just the recommendations. Okay, you can read it from the recommendations in the compendium. These are my recommendations. Achieving net zero in mining is not just about reducing greenhouse gas emissions. India's energy transition needs to benefit its citizens. Well-designed policies can limit the potential trade-offs between affordability, security, safety, and sustainability. I end with the quotations of Al Gore, the last vice president. He was vice president of the United States. If we do not act now, this is for the planet Earth, future generations will look around and back at us and say, you knew this, you knew what was going to happen to the planet, and you decided to ignore it. Thank you so much. Namaste. Any questions?
Any question, please? Both sides.
आपको?
Fifth row में.
मैडम ये मैडम here.
किधर पे है?
इधर
I'm so sorry, sir.
It's all right.
The light is focusing.
Where the Coal India stands actually, I want to know. Means because Coal India is
I'll
the
tell you, sir.
biggest coal producer, and what exactly you are doing? You have a lot of free space, है ना? Free space, a lot of free space you have. Even dump yards are there. You have abandoned mines. Is there any policy, to make use of all those things? That's what my question.
Yes, sir. So to answer your question, Coal India has a target of 3,000 megawatts को net zero करना है. Net zero, we have a net zero target of 3,000 megawatts through entire Coal India by 2026. Okay, 3,000 megawatts. हमें renewable power, I mean considering all the subsidiaries of Coal India. Yeah, 3 gigawatt. So in that, every company has been given its own target. So since I'm in CCL right now, we've been given the target of 453 megawatts of solar power, I mean whatever, renewable power, जहाँ से भी हम करें. And इसके पहले मैं NCL में थी, they had a target of 273. ऐसे करके सब companies का target. So जब मैं NCL में थी सर 2 साल पहले, तो वहाँ start किया था, right from tendering अभी 50 megawatt का plant लग चुका है. NCL में, निगाही प्रोजेक्ट में, निगाही में वो जगह हम लोग 129 हेक्टेयर्स ऑफ लैंड पे लगा है. And after I joined, last 1.5 years I'm in CCL, sir. We've already commissioned 20 megawatt power plant in Piperbar. That is giving us a profit of 1.01 crores of rupees per month. I mean, मैं energy को rupees में convert करके बता रही हूँ. And carbon footprint हमें 4,000 tons of carbon dioxide we are saving every month. I mean, as per calculation from that. Because we are getting that from the and sir हम 4 megawatt गिरिडीह में लगाए हैं in CCL. So another 4 rooftop capacity हमारा 2.65 है kilowatt सूर्य घर PM सूर्य घर बिजली योजना में. And sir हम 150 megawatt सबसे बड़ा power plant कोल इंडिया का renewable वो हम लगा रहे हैं गिरिडीह में. We have identified land of 286 hectares. पहले वो double degradation land में जा रहा था. CBA Act भी हमारा है. That land is very difficult to acquire, sir, for us. But whatever we found, so 150 megawatt is our big target, sir, now.
It's a good achievement, no doubt. Means all this beyond mine leasehold area.
No. Everything, all of this is within the mine leasehold area.
Okay, wonderful. Very good. Very good.
Thank you, sir.
Any other question from any side? First row.
Madam, one
Yes, sir.
question. Just now you explained that how you are diversifying from coal-based energy generation to renewable energy generation. So why this Coal India is every year escalating the target? So now the target should
So
be
one second, we are not diversifying. We are not diversifying, sir. We are so the CMP there, he's there. GMENM CMPDI. अभी CMPDI की टीम को कल ही उन्होंने भेजा है एक बैटरी बैकअप सिस्टम स्टोरेज सिस्टम स्टडी करने के लिए. हम स्टडी पे हैं, हम लगे हैं बिकॉज ये जो 150 मेगावाट अभी जो मैं सिंह साहब को बता रही थी 150 मेगावाट जनरेट करके हम उसको इवैक्यूएट कैसे करेंगे. आई मीन 150 कहाँ, उसमें से 80 हमें चाहिए खुद के लिए कैप्टिव कंजम्पशन 80 चाहिए, फिर भी हमको 70 बचता है. सो वो 70 को हम सोच रहे हैं अगर हम बैटरी बैकअप ले ले तो हम नाइट टाइम पावर, क्योंकि डीवीसी के साथ बहुत सारा डिस्कशंस होने के बाद वही मेरा मेन यूटिलिटी है, देव अग्रीड टू टेक 80 क्योंकि उनका भी आरपीओ ऑब्लिगेशंस है और कॉन्ट्रैक्ट डिमांड हम कहीं नहीं हटा पा रहे हैं क्योंकि मेरा जो पावर जो हमको रिलायबल पावर है दैट इज फ्रॉम कोल, दैट इज थर्मल पावर. अभी तक सिचुएशन इज चेंजिंग एवरी डे. सो वो 70 को हम सोच रहे हैं बैटरी बैकअप लेके अपना लैंड बैंक में ही यूज करके 286 हेक्टेयर में से 2 हेक्टेयर लगेगा बैटरी बैकअप 70 का रख के नाइट टाइम में यूज करके टीओडी टैरिफ में सेव करें.
I can tell you some more options.
यदि और किसी के क्वेश्चन है तो बाद में मैडम से अलग से आप अपना
hydro pumping and
pump storage you're talking about, we are exploring that in Jharkhand.
and hydrogen cell incorporation.
Hydrogen is the future, I told you.
Hydrogen cell incorporation in solar panel.
Right, sir.
Thank you, madam. Thank you.
Thank you so much. Namaskar.
Thank you, ma'am. For our next paper, I would like to call Shri B.K. Das, Head Projects ANR, and Shri Chirag Kumar Misri, Manager Electrical. The topic of the paper is Futuristic Approaches to Electrification and Automation in Mining Industries.
Should we start, sir? Theme का ही paper में. Yes, you can
your
start.
time start now.
Your time starts now. Very good afternoon, sir. Honorable Chairman and DICE all committee members, Ajay Singh Saab, the conveners, and my dear industrial colleagues and senior officials of DGMS. Myself, B.K. Das, I am heading Pan-India projects of Adani Enterprise Limited. My colleague, Mr. Chirag Mistry, he is from electrical department. We warm welcomes to all of you from Adani family today. About the subject is futuristic automation and industrializations, I will tell you. Adani having the vision for greener, cleaner, and to implement a 30 gigawatt, 30,000 megawatt solar productions within the span of by 2030. And in mining and cement business, our target is 1,000 megawatt solar plant within 2 years of time. And recently in the mining sector, so we have already implemented 9 megawatt solar plant at Sarguja mines, which is art of technology and which is integrated to 132 kV grid substation. And please
play the video.
Play the video, please. It's not doing. Okay, leave it. If it's not running, this is the. Sorry. This is in Chhattisgarh, Sarguja mines. Recently we have commissioned. And we are utilizing the entire 30 acres OB dump area to build this 9 megawatt solar plant. Next, please. The energy, next, previous please, previous slide. नहीं जा रहा है क्या? Okay, I will tell you this. The solar journey. It gives us environmental sustainability, reduction in carbon emission, and we have built this entire solar plant in the OB dump area. Then, which lowering our energy cost. We have a contract demand of 30 megawatt approximately at Sarguja, and we are injecting its on-grid system. And in the peak load management, we are doing with the solar plant. Then regulatory and social impact also we are getting, and technological advancement. These all three together we are achieving from this solar plant. And then I will explain what benefits we are getting from this. Approximately 2.5 lakhs tree plantation, whatever you will do in mines, by installing a 9 megawatt solar plant annually, we are saving this much of carbon emissions we are reducing in this. Then about the energy efficient motors, my colleague Chirag, you can explain.
Hello. So we are using the energy efficient motor in our all mines, and these energy efficient motors are the significant reduction in the operational cost as well. You can, sorry.
Please.
You can see here this energy efficiency difference for the 11 kilowatt motor. For the IE2 it is the 89.8 and for the IE3 it is the 91.4. From this energy efficient difference in the energy efficiency, we can save the energy cost per year, and total product cost, total purchase cost, the payback period is around the 7 years. Okay.
Entire in our future projects, we are using all I3 or I4 motors, whatever projects we are installing from, importing from abroad, all are IU4 motors, and from India we are implementing I3 motors.
We are using the active front-end drives for our major conveyors. Okay, we have already implemented the AFE drives for the regeneration as well as for the low harmonics mitigation. Okay, and these drives we have already implemented in our Taldi and the Kurmitar projects.
Now, this gives two benefits. I will tell all electrical friends. Earlier, standard drives versus active front-end drives, not only it reduces the harmonics, but if the distance is more, there is a 10% voltage boost of facilities there. Almost 10% voltage for a long distance. If it is decreasing, you can increase it. That's a benefit.
So the asset performance, asset monitoring and the predictive maintenance system, we have already installed our Honeywell system at our PEKB Sarguja mines, and we have connected all the sensors, all the vibration sensors and the RTDs, and we are measuring the current and the cloud base. It is the monitoring system. It will give the predictive maintenance analysis as well in this. This is the remote monitoring system for our mines. We have already, we have already installed the remote monitoring cloud-based monitoring system in our Suliari mines. It gives our predictive maintenance as well in this through this remote monitoring facility. We will have all the data on the cloud. We will analyze the data, and we can predict as well. So the next topic is transformer conditioning monitoring system. It is already
covered by Mr. Roth, so we will not repeat it.
We will not repeat it. Some of the best practices in the electrical safety is the uses of the GIS. We have proposed two uses of the GIS 33 kV switch gears. We will have a 33 kV insulation paints in our all electrical switch gear rooms. The rear side voltage indicators, we are now mandatory this voltage indicators in our all the ST feeders, and definitely when the arc shoot already already covered by the Raj Saab, so we are not discuss more on this. This remote racking and the rack out operation of the breaker, Raj Saab has already covered this topic for the ST, but we are implementing in the LV as well.
Then this is the biggest thing Adani has implemented in mining industry. First hydrogen-based vehicle we have operated in GP3 in Chhattisgarh, which has been inaugurated by Chief Minister Chhattisgarh. This we have collaborated with Ashok Leland and a Canada-based company Ballard. The hydrogen, the basic challenges in using this vehicle, we are running every day 80 kilometers. It's a 40 tons total capacity. We are starting from our mines to the railway siding. We have started the implementation. The challenges we are facing in this is that the hydrogen supply. Because now at present we are implementing at Mundra, we are setting up our hydrogen plant. Once the hydrogen plant is commissioned, then the hydrogen supply, and it will be a cost-effective solution. But it's a art of technology where it's a Ashok Leland. The gross vehicle weight I have written here, 18,000 kg, and the gross combination weight along with everything, hydrogen and all battery system is 55,000 kg. Payload is 40 tons, and hydrogen tank. These are the 3 tanks you are seeing, the white part. These are the 3 tanks of hydrogen fuel. At present, we are keeping the hydrogen is coming from different sources, and we are keeping the vehicle at our mines to load the hydrogen once it is going to finish. At 20% level, it will give an alarm, and we have to refill that one. Then the maximum speed limit, we have taken a trial in the highway also. It's 80 km per hour, it is running now. And 2 numbers of batteries, again lithium batteries, 2 150 ampere hour batteries, we are using it. Then you see, by using the hydrogen technology in mining, what are the benefits? First of all, the diesel consumption of carbon dioxide produced per liter is 2.63 value, 2.63 kg per liter of diesel. Average fuel consumption we have calculated for a diesel truck. If you are calculating 3 km per liter, then average daily trip, if you are calculating 85 kilometers for a mining vehicle, then average daily diesel consumption will be 28.33 almost liters. So per year it will be 9,916.67 liters of diesel we will consume. Then carbon dioxide generated by this is almost 26,000 kg. If you are operating a fossil fuel based trucks, then carbon dioxide savings in this by using this hydrogen fuel is almost 26 kg. So I will request to all my industrial friends, all the mining friends, to please take a trial of hydrogen trucks. We are all discussing about the EV machines, but the hydrogen will be the next generation trucks where you can utilize it. Thank you so much.
Any question, please?
This is the please see the photo. This is the trucks, and this is the unloading, and this is Chhattisgarh Honorable Chief Minister is inaugurating it. Last May we have operated the hydrogen truck.
Thank you, gentlemen. You are well within that time.
Yeah, thank you, sir. Because almost co-friends are covered every topic.
So I have 2 questions for you.
Yes, sir.
The first question is that just now you explained how you are using hydrogen cell for this heavy vehicles, trucks.
Sir, at present we are...
just now, please wait. Yeah. So do you think that you should intimate DGMS also, because this is a new technology kind of thing? I just asked Sai Sahab, your head. He told that, sir, we have not intimated DGMS. Second part of question, that at PKEB, you told that you have installed certain capacity of solar panels. So what amount of energy you have saved in actual calculation? You please elaborate.
Till now it is commissioned. At present we are not integrated with Chhattisgarh side. The meter is getting installed recently, sir. So whatever data you have for annual data, you can explain to sir. That we have captured in the presentation you see.
Okay, that is the annual generation of the 21 million units, and the over the lifetime output is the 525 million units for that 9 megawatt solar plant.
And regarding permission,
DGMS has inspected, sir. Who has inspected, I could not tell, but DGMS has.
Sorry to say this. The inspection is a different thing.
Achha.
But you should have got formal permission by written application that the procedure is there. I think concerned जो director है DGMS बता सकते हैं.
Chhattisgarh DGMS, sir has visited and given the permission.
No, I was there only. I just recently 4 or 5 months back I transferred.
Okay.
I have not seen. कभी भी मैंने देखा नहीं आपके यहाँ ऐसा.
Definitely, sir. We will take it.
Sir, we will tell to Chhattisgarh team positively, sir.
Yes, definitely. Sure.
It is down.
In whole of your presentation, this hydrogen truck, this information was very useful. Actually, I was not aware that we are using hydrogen fueled.
It is started,
HEML.
sir. Daily
Okay,
basis.
started. That we came to know. But hydrogen is next big thing, no doubt about that. That we also know, because I am also part of ETD 22, BIS, all that. So I know. It's basically explosive, hai na? So in that also there are so many safety issues, all that. So what Mr. Veer Pratap said about permission, I'm not talking about permission, all that. My request is you please, because I am not in a position to ask questions also, because even I am not familiar with the technology. So my request is, my suggestion is you please have some sort of presentation here or somewhere.
Sure, sir.
Any place, Ranchi,
Sure.
Nagpur, anywhere.
Sir.
So that we can get familiar actually. We just know a little bit, that's all.
No, I will share a 7-page presentation is there tomorrow. I will share with you, sir.
Please
You
share.
can circulate it because it's digital cooling system, hydrogen filling system, all SOPs has been mentioned. And Government of India, all hydrogen-based sector from different units they have inspected and the SOP has been prepared. I will share with you, sir.
And in US, as far as I know, in US, actually by now we would have gone far ahead. But some 1 or 2 years back, some major accident was there while testing all these things related to hydrogen this thing. So there are some serious safety issues.
No, positively, sir. We will give a entire SOP and other things. And biggest thing is that the now almost 4,000 rupees per kg delivery of hydrogen at Sarguja we are facing. Once, because the renewable energy source Adani is doing a great 30 gigawatt generation. Once the renewable energy generated, hydrogen self-generated, then it will be a cost-effective solution, sir. In addition to safety.
Okay.
Thank you so much, sir.
Okay. Only one question allow.
You were talking about energy efficient motors.
Yeah.
Energy efficient motors. So, like in NCL, we have very high discharge pumps and all, So motor sets, the motors are very, we have high voltage. So high voltage mein to energy efficiency.
No, it is for LV motors only I3, I4.
Okay, another thing for thank you. Another thing for LV motors, that LV motors generally energy efficient motors में वो जो air space रहता है उसको घटाते हैं for the losses.
Yeah.
So I have been told by a lot of manufacturers कि वो bearing घिस जाता है उसका shear
Bearing?
हो जाता है.
Till now, ma'am, we have not faced.
So they said that whenever you buy a energy efficient motor, you need to have a warranty for the life of the motor.
Yes.
Can you throw light? I mean, I'm not sure whether that's true. That's why.
Definitely, we are using the energy efficient motor IE3 motor since the 2018, but we are not finding any difficulties till date.
A lifetime warranty also we are not taking. At least 3 years warranty.
No, we are taking the warranty of the 60,000 hours running.
Okay.
Thank you, Das sir.
Thank you so much.
If anyone have any queries, please after this. Acha, one more question.
Yeah.
ठीक है. Last question.
So actually, for EV vehicles, we are following AAS standards. Okay. For hydrogen, anyway, you have built up on a vehicle. So what standards you are following?
No, I can explain you because I will come back to you. Please give me your card. Which standards we will give?
Okay.
It's almost EV because 2 batteries is controlling. If you see the presentation, it is already printed. How it controls, we have narrated that.
After hydrogen cell, it's okay.
Yes,
It's almost
yes,
EV. But
yes.
for hydrogen cell itself, what are the standards you are following?
I will share with you.
That's
Please
okay.
give me your card.
So, my second question I'm having.
No, only one question, please. Thank you, Mr. Das, and thank you, Mr.
Thank
Chirag
you so
Kumar.
much, sir.
Thank you.
Thank you.
For next paper, please.
Thank you, sir.
Gentlemen, your time starts now.
And my colleague Mr. Dinesh Manaka are here to represent the Shri Ajay sir and their team to select our presentation in this forum. Thank you. Next. Reliance Sasan Power is the India's largest integrated power and coal mines project, and it is producing 4,000 megawatt power generation at 22 kV and exporting it to grid at 765 kV level. And from Reliance Sasan Power, we are taking power supply through 132 kV double circuit transmission lines, and that are being protected with distance protection system at power plant. So at our power supply system is that Sasan coal mines is, we take at 132 kV two transmission lines and just step down it to 33 kV and put it to our entire mine surrounding area at 33 kV level. And from that location we put as per requirement mine substations which reduce 33 kV to again to 6.6 kV level, and we use that for our electrical driven equipment system. Our HEMM fleet has there are lots of electrical driven equipments at our power coal mines. We have 2 number of drag lines, 6 rope shovels, 10 drill machines which are electrical driven. And next go. So here we are taking so lots of problems in our system to mitigate to overcome that. We are using our power supply system with flexibility, durability, portability, reliability, and finally all our safety is the major concern to come up all our projects. Next. We are being next. At our coal mines, we are using this diesel driven shovel which we have converted in our electrical system. Back karo. And one drill machine which we both are being converted in our coal mines, and successfully we have done this project. So lots of challenges which are coming to our plant. So we using this diesel driven equipment conversion to electrical equipments, and we are trying to use electrical vehicles we are procuring right now, and we are going to hybrid system in which our diesel electric dumpers can be used with overhead electrification projects, in which we use trolley assist system. We had taken the successful trial of that trolley assist system, which can be viewed in running video. Play ho raha? Play ho raha.
Earlier, actually, BEML personnel they already told that the trolley assist system is there. They are working, but we are already take a trial run of this trolley assist system.
So these are some efforts we are taking to come up our requirements of making cost effective and coming to as our plants are running with so many cash flow problems because our fleets are being larger and larger and with increase of diesel and this explosive costs, we are taking challenges for making our cost effectiveness because we are producing power of 1 rupees 19 paise, which is the lowest PP in our India. So these are the automation adopted in our power system. We have the highly modern high-speed operating numerical relays incorporated SCADA system to operate our power supply systems. Relays which are the working with TCS master chip relays, fuse failure protection, and we use the primary injection testing equipments for those automation, and ELR protection are also incorporated with the CBCT protection. Neutral cities are incorporated. Our 615 relays, which are the ABP made relays, is given provided to protect the earth fault and overcurrent earth fault protection, as well as conductor failure protection. Next. Here conductor failure and negative sequence operating testing is the shown in our presentation, which phase discontinuity is operated in this. Next. Here we are showing the challenges with power supply system in our mines. Mr. Dinesh will explain you further.
Sir. Good evening all of you. Myself Dinesh Mankar from Shashan Power Limited. Actually, some of the challenges that we face in during this tenure, we mentioned here that number one is a sag of the conductor, because increasing the sag, it will create a lot of faults. Then wind pressure. Because of the wind pressure, insulator goes to the towards the pole, and hence tripping is occurred. Protection against direct lightning, because the overhead line is passing through the overhead line erected on such a terrain that it is a hill or a OB dump, and a lot of lightning is occurred there, and so the tripping occurred. So then earth wire rusting. Earth shield wire, we erected earth wire throughout the overhead line, but somehow it rusted and fall down on the phase conductor, so tripping occurred. So earthing system also is the problem, because the hilly terrain is there and soil resistivity is also the issue, and hence it is very difficult to maintain earth resistivity. Then how we overcome these issues? So we erect at least 2 kilometer transmission line in our mines by using the ND60 tower. It is the 132 kV. It is the towers are designed for 132 kV, but we are charging it on 33 kV. So it helps. The conductor span is around 350 to 500 meter, and so the problem that comes in the overhead line in a valley terrain or in a hill terrain, we already we overcome this issue by using the 132 kV tower. Number two is a lightning protection. So we are using here the Franklin cage rod technique, and this technique protection, it protects around 60%, and the protective angle we use here 30. Actually, there is one DGMS circular also there that to maintain the earth protection, lightning protection, and it mentioned 45 degree. But we are here, we are using angle.
So our complete overhead network is covered with GS lattice wire. This is GS galvanized steel wire. Earlier we were using the GI wire, which were being rusted and coming down. So we have replaced all GI wire with galvanized steel wire and provided it to such a height that it is covering our transmission line to almost 30-degree protection.
So this is also the second example of the cage, Franklin cage, that we are using a earth shield wire over the substation, and so we protect our equipment from lightning. This second slide also there, that the how we protect our conductors from the lightning. It is this improvement we had done, that the LA, we replaced LA with a good quality and reputed make, and the installation practices we mainly change here, that we the lightning arrestor we placed with insulator, base insulator, and we placed a counter also there, so that the lightning stroke we count and we monitor the healthiness of the lightning arrestor as well.
Dinesh.
Sir.
Sir, one point is more to be explained here. We are using third harmonic leakage current tester, which can be provided only with these GLA counters. We, although this counter is being positioned at green position, but in many times if third harmonic leakage current is higher, we monitor, and many times it is found that LA fails and this monitor are almost in green zone. So that is can be happen with this providing this leakage counters.
So earthing system we improved in our mines. Actually we provided earthing grids at sending end as well as receiving end, and the earth conductor, earth shield conductor, we directly connected from the earth shield wire from the overhead line to the our earth grid.
Please
Sir,
conclude.
almost 2 minutes around.
Please conclude here.
Sir. So the earthing system we maintained below 1 ohm. This is the one of the major improvement we done in our mines, that we are using a triple conductor overhead line in our mines. What happened in a drag line, we are using a big size of drag line, and the current rating is restricted by the by using the cable. So we are using here the triple conductor overhead line to maintain the current required current level. Most of the time monkey climb on the pole and line get tripped. So to avoid monkey to climb on the pole, we use mesh barbed wire, multiple barbed wire on the pole, so that it restrict.
Non-contact voltage detector.
We are using a non-contact voltage detector because the our team is going in a remote area where the overhead line work we are doing. So what happened, whenever we take a permit in the substation, but our team check the voltage level. Voltage is in line or not. So by this non-contact voltage detector, it is the very good practices we adopted in our mines. Okay. We are using a ladder for climbing on the pole. So avoid. It is also the safety features we maintain. Lotto box we are using in our mines. Group lotto box actually.
भटनागर साहब थोड़ा फास्ट करें, आपका टाइम हो गया पूरा.
We are using
just conclude.
We are using couplers.
Fast.
Cable reeler, so that by using this cable reeler, wear and tear of the cable we are almost reduced. We have a cable fault locator in our mines to find out the cable fault, and also the cable repairing kit, cable jointing kit is there in our mines.
Please,
conclude. Yes, sir.
Conclude.
These are the cable.
So many small implementations for improvements are given here.
This is the already we explained that we are using
40 calorie PPs are being used. Here dry type transformer, our 15 MVA transformer is being protected with fire protection. This is a new work we have carried out.
Certain work we improved, adapt practices, that fixed on the mid-boom, fast-moving haul road equipment.
I request you both, please.
चलो conclude कर दो जब.
Please wind up.
So all these, when we adopted all these good practices, we are maintaining the power supply. These are the data we have maintained, and you see that the power supply availability in our mines are above 98%. We are monitoring these continuously, and on that basis, we are saying that our mines, the failure in a power distribution system is very is come down by using these good practices.
Okay.
Thank you.
Thank you. Thank you.
Yes.
Hi.
Yes. Please.
You, the way I understood, you have converted diesel shovel into electric shovel.
Yes, sir.
Like that?
Yes, one number diesel shovel.
You have done that.
Pure diesel shovel tha, sir. Which is we have just provided a prime mover of electrical motor, and swing motors are also provided.
All that you don't tell means one shovel, diesel shovel, you have converted to electric.
Yes, yes.
So that was abandoned. That shovel was abandoned, diesel.
Yes. No diesel consumption is now.
No. Consumption,
Previously,
it is electric.
it was a diesel-driven machine, but
Purely
right now,
diesel-driven, not
right
diesel
now we are
electric.
using
That was a condemned. It was
Liber.
Yeah. And this electrification means conversion to electrical. You have done locally.
Yes.
In the mine level.
In-house.
Yes. Mine level.
Yes.
Mines, yes, in-house.
Can you do that?
It is in the trial basis, sir. We are not.
No. Can you do that?
Yes, sir. We have done that.
Arey, you have done, yeah. Can you do that? You are not a manufacturer. While designing an equipment, there are so many things. It should conform to some standard. It should NDT. We saw already condemned shovel. You have converted to electrical. Its NDT should be done. All that have you done?
No, sir, actually,
trial
version is completed.
My advice is, whoever is the inspector, means please inspect that. Stop it immediately.
No, it is not in operation, sir. It is only in the trial version, and we are not in a production.
You are not a manufacturer, bhai.
Okay.
You are a user. You are, na?
Yes,
you
sir.
cannot do that. There are so many things which you may not be aware of.
Okay, sir.
Locally, you cannot do that. There are so many type tests, so many routine tests.
Yes.
You don't have even facilities to test all those things locally. You cannot do that.
Yes, sir.
We will take care, sir.
Have you taken any the NOC from Libor? You are converting that as the electric shovel, something like that.
Labor persons already visited to our mines, sir, and
They permitted.
Yes, actually, we are doing the.
चलिए ये बाद में बात करते हैं.
Sure.
But this is highly objectionable, है ना, from my side.
Sir.
And okay, thank you.
Any question?
In the lightning protections, you have discussed about the that lightning protection leakage current you have mentioned over there. So I want to know that in the total current, like you can say that capacitive current and total resistive current. So what is the limitations for the healthy of that lightning leakage current in the total?
150 microampere limitation. Yeah.
150 microampere. That
in
is
third harmonic leakage current equipment.
Okay. And what will be the IC capacitive current among that total? You are talking about IT is equal to IC plus IR.
That is IR actually, third harmonic resistive current.
Okay, what will be the total resistive
total current actually reads only in this leakage current monitor, and it is not not tells so good results actually.
See, you have discussed regarding that.
ये 1 milliamps के आसपास का कुछ ऐसा रहता है, but इसके green zone में रहने के बाद भी we have some case studies that leakage current is going increase and after some times actually for higher voltage levels, as I have worked on 765 kV level also. So at that level we have at that once we have to change our 40 numbers of lightning arresters because this THR's values were increasing. Two number of lightning arresters were failed because at that time that values were increased to some are higher values. We had not replaced at that time, and those got failed.
Okay, there is a provision is for their, see, suppose if it is reached the unhealthy values, suppose it is crossed at that green level, okay. So there is a provision for condition monitoring for display, any like display?
No, it is that THRC reading is taken in connecting mode. No disconnection is done. Lightning arrestor is in service. We just provide a current monitoring probe on that and take the reading.
Okay, thank you.
Yeah.
Thank you so much.
Okay, one question from my side. So I consider that you both are very honest speaker. So one thing that what I could understand that you have tried to adopt electrification in your mind, right? You have converted diesel equipment to electrical equipment, electrically driven equipment without consulting OEM. Is it okay? But why did not you go for buying right from OEM for your purpose-made, tailor-made equipment, which is already designed for electrical purpose, electrically powered? So what stopped you?
Actually, sir, I just want to confirm that the dumper electrifications we had done, it is already electrically designed dumper. We are using a 4400E dumper, which is already been there a provision of electrical as well as diesel driven. And so we are using only, we are feeding only the power. But it is already designed for both.
One question is that if it is in hybrid mode design, then you should have contacted OEM for conversion to electrical.
Yes, sir. We already
You should have contacted OEM, original equipment manufacturer, instead of locally modifying it. That is
OEM support was not being provided, and that
support was not provided.
Yeah.
Thank you, Mr. Bhatnagar, and thank you, Mr. Tiwari, for your
Dinesh
presentation.
Mankar, sir, please. Dinesh Mankar.
Thank you, sir.
Sure. We ensure you, sir.
Thank you.
Thank you, sir. I would request the chief, the chairman, Shri R.A. Meena, sir, to summarize the session.
Thank you, madam.
Meanwhile, we request all the presenters and chairman of the sessions to, that validity session is there. So please be continue in this seminar hall for your certificates and memento, please.
During this technical session, total 3 papers were presented. First paper was presented by Srimati Shochandra Sinha, GME&M, CCL. And that was on renewable trajectories to help coal go green on its journey of climate transition, risk mitigation for a safe planet. She covered the switching of renewable trajectories to replace the fossil fuels with automated mechanization, SCADA, remote cloud monitoring system, and digital twin conveyors. Safety and sustainability in its installation and operation of renewable, switching to zero emission energy carrier like green hydrogen as a stepping stone to prepare the black fossil to go green. She emphasized to mining industry needs to revisit its policy synchronization with digitization. Preventive maintenance is a proactive scheduled approach to maintenance. Thank you, madam. This presentation will be very helpful to all mining industry. Thanks a lot for your presentation. Your presentation was very nice and very useful for this industry. Second presentation was by Sri B.K. Das and Sri Chirag Kumar Mistry on the futuristic approach to electrification and automation in mining industry. He covered about the renewable energy integration in mining industry, told about the 9 megawatt solar plant in Sarguja of Chhattisgarh state use of active front-end VFD, IGBT-based converter and inverters, asset monitoring and performance management, remote monitoring in mine electrical network, condition monitoring system of transformers that was already covered in other presentation, best practices, electricity being done in there, and use of hydrogen fuel cell electric truck in mine with zero emission. Thanks a lot to Sri Das and his colleagues for his nice presentation. Third presentation was by Sri Anurag Bhatnagar, AVP, and Sri his colleagues about the Sasan mine. They covered the power supply distribution in Sasan coal mines, challenges and measures. Most equipment deployed in our electrically operated machines are being deployed in Sasan mines. Electrification of excavator and drill machine. Trial run of dumper in overhead line. Number of automation adopted in power distribution system and Sasan mine. Protection against direct lightning stroke inside mine, and he told number of safety measures those are being used in his mines. So thanks a lot to Sri Bhatnagar ji and his colleague for nice presentation, and this presentation and best practice being used in your mine will be helpful in other mines also. So thanks a lot to all 6 presenters, those who have presented their papers in this last session. Thanks a lot.
Thank you, sir. Here we end here we are ending our technical session 4. I am requesting everybody to please take tea outside. We'll meet after 10 minutes and we'll have our valedictory, sir, to also join them on dais.
We humbly request our DGMS, Shri Ujjwal Taha sir, to please come on the stage for the valedictory session. Thank you so much, sir. We highly appreciate your cooperation for this last minute change and change in sequence because of this termination of tea break. Thanks for your cooperation, sir. Moving to call our presenters. With the permission of chair, we would like to request our esteemed presenters of today's session. I would like to request from the first presentation given by Shri Rupesh Mehta, DGMS Electrical, Central Zone. And
all the participants are requested to please enter from the right side and leave from the left side.
I request Ujjwal Taha sir, DGMS, to kindly present this moment to Shri Rupesh Singh Mehta. Ladies and gentlemen, can we have a round of applause, please, for the efforts. Thank you, sir. I request Shri Ujjwal Taha sir to present memento and certificate for Shri M. Armugam, DMS Mechanical, DGMS, Southern Zone, Bangalore.
I request Sri P.K. Jha, Superintendent Electrical, to come on stage. All the participants, please sit near the stage. Shri Bhogesh Kumar from NT Enterprises.
तालियों की गड़गड़ाहट चलती रहनी चाहिए.
Professor Dr. Pradeep Kumar Sadhu, IIT ISM Dhanbad. Shri Surya Chandra Shekhar Kata from SBU Mining.
Shri M.R. Rath from Tata Steel. Mr. M.R. Rath. Along with Mr. M.R. Rath, Shri Vikram Kumar Das of Tata Steel, please. Mr. Rath, please. Now on the stage, Mr. M.R. Rath and Shri Vikram Kumar Das from Tata Steel for their presentation on HT installation in open cast iron mines.
Shri Somalia Goswami and Shri Wasim Ahmed. Shri Rajesh Verma and Mr. Dinesh.
Mr. Dinesh P. Makan and Rajesh Verma from RR Global Energy. सुचंद्रा सिन्हा नहीं दिनेश कहाँ बोला है नहीं चेंज किया था कराया था ना चेंज कराया नहीं ये रजत का चेंज नहीं है राजेश वर्मा रजत महेश्वरी अलग है ना अच्छा ये अलग है राजेश ये उसका नेक्स्ट ये वाला अनुराग रविंद्र इसमें सो राजेश वर्मा एंड रजत महेश्वरी फ्रॉम ग्लोबल आरआर थैंक यू कॉलिंग नेक्स्ट प्रेजेंटर श्रीमती सुचंद्रा सिन्हा GMCCL. Shrimati Suchandra Sinha, GM E&M and Solar.
Shri B.K. Das and Shri Chirag Kumar Mistry.
At stage right now Mr. B.K. Das and Mr. Chirag Mistry from Adani. तालियों की गड़गड़ाहट कुछ कम महसूस हो रही है. हम जानते हैं कि हमने टी ब्रेक पोस्टपोन किया है. Thank you. And the next memento is to Shri Anurag Bhatnagar and Shri Dinesh P. Makan from Reliance. तालियां बजती रहनी चाहिए.
At last, I would like to invite Shri Saifullah Ansari sir, Director S&T, on stage.
तालियों की गड़गड़ाहट होती रहनी चाहिए for the energy which was showcased during presentation. जिस गर्मजोशी के साथ प्रेजेंटेशन दिया गया, उसी गर्मजोशी के साथ में पारितोषिक का भी सम्मान होना चाहिए. Now I would like to request श्रीमती तृप्ति मौर्य from BCCL, जिन्होंने आज हमारे साथ यहाँ एंकरिंग में सहयोग दिया. एक बार जोरदार तालियां तृप्ति के लिए. Thank you so much, sir.
Moving the event forward, it is now time to reflect on the rich discussion and insights we have gathered throughout the day. With great respect, I would like to invite Sri T. Srinivas, DGMS Electrical Western Zone, to kindly give the key takeaways and recommendations from the technical session of this seminar. Before Srinivas sir says anything, I think it's time for audience to give their feedbacks and recommendations if they have some. Is anybody interested? Yes, sir, please come on stage, please.
Good evening, Ujjal sir, all senior DGML officials and my dear friends. This is my second seminar in this year I have attended. Last time it was in Bangalore for the bulk material handling safety system. And it is a great learning, at least the atmosphere is getting created. We are doing all type of jobs, but we are not sharing each other our knowledges. This is the forum where every industry is coming and giving, sharing our knowledges, what new technology we are learning. And thanks to DGMS, last time, sir, whatever in Bangalore you have the seminar, from the seminar we have gathered, we have started implementing in the bulk material handling system. And this is the second seminar in automation futuristic technology. Again, I will request to all the miners friends, my dear friends, we must learn whatever we have learned about the IoT technology, or future distillation, or hydrogen, or renewable energy, reducing fossil fuels. We must go and learn each other from each other, and we must implement in our field and in our minds to create a very good technology in mining industry. Because I am from steel background, everybody is telling plants everything is possible. We will show as a team in mining sector also it is possible. We will create this. This should be a oath we should take from this seminar. And thanks to DGMS for organizing this type of seminar. Thank you so much, sir.
Anybody else wants to share something? Please, sir.
Good evening, everybody. My name is Sanjoy Mitra. I represent Gainwell Engineering Private Limited. Before I say something, thank you so much, DG sir. Thank you so much, Ajay Singh sir, and all my senior dignitaries present here. This is the first opportunity for me to attend a seminar in DGMS. I must say it's been an overwhelming experience for me. Coming to the point, I represent a mining machine manufacturer, and like we all saw in the seminar that it's a essential need to capture data, transmit data, store data, and analyze data. So that's one of the most vital things we are feeling from last 5 years since I've joined Gainwell. We are still struggling to gather data in a seamless manner. And I saw Arumugam sir presenting in his presentation that one of the challenges is extraction of data. So if there is something we can do, sir, especially in underground mines, to extract data, to make it a practice in upcoming projects, if we can ensure something that extraction of data becomes more smooth, more seamless, that will be so good to, I would say, enrich our products and help in turn the mining industry to make the coal extraction fruitful in every manner. Thank you. Thank you, everybody.
Good evening, Chair, and all the delegates present here. My name is Jagannath Satpathy. I am the project engineer of Jagannath Colliery, MCL Coal India Limited. We have DGMS visiting our colliery quite a number of times. I had the opportunity to interact with most of them. And I would heartily thank each and everyone who has participated in it and put their effort to make this event a success, because events of such kind are really rare for all the people who are working and toiling hard in their collieries and different places. We have very less time to actually brainstorm on certain things. But when we come to seminars like this, we really brainstorm with other people and we get to know how far we have reached and how far we are supposed to reach. There are many papers that were in conceptual level, and there were many papers, those were in experimental level, and even there were papers which were already implemented. In this context, I would like to say that kudos to all the people who implemented really futuristic ideas. And thank you, the DGMS, for selecting my paper. And also, from my side, like being a youngster, I expected a lot more to be discussed on artificial intelligence and machine learning. I expect that next year forward, we will be talking on these topics also. Thank you again for this opportunity. Thank you very much.
Hello, good evening to you all, respected DG sir, respected dignitaries on the days, and all my friends off the days. First of all, I start by thanking DGMS for having given me this opportunity. This is my first time that I was allowed to present a paper, or first time I've attended a seminar, and I thank DGMS for bringing industry, academia, suppliers, manufacturers, all in one platform, which was very, very required for just transition, because there were so many views that were shared. Everybody's already been talking of the different topics, from condition and monitoring to preventive maintenance to predictive maintenance, what's happening in the mines, mining technology, and for mining industry to go from 4.0 to 5.0 is a huge challenge. IoT things is not, everything is easier said than done in the mining industry with all its challenges. So I think I would like to thank everybody, and there's been so much sharing of knowledge, and for me, sirs, it was like so much to learn, so much to learn, and so little learned. So it was an eye-opener, and thank you so much. Thank you, sir.
Thank you, ma'am. Thank you, everybody, for the feedback. Now I would like to invite Sri T. Srinivasan sir for key takeaways and recommendations of the technical sessions.
Respected DGMS Sri Ujwalta sir, all DDGs, all officers from DGMS, distinguished dignitaries, esteemed presenters from various mines across the country, and all participants present over here. A very good evening to all. It is a privilege and honor for me to present all the takeaways of this national seminar on behalf of recommendation committee. All papers are very much relevant and are very much useful. Based on these papers, we have made recommendations. From each paper, we have made one recommendation. So the takeaways of this seminar is, as there is risk of electrical shock due to touch potentials, the committee recommends that a proper system study to be carried out to accurately determine the magnitude of touch potentials and capacitive currents to design the value of restricted neutral systems for power supply. And in recent past, as multiple fatalities occurred due to these touch potentials, committee recommends that bring the design of use of restricted neutral system of power supply under ambit of special approvals to be granted by Chief Inspector of Mines. And the committee recommends that Directorate General of Mine Safety may take initiative by entering into memorandum of understanding with premier educational institutes and research bodies to formulate a system to identify the technological challenges in integrating various technological groups of mining 4.0. Manufacturers may need to come forward to make necessary modifications in their equipment to adapt mining 4.0. So there is another one presentation regarding wireless power transmission in gaseous degree 3 mines. So committee recommends that educational and research institutes may do further studies in finding possible ways for safe transmission of wireless power in underground gaseous mines. As protective systems available in the equipment is crucial in human safety and equipment safety, committee recommends to standardize the best safety systems and various protective systems, if any, in the switchgear through a circular or incorporate in relevant Indian standards. It also recommends that mine management should formulate, update their standard operating procedures for installation, maintenance of electrical equipment that are used in mines with latest available technologies. Committee recommends that mine management should always align with world-class electrical safety and automation standards for improved safety, industrial growth and sustainable economic development. As there are challenges with wired or wireless communication systems, committee recommends that educational institutes or research mining institutes may further study medium and low voltage power line communication systems for use in underground mines. And regarding this artificial intelligence and Internet of Things, committee recommends all management to introduce artificial intelligence and IoT into their monitoring and predictive maintenance systems for improving safety. Among various communication systems used in underground mines, Wi-Fi is one of the better way of communication in underground mines, which may be implemented in mines. For reducing greenhouse gas emissions, solar power is one of the best renewable energy source. So mine management may go for captive solar power plants. Electrification of mining vehicles offers a transformative pathway towards cleaner, more efficient and safer mining operations. But as there are challenges in various electrical aspects, it is recommended to introduce the electrical vehicles in the mines by incorporating all the required protective features and ergonomic studies. And there is one paper regarding infrared sensors. So as there are advantages over catalytic sensors, infrared sensors may be one of the option along with other sensors to use in underground mines subject to compliance of relevant IEC standards. These are the recommendations. I thank all for giving me the opportunity.
Thank you, sir. Now, I would like to request Shri R.T. Mandekar, sir, Deputy Director General, Northern Western Zone, to address the seminar forum, please.
सभी उपस्थित को मेरा नमस्कार। We started with a new kind of working culture in DGMS under the guidance and leadership of our respected DG Saab, Shri Ujjwalta Saab. Such type of consultation, collaboration, discussion, brainstorming, including all the stakeholders, now a practice in DGMS under his guidance. So he believes in collaborative approach, what I've seen last 1 year working as a DG. He discuss all the issues with the internal senior officers and also with the industry and then take any step. I think that is a very democratic way of functioning, and we all should welcome all these things, which is a paradigm shift in the DGMS functioning that we are noticing. आज के परिप्रेक्ष्य में मैं अगेन हमारे डीजी साहब और अजय सिंह साहब को इस पूरे वर्कशॉप को, सेमिनार को कंसेप्चुअलाइज करने में जो उन्होंने किया और जो मेहनत की और जो डिफरेंट स्टेक होल्डर्स के पेपर्स को इकट्ठा करना, स्क्रूटिनी करना और उसको इस तरह से पेश करना और सभी को एक साथ धनबाद जैसे जगह में बुलाना, और पूरा दिन ऐसा था कि मैं तो अपने चेयर से उठा नहीं, आज कहीं गया नहीं, मैंने आई इवन नॉट वेंट टू द हेडक्वार्टर ऑफिस फॉर माय वर्क। मैं पूरा बैठा रहा क्योंकि इंटरेस्ट जनरेट हो रहा था। एवरीबडी वॉज इंटरेस्टेड इन द पेपर्स एंड देयर वॉज वेरी कामली कूलली सब लोग सुन रहे थे क्योंकि कुछ नया हो रहा था, बिकॉज वी आर इंजीनियर्स बेसिकली। सो हम लोगों को कुछ भी ऐसा नया बोलने से तुरंत ब्रेन एक्टिव होने लगता है, काम करने लगता है। अब मैं देख रहा था सब बहुत शांति से ध्यान से सुन रहे थे और बहुत कुछ नया था, बट मैं थोड़ा ज्यादा एक्सपेक्ट कर रहा था इस वर्कशॉप में, सेमिनार में। जैसा किसी ने बोला कि एआई पे ज्यादा बात नहीं हुई, हो सकता है कि एआई में हम बहुत नेसेंट स्टेज में है माइनिंग इंडस्ट्री में, उसके लिए बहुत डेटा जनरेशन चाहिए, बहुत कुछ प्री वर्क चाहिए, तभी कुछ एआई बन सकता है। तो उस पर कुछ ज्यादा काम नहीं हुआ। और दूसरा मुझे ये लगता है कि थोड़ा रिप्रेजेंटेशन कोल पे कंसंट्रेशन ज्यादा था आज के वर्कशॉप में, बट मैं ये मानता हूं कि मेटल वालों ने भी बहुत ज्यादा ऑटोमेशन किया है। अगर आप थोड़ा कंपैरिजन करेंगे तो मेटल इंडस्ट्री इज लिटिल अहेड ऑफ द कोल सेक्टर एज फार एज आई नो। सो उनका कंट्रीब्यूशन भी थोड़ा होता तो हम लोगों को थोड़ा और लाइट इसमें इस पर्सपेक्टिव में और थोड़ा हम लोग समझ पाते और बहुत लोग इससे लाभान्वित हो सकते थे। लेकिन बेटर शुरुआत तो बहुत अच्छी हुई है। उनके जो टीम है साहब की, अजय सिंह साहब की टीम, सारी टीम को जिन्होंने पिछले 15 दिन से लगातार मेहनत की है और बहुत अच्छा रिजल्ट आज सामने आया, उसके लिए हम सब मिलकर उनको धन्यवाद देते हैं, उनके लिए क्लैपिंग। और पेपर्स के बारे में बहुत चर्चा हुई, मैं उसमें नहीं जाऊंगा। बहुत 2-3 टॉपिक मुझे बहुत अच्छे लगे। एक वो जो था कि पावर केबल के साथ ही कम्युनिकेशन को एस्टैब्लिश करना, अच्छा कंसेप्ट लग रहा था, सुनने के लिए भी अच्छा लग रहा था कि अगर ये हो जाए तो, क्योंकि वाईफाई के साथ बहुत सारे इशू रहते, लाइन ऑफ साइट चाहिए, फिर वो रिस्ट्रिक्टेड रहता है, फिर एवरी जंक्शन एवरी क्रॉस पे आपको देना पड़ेगा, तो थिंग्स आर देयर। तो ये इसमें अगर पॉसिबल है, अगर सीमलेस कम्युनिकेशन पॉसिबल है तो इससे बेहतर बढ़िया क्या हो सकता है, और ये कोल में भी हो सकता है, और इसका सबसे अच्छा यूज इमरजेंसी में हो सकता है। अगर आपने देखा होगा कि हम लोगों का जो रेस्क्यू प्रैक्टिस है, इंडियन रेस्क्यू प्रैक्टिस और यूएस में जो रेस्क्यू प्रैक्टिस है, इसमें एक मेजर डिफरेंस है। जो हम रेस्क्यू रिकवरी इमरजेंसी डील करते, हमारा जो रेस्क्यू प्रैक्टिस है ये कैप्टन ओरिएंटेड है, यानी कैप्टन ऑफ द टीम टेक्स अ डिसीजन एट द साइट। अभी मुझे क्या करना है, यहाँ पर ये ऐसा करना है, यहाँ से यहाँ वेंटिलेशन करना है, ये ब्रैटिस लगाना है, ये ब्रैटिस को गिराना है, कैप्टन टेक्स अ डिसीजन। बिकॉज कम्युनिकेशन चैनल नहीं होता टॉप के साथ, कम्युनिकेशन चैनल कंटिन्यूएशन नहीं रहता है। लेकिन यूएस प्रैक्टिस में ये है कि अनलेस अंटिल दे इस्टेब्लिश द कम्युनिकेशन दे डोंट मूव फॉरवर्ड। तो उसका जो टीम होता है वो बेस के साथ कम्युनिकेट करता है, मतलब सेंट्रल कमांड के साथ कम्युनिकेट कंटिन्यूस, और सेंट्रल कमांड जो कमांड देता है उसी को टीम फॉलो करता है अंडरग्राउंड रेस्क्यू में। ये बेसिक डिफरेंस है। हमारे यहाँ चूंकि कम्युनिकेशन का इतना अच्छा इस्टेब्लिशमेंट अंडरग्राउंड वर्क में नहीं है और इमरजेंसी में हमारा सब फेल हो जाता है, अगर इस टाइप का कोई कम्युनिकेशन सिस्टम, तो हम लोग इसको भी सोच सकते हैं कि हम इंडियन पर्सपेक्टिव में इसको यूज कर सकते हैं क्या। तो कम्युनिकेशन, अंडरग्राउंड कम्युनिकेशन चैलेंज रहा है, अभी तक भी ढंग से नहीं हो पाया है। अगर कोई ऐसी टेक्नोलॉजी आती है और अंडरग्राउंड कम्युनिकेशन जो उन्होंने बोला टैगिंग, ट्रैकिंग, सभी चीज के लिए यूज कर सकते हैं, और इंक्लूडिंग वॉइस, ऑडियो विजुअल एंड बहुत सारी चीजें और यूज हो सकते हैं। तो बहुत ही अच्छा लगा मुझे, इसमें काम करने की जरूरत है और इसको अगर बढ़िया फ्रूटफुल रहा तो इम्प्लीमेंट करना चाहिए सबको। बहुत बहुत धन्यवाद मुझे ये वक्त देने के लिए। मैं सोचा नहीं था मुझे बोलना पड़ेगा, बट अब बोलने के लिए वक्त मिला है। थैंक यू वेरी मच, थैंक यू वेरी मच वंस अगेन। जय हिंद, जय सुरक्षा, जय भारत।
धन्यवाद सर, आपके आशीर्वचनों के लिए हम तहे दिल से शुक्रगुजार हैं। कार्यक्रम को आगे बढ़ाते हुए मैं निवेदन करना चाहूंगा आदरणीय श्रीमान अजय सिंह सर से, डीडीजी इलेक्ट्रिकल, के आए और सदन को संबोधित करें।
थैंक यू हेमंत। रेस्पेक्टेड डीजी साहब, मांडेकर साहब, all the senior officials and representatives, manufacturers, staff members, good evening to all of you। हम लोग काफ़ी लेट हो गए हैं, सुबह से डिलिब्रेट करते ही जा रहे हैं। सबसे पहले तो मैं वोट ऑफ थैंक्स होगा बाद में, लेकिन मैं अपनी तरफ से बोल रहा हूँ कि जो भी हमारी टीम है ये पूरे कार्यक्रम के आयोजन में जो लगी हुई है, मतलब पिछले मेरे ख्याल से 15-20 दिन से पूरा रात को 9-9 बजे तक ऑफिस में बैठे रहते थे, तो उन सभी लोगों के लिए एक बिग शाउट आउट। थैंक यू वेरी मच। यहाँ जैसे मांडेकर साहब ने एकदम एक सही बात बोली है कि यहाँ थोड़ा नॉन कोल से कुछ रिप्रेजेंटेशन, थोड़ा सा एक बार हाथ उठाएंगे नॉन कोल के कौन कौन है? तो है लेकिन कम है, सही बोल रहे हैं साहब, थोड़ा सा तो ओके। देखिए शायद आप लोगों ने प्रेजेंटेशन वगैरह नहीं दिया, इसलिए आप लोगों की योर प्रेजेंस इज नॉट फेल्ट, दैट्स द थिंग। तो नो प्रॉब्लम, नेक्स्ट टाइम हम लोग इसको एड्रेस करेंगे जरूर। जैसा मांडेकर साहब ने पूरा ब्रीफ किया है, तो मैं फिर से उसमें डुप्लीकेशन में नहीं जाऊंगा, बट वन थिंग, सम ऑफ द पेपर्स even I was not familiar with, excellent paper, some of the papers were excellent, particularly that of Tata Steel, excellent paper. So those are matlab that's the main advantage of this type of seminar, because whatever good practices, when one project can adopt all those practices, why not others? So the practices they explained actually, that almost makes the system fail safe. So kuch person coming into live electricity, all that chances are practically we just block those chances. That's a good thing. And you are monitoring the live health of transformer. It gives the life, how much life it is going to clock, all that. So wonderful. Other papers also. This one, this carrier frequency telephony, Mandekar Saab told. This is old technology actually. So that I was not very much impressed. But other things, many other papers, they were simply excellent. Madam Sinha madam ka paper bhi bahut acha tha. The one thing she told actually, and we are familiar, in last 6 months, means by December 24, this contribution of thermal power was 50%, and within 6 months it came to 45, no madam? It came to 45. You can imagine the level of this adoption of renewable power is going on in the country. Excellent madam, thank you very much, new information for me. So, okay, once again, finally, I personally thank DG Saab also, because he was after me since last almost 1 year or so. We have to conduct a workshop. Bangalore workshop also, our contribution was almost 50%, but that was counted as mechanical workshop, mechanical seminar. So उसमें हम लोगों को कुछ credit नहीं मिली. I hope we will get credit this time. Thank you very much.
Thank you so much, sir. Now I would like to request Honorable DG Saab, Shri Ujjwal Taha sir, to come on the dais and address the forum, please.
मैं कितना बोलूँ, सुबह तो बोला हूँ, एक आदमी को एक ही दिन में कितना बार सुनेगा लो. Good evening everybody. It is the fag end towards, but see, there are almost all seats are vacant and nobody will be encouraged to speak seeing the audience. People are in the mood of going. So I wish you all the best. I think you have taken part and learned a lot. Cross learning has taken place. Sessions are interactive, and with this learning we want to imply and employ these tactics or techniques whatever we learned today in the field, and which overall improve the mining situation, safety, health and welfare. Not only that, with production and productivity. So with this, Sri Ajay Singh Sahab was telling that credit goes to everybody. Any function you organize as a team, and obviously Bangalore part, obviously electrical people have been contributed, mining people have been contributed. This sort of competition is good, healthy competition. So inspire you all that this lot of little difference is created, so that now mining, we tell that mining has not done already, but he will complain that mining already has done occupational safety health in Udaipur. Very good seminar they have done. And this was the first time this seminar, one workshop has been, not seminar, workshop was conducted by director exam last year. This is a very beautiful and very well appreciated. This sort of seminars gives a, we learn from many people. Their feedbacks is very important, so giving feedbacks is very essential, so that not a continuous, you see improvement is a continuous process. There is always scope for improvement, and the participation point of view, I say that might be some coal mining only maximum, but obviously I appreciate that coal metal mining in advanced adopting technology is far most probably ahead. I have seen UCL or some other metal mine companies, they are going ahead, but presentation point of view, I think they might be lagging. Or another thing, this technology, different technologies, particularly oil mining and gas, this CBM projects, there are also number of technologies are available. I think wholehearted participation from these disciplines also give us impetus to improve upon this quality of these seminars, workshops, whatever we conduct. So this is my request to communicate your senior bosses, senior officers, so that whenever we get the opportunity, it is not only just a sharing information. From there we can show, if you feedback is quality, we can use guidelines. We can share to the, because acceptability of information shared in this forum may take a good policy decision, and that policy will affect the whole country, may affect. So it is better quality papers are submitted, discussed, and more debates happen, and then out of this churning we come to a little bit summary or conclusion, which will give the pathway for the our future adaptation. Another thing I see, this technology was being developed already. The one thing I came to my mind, that there is a 4 stage of development, what we generally say. One thing we do not know and we do not do also. Second thing, we know what is the problem, but we cannot solve. That is the second stage. We are moving this towards the end of this stage. Third stage is we know the problem, we solve the problem. And this most advanced stage, this is that whatever be the problem, that fail-safe we can say, that it will automatically take care of. And with the advent of AI and all these things, this will be possible in the future generation. I think so. The developed countries are striving for the 4th stage. We developing countries are striving for the 3rd stage, which the developed countries have already reached. So if we, this stage-wise, if we say that there is a transition, and it takes lot of efforts from all stakeholders, and you are in the right, we are in the right direction. As India, we are progressing, we shall progress. And with this hope, I do not know how much facilities, how you have appreciated, how much you have been taken care of. If anything deficiencies are there, please don't let us know. So we shall, in the forthcoming events, we shall try our level best to for course correction. And with this, I again thank the organizing team who have put their wholehearted efforts since many long days, and made this event happen. And also thanks all the participants that from across India they have come to this Dhanbad, such a not a good communicated place, but still they have come there which has encouraged us to organize such few events in future. So keep up this spirit. With this, Jai Hind, Jai Bharat.
Thank you, sir. Now I would like to invite Shri S. Puttaraju, DGMS Electrical, for vote of thanks.
Good evening to all. On the dais, Honorable Respected Director General of Mine Safety, Sri Ujjwalta sir, and Sri R.T. Mandekar sir, Deputy Director General of Mine Safety, Udaipur, and Sri Ajay Singh sir, Deputy Director General of Mine Safety, Electrical HQ, Dhanbad. Of the dais, my Deputy Director General from various parts of the zone, Sri S.S. Prasad sir, and Meena sir, Sri Veer Pratap sir, HQ, Dhanbad, Sri Niraj Kumar sir, Sri Supriya Chakravarti sir, P.K. Singh sir, Sam M.D. Misra sir, and all my directors, colleagues, all deputy directors, and whoever the stakeholders from the different Coal India, from the metalliferous mines, and from the oil mines, and from here come from the different manufacturer side, like Sandvik, Mine Line, JMS, all the whoever that mine manufacturers, whoever come here, I am very much thankful to you have made a grand success in this function. So good evening to one and all, ladies and gentlemen. It is my proud privilege and a pleasant duty to deliver the vote of thanks on behalf of the Director General of Mine Safety, DGMS, Dhanbad. At the conclusion of this insightful and inspiring national seminar on futuristic approaches to electrification and automation in the mining industry, we are all truly honored to have hosted this landmark event that brought together some of the finest minds from the mining sector, academia, and industry. The discussions and deliberations today have been a testament to the collaborative spirit, forward-thinking mindset that will drive the future of mining in India. First and foremost, I extend our heartfelt gratitude to our chief guest, Sri Samiran Datta sir, Chairman and Managing Director of BCCL, and guest of honor, Sri Nirmalendu Kumar sir, Chairman and Managing Director of CCL, and one more guest of honor, Sri Arvind Kumar Misra sir, Director Simfer. So for sparing their valuable time to grace the occasion and share their visionary thoughts, your presence and encouraging words have truly added great value to the seminar. A very special thanks to all our distinguished speakers. They have come from the various states of our India, various states and different states, panelists and subject matter experts who shared their deep insights on the emerging trends in electrification, automation, digitalization, and safety in mining. Your expertise and presentations have been both thought-provoking and solution-oriented, giving us all much reflect upon. So I would like also to express sincere appreciation to the patron, DG sir, the organizing committee, my organizing committee. So I am personally very much thankful to the organizing committee. On that day, I hope there was a day, the July 10th. July 10th there was a meeting inside our meeting. The Honorable DG sir has just delivered. We have to do one tech. Ajay Singh sir was accepted. Okay sir, we will do. So within a span of almost 20 days, so we could be able to manage on the guidance and the support of Honorable Director General sir and my Deputy Director General and my committee members like Sri Maheshwar Reddy sir.
from the Director of Mine Safety, Southeastern Zone Ranchi. Among 13 papers, from 4 papers we have qualified from the CCL sector, because he was regularly following up with the concerned persons, and also he was guiding me also, and he was supporting during this program presentations. And also my colleague Sri Ratnakar Sir, Director of Mine Safety Mechanical from Ranchi, is also guided and supported me and in back end. And also my senior Sri T. Srinivas Sir, he supported and he guided for each and every pinpoint regarding. We are thoroughly day to day we are discussing what has to be done, what is the paper has come, what we are thoroughly monitoring. So I am very much thankful to Srinivas Sir, and also my colleague Sri Somajuru Sir. Somajuru, Director of Mine Safety, posted in Central Zone, for each and everything. Along with his colleagues, Deputy Directors, Sri Ashwani Kumar Saab, Chitreskar, Rupesh Mehato, all my colleague Sri Anil Topo, and also Mr. Sri Upadhyaya Saab, Sindhu Kumar Upadhyaya Saab, they are all dedicated, very dedicated and helpful to me to grant this the function and to grant success of this function. And also next, and also if I missing any names, sorry, I am sorry for that. But totally you have helped me to lot to success in this program. And also, and I forgot from the papers presentation given from ISM and also from Simfer and also different mining industry. And to our, I am lucky to announce, to our sponsors and collaborators, I am very much thankful to that lunch and snacks and breakfast, everything is sponsored by that Honorable CCL, CNMD, the team has been sponsored that, the snacks, lunch, everything they sponsored by us. And also, we took the small sponsorship from Sandvik and Gainwell and JMS also. And I am very much thankful to those teams are here. I am very much thankful to all the participants from across the country, industry professionals, researchers, students, students and their research. They are in the research fellows also. They are attended from the ISM. And policy makers, thank you for your active engagement, enthusiasm and insightful questions that enrich the seminar's dialogue. Lastly, I would like to thank the supporting staff from our DGMS, including contractual workers. They have put a lot of effort in cleaning inside, outside, along with our staff, guidance of the staff. And media teams, and also IT teams, admin team, everyone involved in logistics and hospitality. Your contributions, though often behind the curtain, have been invaluable. Let us all carry forward the learnings from today and work collaboratively towards a more efficient, automated and safer mining industry for India. Thank you all once again, and we look forward to continued dialogue and cooperation in the times to come. Thank you a lot. I wish you happy journey to those who are you have come from the different parts of the India. I'm wishing the happy journey in this occasion. Thanks a lot.
Thank you so much. Now, before concluding our program, we are going for national anthem. So, requesting all kindly stand up. And after this national anthem, requesting all DGMS officers to please be here for a group photograph. Keep mobiles on silent mode, please. Just before starting, let all put in silent mode.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे
Thank you so much. Tea and snacks are outside, and please don't forget to fill feedback form before your departure, please. Thank you.